Good morning, everybody. We will start in a couple of minutes. We are waiting for all to start, join.
Good morning, sir.
Yes, good morning, sir.
Huh?
ఇన్న చాక్లెట్ తప్పేస్తారు ఇంత నేను ముక్క ముక్క ఎక్కువ తింటుంటే దాన్ని
Good morning, sir.
Jemima, good morning. Please start.
Yes, sir. A very good morning to all the speakers and participants. This is your anchor, Jemima Paul, and I'll be anchoring the whole conference. Welcome to the International Conference for Bioinformatics and Data Science. As we are aware that the world is getting deep and growing more in science and technology, we have some amazing speakers who will drive us deep into the importance and necessity of bioinformatics and data science and clear our doubt. So, let us all be alert and welcome our first speaker, who is Dr. R. Someshkaran, Chairman of 4th ICBDS 2024. Welcome, sir. So your mic is mute.
Now, okay, I am audible?
Yes, sir, you are.
Okay. Very good morning to you.
Good morning, sir.
Now we shall start our...
Yes, sir, you can start.
Any
But,
introduction?
sir, can I just interrupt you?
Uh.
Yeah, I would request Prenon, sir, to please come up and just say some rules and regulations for the conference.
Okay.
Yeah. So,
The rules and regulations will come during the presenters times Jemima, we will start the conference now, and during the second half, we will do it. Please
Okay, sir.
continue, sir.
Okay, sorry, sir.
Sir, you can start, sir, with the presentation. Dr.
Okay.
Somshekhar, sir. Yes, sir.
Some introduction will be there, or just we can start? Okay. Bakchi. Shall I
Yes, sir.
start?
Yes, sir.
Okay. So very good morning, one and all present here. I welcome all the delegates for this 2 days international conference on bioinformatics and data sciences of 2024. Let us explore some of the important configurations with reference to our international conference. As we know, this bioinformatics, it is the interdisciplinary field combining biology, computer science, statistics, and analyze biological data. So this knowledge of bioinformatics especially uses for the acquisition, management, and analytics of biological information. And also, the findings of this bioinformatics can benefit healthcare, crop improvement, and biodiversity also. Similarly, as we know, this data science, the science of extracting knowledge and insights from structured and unstructured data. This includes genomics, that is identifying mutations linked diseases, proteomics, understanding protein interaction, drug discovery, that is assisted molecular docking. Especially we know this bioinformatics, it is nothing but storing, retrieving, organizing, and analyzing biological data. A major activity in bioinformatics is to develop software tools to generate useful biological knowledge. Over the past few decades, rapid developments in genomic and other molecular research technologies and developments in the information technologies have combined to produce a tremendous amount of information related to molecular biology. Bioinformatics is the name given to these mathematical and computing used to glean understanding of biological process. Common activities in bioinformatics include mapping and analyzing DNA and protein sequences, aligning different DNA and protein sequences to compare them, and creating and viewing 3D models of protein structure. So, why is it useful? The question arises because all of the information needed to build an organism is contained in its DNA, because our DNA is the one which reflects all the contents. If we understand that DNA, we would know how life works. How life works. Yes, preventing and curing diseases like cancer and inherited diseases, curing infectious diseases, including AIDS. If we understand how a microorganism works, we can figure out how to block it. Understanding genetic and evolutionary relationships between species, understanding genetic relationship between the humans. So these are all the different constituent matters with relation to bioinformatics and data sciences. So on behalf of our organization, I welcome all of you for this 2 days international conference and maximum utilize the resource talks and get benefited for your research activities. So I wish all of you happy stay and make use this 2 days conference quite fruitful and useful for your research activities, and come out with some more good information. In the coming years, we are also conducting like these conferences. We can share and grow together as a part of our work with the research activities. So I wish all of you all the best, and these 2 days, all our delegates can enrich their knowledge out of this conference. I wish all of you good and make the time more effectively. All the best for all of you. Thank you very much. Thank you.
Thank you so much, sir. It was a pleasure to have you. And thank you for taking your time for us.
Thank you. Thank you.
Yeah. Now I would like to welcome Dr. Satish R. Sankhe, who is currently affiliation with Associate Professor and HOD of Information Technology at Dr. G.Y. Patrikar College of CS and IT in MGM University, Chhatrapati Sambhaji Nagar. And he especially works at speech area, that is natural language processing challenges and emerging trends. And his research and key interest is signal processing, machine learning, data science, and natural language processing. And he's currently working with some project and publications. So he's currently working on one project, and more than 10 papers are published in international journal. So we would like to welcome you for this conference. Sir, you can take over the time now.
Thank you, Jima. Greetings to all of our online conference attendee. I feel so pumped that today we have joined on Zoom around the countries from different areas, and it is because of the technologies that we are able to get the conference getting connected. So I'm very much excited. I would like to bring to conference, first of all, say thank yous to the organizing committee chairperson, Dr. R. Somashekar, the convener, Pranay Bakshi, I would express my sincere gratitude to them also. And before I start, I once again congratulate the team member of Vishishta Academy Advanced Studies and Research for organizing such a beautiful conference on this being their 4th international conference on biometrics and data science. So can I start with the presentation, if permitted?
Yes, sir. Yes, sir. Proceed.
Yes,
Proceed.
sir, you can.
So should I share my screens?
Yes,
Yes.
sir.
Yes. Share the
Yes,
screen.
screen sharing is enabled. You can share, sir.
Okay. Is it available? You can see the complete screen.
Yes, sir. It is visible.
It's visible. Okay. So my today's topic is on natural language processing, challenges and opportunities that is there for the upcoming new researchers and all those who wanted to make a career with the research. So this is one of the best things that we are having. So this is what we have already discussed. So good morning, everybody. Once again, this is the things that we are supposed to start with the very first talk. The road to success starts with a single steps each morning. And that's what we have taken a one steps today confidently on this particular morning, joining everybody. So today my agenda will be, I will be starting with the introduction to NLP, AI, DL and linguistic. I will be going with that. Then I will be discussing about the potentials of NLP and its market share globally. After that, we will be discussing about the benefits and industry leverages of the NLP. We will also see for the beginners, because those who are new to this, the NLP flow diagrams, and then we will discuss the challenges that is being faced in this area. And lastly, we will be discussing a case study where we will be putting an examples of how the NLP is going to work with the health sciences. Bioinformatics is one of that part, but then I didn't get much about the bioinformatics, so I could not speak much about that. But then I will try to have the things related to health science, how the health sciences will be the part of bioinformatics. And that is what we are going to see. So first thing, that whenever we communicate, so the biggest communication problem is we do not listen, especially listen to understand. Normally what happens, we listen to reply, and this is where our machines are there in NLP. That machines tries to do will be listening, then understanding, and then responding. This is what the best thing is there, and this is what NLP does. So we will see the best thing here. Linguistic in NLP, most important is the language. As you know, language has been most powerful tool which has made us human more efficient and effective living being when it comes to communicating anything meaningful that we are having. Okay, it is our ability to perceive anything external as an image on an expression given by the individuals, and visualize those memories through voices based on the understanding of the language, which we have learned since ages, that made us special living beings on this mother earth. Okay, being alive in the 21st century is really a boon. Largely, this is because of the technological advancement. Like in the very first thing I told you, that it was possible for us to meet so many peoples from different parts of the countries through the technology only. Okay, we have with the help of the technologies, now we have trained our powerful gadgets and machines to have their own virtual intelligence and understand and execute to human originated tasks. Okay, without much human intervention. And natural language processing has been one such technological advancement that has empowered our machines to understand, communicate the language we human speak in much efficient and effective manners. So NLP is the branch, I can say, that is branch of computer science. To be more effective, I can say it is branch of AI, which is concerned with giving computers the ability to understand text and spoken words in much the same way as human being can do. This is the technological use of the machine, that is to understand, analyze, manipulate, and interpret human language. So basically what the NLP is going to consist of, NLP is not the single things, but it is a technology of so many things that is there. So very first thing, first part of NLP is the linguistic. Linguistic is the growing and interesting area of study, having direct hearing on fields as diverse on education, anthropology, sociology, language teaching, cognitive psychology, physiology. Fundamentally, what I can say, that it is concerned about the languages and communications. It is not, it is the scientific study of a particular language, not about the particular language. So NLP deals not only about the Hindi, Marathi, French, or something like that. Linguistic is there for all general languages, general rules. So that is the key part of this particular thing. Then second part of this NLP is the statistical model. So using a statistical model and technique, it helps extract the meaningful information and patterns from the language data, which benefits the system to understand our human language. So that is also the one of the parts. Then another important is the machine learning is the foundation part of the NLP. Machine learning algorithms with the deep learning are helping to understand and then get the data. So this is the most important, that is what we can say. NLP combines computer linguistics, statistical, machine learning, and deep learning together to give us an NLP. Next, we are going to see about the what is the potential, because normally we deal with the things, we go for certain things, or researchers go with the benefits. So we are going to see that. Now, as per the study of Grandview Research Corporation, San Francisco company, the global natural language processing market is going to be having a revenue of NLP more than around $450 billion by 2030. So this is the huge amount of things for a particular any sector, which I can say that it is more than the money that is currently, if you can think of the currently the amount of money that is having by the Jeff Bezos, Elon Musk. Okay, so they are having the money that is they are bearing, Elon Musk, is nearly the same. Jeff Bezos and Larry Ellison together will have this much amount today. So you can think of what is the future. You can think with the revenue that is going to be generated. The growth rate of NLP as predicted is at the rate of 40.4. When we talk about FD, or when we talk about any particular thing, like FD is gives you at the max 7%, 8%. Some of the mutual funds gives 10%. If we go with the share market, there will be hardly 15% growth is there. But NLP will be growing at the rate of 40.4. So that is the biggest advantage to us. US or United States is the largest shareholder currently in 2024. It was having a largest shareholder in the things, whereas according to the same survey, we as Asia and Pacific is the fastest growing region. Okay, this is the fastest growing region that is having. So as a part of Asia Pacific, India's share is currently in 2023, it was around 6.5. But the growth rate expected, although you know that technological we are not very strong, but still it is, with the help of our researchers, now it will be at the rate of 27.57 growth rate is expected. And we will be one of the major contributors in the NLP. You can see the markets, even the markets that is showing the potential markets. Already the Canada and US is already having a huge market, but China and India will be flourishing their things in the applications, product and geography. Okay. Now, with this, we will be also discussing about the top key players, or I can say the top key players in the NLP. So NLP, as I told you, that is, it is going to have the compound accelerated growth rate of 40%, but in the hybrid, it is divided with the rule-based, statistical and hybrid. So you can see that this is 41.49% is there. The key companies that is associated with NLP are Microsoft, Google, AWS, Intel, 3M. These are the key markets there. But what I can divide this, I can divide this companies or key players in different zones. What I can do is I can make them based on how they are providing the services to them. Like we have some of the companies which is there with the platform providers. Platform providers are like IBM, Oracle, OpenAI, with AI, Rasa. Okay, so these were some of the companies which are providing a platform to the NLP. Whereas we are also having a service providers companies like SAS is there, Infosys is there, Wipro is there. Just yesterday's yesterday's news, I have heard that Wipro survey server Azim Premji has purchased a new company in the US market, AVT, which is of $40 million, $45 billion company they have purchased, and that is because of this NLP and technological growth. So you can see that how the market is growing with this. We are also having the software providers. We will require some softwares. So that is there by the 3M, Lexatical, Amenities, Inventor, Rapid Miners are there. Then there are some of the frameworks and toolkits are there for the developers. They can use to go with the new ideas and the new areas, explore those things. With the NLPs, SPACY, NLTK tool is there, Gensim tool is there, and TextBomb is also there. Then we are having end users, which is helping all these 4 companies to reach to the end users, either with the help of the Twitters, X, or I can say Amazon, Google, Meta, that is WhatsApp, and definitely all the things has to be under the regulatory bodies. So we are also having the regulatory bodies which will be controlling the flow of this particular thing. By 2025, I can say that more than 85% big businesses plans to implement the NLP. NLP is growth is driven by something that we believe region that is there is growing region, growing use of AI, artificial intelligence, in goods as well as in services. So in majority of the sectors, we can see that everywhere we have started using the AI. Uptakes of the technologies in the majority of the sectors with the adoption of industry 4.0, it is expected to support robust growth of business operating in various industries. The automation of the market and sales process, use of analytics has enabled managers with greater ability to make data-driven decisions in the areas of forecasting, territory management, decisions. Smart products are being there. Now you can see that so many smart products are coming. We are using it, voice assisted devices, even in our homes. We are having washing machines, TVs, complete home control, everything is there. So we are using the Siri and Alexa, that is there. So that is the one of the reasons, that is what is happening. And the customers, that is what the competition is there, competitions to offer the greatest customer experience. So everybody wants that they should have the customers, because customers are the key to any business to grow. In addition to this, due to as our chairman has said, that there is a continuous growth of digital data, that is proliferation of data, huge volume of structured and unstructured data is there, and that is also one of the reasons why the NLP is having so much in demand. And last but not least, it is the accessibility of the affordable cloud solutions. Okay, so now the cloud-based solutions are very easily available. We are able to purchase the things which was there in the markets at higher rates. Now the rates have come down, and even small companies can think of a solution for their customers. So that is the reasons, that is what is happening. Next, I will be discussing about the benefits of the NLPs. So NLP is the key benefits of NLP is what I can say. It is to analyze larger data set in the sense that we have a large set of unstructured data, which is we are receiving from the documents, survey, maybe the customers' reviews, emails, news, reports, social media, etc. So to process this data manually, it would take days or even weeks for conventional computer analyze this data. But with the help of NLP, we can do this efficiently and accurately. So that is the one of the reasons why NLP is there. So that is what the increased documentation efficiency is there, and it is a big things. Another important kind of benefit is the capability to automatically create a summary of large and complex textual data. That is one more task which can be done by the help of NLP, and which is helping the things grow at a rapid rate. We are also having, as a human, what I can say, to perform a repetitive task, be it reading, processing, or analyzing, one to many text-based data, human tends to lose the ability to focus on certain points. And then there is a chances that we may make mistakes or do something based on their personal emotionals. This is why we can now depends on the NLP, and NLP can do this text-based data processing and give us more clear ideas without stopping, and in a complete sense they can do it. So it can do the analyzing of data at a faster rate, and that too correct. It is also helping the customer experience. So leaving a customer, I can say leaving a customer in cold or not responding to their queries immediately is one of the main reasons behind every company's downfall. We have seen so many companies that have gone down because of this particular reason. So detecting a potential crisis involved in comprehensive understanding of customers' behavior. Okay. And what these customers says about the product, about the services. The NLP tools are there available, which can be used to help and respond immediately to the customers. And it is expected that as per the last survey, the US were able to get around $1 million per year. Okay, you can think that that is a huge amount is there. US dollars, $1 million annually. They are saving because of use of AI chatbots and NLP have businesses. So you can think that in near future, this amount can keep increasing. Last one or more sector is there, that is extract and the actionable insights is there. So we can have one more thing that related with the brands and products and services, we can analyze the social media and conversation online and perform the sentimental analysis. That is possible with the help of the NLPs, and this is why the things are in demand. So NLP is having a huge demand. Next, I will be discussing about the industrial leverages. Leverages, as you know, it is related with the what I can say, the company is taking a loan type of things and then putting it in the market, and this is not done unless they see the benefits. So this is why the different industries are coming up, and now they are joining the NLPs. So when we say industry, the very first name that comes to our mind is the industries that is related with the machine manufacturing. So in manufacturing industries, with the help of the NLPs, we are having, we can get the automated machine health monitors and detect the, have the, what I can say, health monitoring and defects that is there with the machines that can be done. Then it can also help be used in real-time process analysis. Another very important areas that is manufacturing industry is looking at is optimizing the delivery routes and schedule of the fleet management. So with the help of the NLPs, we are getting this technologies more there, and better workers and workspace with the help of the predictive knowledge is there. So that is where the one of the industries is there. We are also using with the yeah, Jima, is there something? Just you tell me if I'm having a time or something like that.
No, sir, you can take your time.
Okay. Right. Then the another area that we are having is the entertainment and advertising agency, which is the one of the key areas where the revenues can be generated, and especially it is related with the content personalization and delivery of the vernacular content. Everybody wants to be on the Twitter and everybody wants to be in the highlighted format. So for that content development, with the help of the NLPs, we can do that. That is what the things is there. Then we have precision analysis and targeting of the user's persona. We can get connected, or the markets can find out who are the target employees or who are the target customers, that they can get connected. So that will be helping them out in the market industry, market search, and they will be also knowing the trends. And because whenever we post so many things, so from the post that comes, things are coming. So that is one of the things that is there in the industries. Then another area that is there is the retail industries, where with the help of retail industries, basically the retail industry is dealing directly with the customers. So they can use with the help of the NLP tools, precise recommendation engines can be used by them. They are providing the voice search optimizations. Like if I come to Bengaluru, I may not be knowing certain areas. So with the help of the NLP, even with the voice talk, I can just very easily go through it and find the things that is near future. One more thing that we can do is, even if some of the things that is written in some other languages, with the help of the NLP tools, we are able to convert it into the languages which I know. So that is also one of the benefits that we are getting. So that is what the location-based services suggestions can be given by them. And definitely that what I told about the user, first-time users discount and more things are added by the NLP service providers. Like if you are a normal users and every time you are using a phone pay, you will get an ad with the GPay or Paytm to use it and try our things, so that you will get a discount. Something like this is provided by them. So for that we are using the social media marketing. So from the social medias, we are taking the text and whatever the things they are putting, that is we have generated comments and all those things. From that they can get the things. Healthcare, which is related with the bioinformatics and biotechnologies, students are there because more of the students are there. So in that, it is in the healthcare, NLP is used to extract the insight from the medical record, analysis of unstructured data. This is one of the key areas, and this I will be showing how it is used with during my case study. Even it can be used in the healthcare. Personalized the clinical decision support systems can be developed. We can have the optimized chatbot, just like we are having a chat GPT. Chat bot is there for especially for the patients. Patient we can have, and which will be guiding them throughout. They are giving the information about that. We can also monitor, predict, mitigate adverse drug reactions and pharmacovigilance strategies, and many more things. Like even NLP can help us with this type of things in the market. And lastly, in the finance and technology will be there. Optimize the risk management and fraud detections. For that, NLP is used. We can use the assessment of credit worthiness for the individuals for the finance. This is there. We can also have the personalization of the financial products. We can also, with the help of the NLP tools, which is helping us out to predict the things. So that can be also seen with this. Is there. Then we will be discussing about the workflow, how basically the things are there. So in NLP, like we have seen so many industry leverages and how the things are there. So how the workflow is there that we are going to see here. So basically what we are having is should be the input. The NLP system is very simple. There is an input and there is an output. Input is the sentence, the documents, an image, or the things that we say to the computers. And output is what the computer has understood what we wanted to say. So that is only the things, that's very simple things. But then in between, there are some processes. So first process that is there is the morphological processing, where we want to convert the documents or images, speech or anything into a text format. And from the text or a sentence, we are going to divide this into what I can say, words. So suppose if I say the word like I have said a sentence, good morning everybody. So I have said good morning everybody. So like this dividing of the sentences, that is what we call it as a tokenizations. This process is being carried out. Even in some of the examples, I have to think of like unhappy. So this is basically the two words are there, although we are seeing it as one word. So in the tokenizations, we are supposed to divide it with the help of un and this tokenizations. So that is what the process is there. With the help of this, we are also dividing it into next areas in the syntax analysis, where we are discussing about the word arrangement, how the words are arranged in the sentences, and it is used to what we can say, it is a twofold things are there, where we are checking the well-formedness or corrective, how correct the sentence is there. Like a simple example I can give, Ramesh goes to school is the correct sentence. But if I say school goes to Ramesh, then it may be able to divide the tokenizations, tokens can be divided, but then in the syntax analysis, I should be able to get the things that this sentence is not correct. So this is the role of the syntax analysis, where it gives me, it shows the relationships, and with the help of here, I am also able to do the one more thing in the syntax and syntactic analysis parsing. We are doing with the help of POS, that is parts of speech. We are dividing every words in different parts, whether it is a noun form, whether it is a verb form, and all those things. And just like we are having a mathematical rules, there are rules related with the languages which help us to arrange a sentence and then tell whether it is grammatically correct or not. So that is also one of the important part in the syntax analysis that is we are doing. The next phase of the NLP is the semantic analysis, where we are trying to get the meanings, literal words meanings. So that is helping us out and helps to find out whether the words used are meaningful or not meaningful, semantically it is correct or not. Just like we are having in the programming languages, the syntax error and logical errors. So similarly, while we talk, while the machine understands, there are maybe some semantic analysis is required to be done. So here we can have that as a this part where we are performing a semanization and lemmatization. Like when if I say the example, the fisherman went to bank. So this sentence would be something like, you will be in the confusion that when I say the fisherman, you may think that he is going to the nearby the river. But when I say If I add the next part to withdraw money, automatically the reference of that words changes. And this is what is being done in the semantic processes while understanding the natural language processing. Next is the discourse integration. Discourse integration is to find some of the sentences which is having the meanings and understanding the meanings of that sentence based on the previous sentence used or the next sentence that is we are using. So that is also the part of discourse integration. And last one is the pragmatic analysis. That is the 5 steps that is being done in the NLP, which we are using for this. And after this, we get the final output, that is the target representations. This is what the things are happening. I will just the same thing we have just explained this, so I will not go in once again the detail of this. That is what I have explained. Syntactic analysis, draw the exact meaning. Pragmatic analysis is there, and then sentiment analysis is there. That is just detecting the polarity of the words, whether I'm positive or negative, or whether that is a neutral or something like that, is helping me out. Now, before I start, I will just go through one of the things. Just give me 1 minute. I just wanted to. Now I think you must be able to see the complete screen is there.
Yes,
Is
sir.
it visible?
Yes, sir.
Yes, sir.
Yeah, yeah.
No, that is the PPT screen.
Yeah, yeah. Just I wanted to show one of the things that is there. Because we also have the things that yeah, you can see this. Everybody must have seen this video. I don't say that you have not seen. Just listen to the what is saying.
यहाँ तो बोलते कुछ है पर मतलब कुछ और निकलता है। एक एक शब्द के 4-4 मतलब ऐसे मुंडी रहो और बोलो अच्छा है मतलब सब ठीक ठाक है, वेरी गुड। आंख बड़ी करके बोलो अच्छा है तो मतलब साफ में है। तुम्हारी अम्मा का एक्सेंट हो गया अच्छा साफ, फिर गुस्सा आता है तो आवाज लॉर्ड हो जाती है। अच्छा हमको सिखा दिया है अच्छा।
So you have seen that this is what the things are there. The same words are there, and we are having this. This is what the challenges are there. So I will just a little break was there that was related with the things. But then hope you have seen that videos. So the challenges related with the thing that we have the one words and human beings speak in different ways that or we are not what exactly the words is there. It depends on the slang, the regional dialects, social context, and what I can say is one more thing, that is how we are putting us saying that things. So that is making the difference. So that is the biggest challenge for the machine to understand. As a human being, we are able to see them in person, and we are able to very easily find out the things. So that is very easy for us. But for the machine to understand the acha hai itself becomes really difficult. And that is what one of the challenges of related with the machine is there. Next is the evolving languages there. Like every language, whatever the language we are talking about, the languages keep on evolving. The way people use it, it is continuously changing. Rules that was working properly in some years back may become obsolete, and new words like keeps on coming. Like if I say that just 5 years back, if I move my cycle back to 5 years before, nobody has heard about the word corona, and now everybody knows. So like this, new words are keep on coming with the help of the corona. Due to the corona, we have got so many new words are there, remdesivir and so many injections, and I've gone to number of terminologies are there. Similarly, we are having a WhatsApp, and these are some of the technologies. Some new words are keep on adding, and some words gets absolutes in the language. So that is also one of the things that we are supposed to keep in mind when we are developing a NLP tool. And this is the reason why the development time to train or to make a tool of NLP becomes difficult. So the total time taken to develop an NLP system is quite higher as compared to any other systems, and AI evaluates the data, or more precisely, I can say the extension of the time is just because of these reasons that is there. In addition to that, we are also having the training time, because training time I have to consider one of the biggest challenges is there with the natural language processing is inaccurate training data. So if we don't provide a training data properly, the system cannot work correctly, or we can get wrong data, and wrong assumptions can be there. That may be there with this. Another things that is there with this is the one more challenge is there, that is the misspellings. Human makes spelling mistakes that can be difficult to interpret. Just like I can say HEARD, heard, and HEART, heard and heard. Somebody may not be able to get the things, and if he writes incorrectly, the meaning itself gets changed. So you can see that some normal times when we don't know the spelling, we just write it randomly, and then so that is the challenge where the NLP has to work, and it has to progress, make that technology and identify the spellings, misspellings related with this. So that is one more things is there, and all these things are there with the help of the diverse languages also. Once because we cannot NLP is related with all the other languages. It is there with the different languages, linguistic itself, like I told you in the starting itself, and we know that nearly 7,000 more than 7,000 officially languages are there in the worldwide. So to deal with this huge potential is there, and everybody can start thinking their own way to develop the NLP. Another reasons where challenge is there, that is the ambiguity is there. Ambiguity in the NLP refers to the sentences and phrases that have potentially two or more meanings are there. Like just now we have seen the words bank. Similarly, we can also talk about the word bark. So bark is having two different meanings. Like bark is the dog barks, and tree is also having a bark. So we get this type of ambiguities are there. That is a legs we are having. So number of ambiguities can be there. Some are things related with the lexicals. Like we have the word round, which can be used as a verb, as a noun, or as an adjective. So one words, but with the at different places. This is causing the ambiguities in the NLP. So that is one more challenge is there. Then we have semantic ambiguity is also there, and syntactic ambiguity is also there. And lastly, homonyms are there. That is the same as what the things are there, where we are having the words with the different meanings. Okay. Then I will be showing you this one of the demos. This is there. Let me show it to you. This is the NLP example that is we are having. If everybody is able to see the screens, is the screen visible?
Yes, sir, it is visible.
Yeah.
Yes,
So
sir, you can
we
conclude in
have
another
shots.
2-3 minutes, sir. Please wind
Huh?
down. And now our next speaker is waiting. You can conclude in a few minutes.
Yeah, yeah. I will just having a medical exploring the things. Here you can see that we are having this things where we can do the summarization of this text is there. What I was telling about in the medical. Then we can also have the question answers type of things. So based on this, if the question is asked, this is what the things it can be shown here. Okay. We are also having the things that is putting related with the clinical things are there. So I will just show you one more things are there. And here we are having a text generations also. Text generation is there that we are having. So this is medical entities that we can find out in the sentences that can be used with the NLPs. That is there. So currently, I think it is. We are not able to see this. So we have to be more careful about. Okay, so I'll just conclude this things. Actually, I have got one. So NLP is just, I will conclude here. And before concluding, I will put the just final remark that NLP is the both once again, NLP is the part of AI, and both are having so many better prospectus, so many things are there that can be, we can use it, researchers can go with this for the research purpose and everything. We can have so many applications are there. Definitely you must have got the areas where we can work with the NLPs that can be there. So thank you. And once again, thanks to the organizing committee, Vinay sir, for giving me an opportunity to give that talk. So I request now it's over to you, sir. If anybody is having any questions, we can have that. Thank you.
Yeah, thank you so much, sir. If anybody is having any questions, quick question we can take before we can move ahead to with the next speaker.
I guess there is no question for now. Irfan, sir, is there any question you want to ask?
Yes, sir. Good morning, sir. Good morning, everybody. So, sir, very nice presentation. Actually, it was a great insight about NLP. I just wanted to know a little bit about, how we can relate this text analytics or, text analytics in NLP. So, whatever you have explained is all about the text. We are analyzing the text. Any insights about how to analyze the audio? How we can analyze the audio, video, because you know that these audio videos are more popular than text now. So maybe in coming years or in future, we have to take care of audio and video visuals also for our analytic purpose. What do you, sir?
Right. A very nice question. Basically, NLP deals with the language in the sense audio as well as the text. But whatever the audio is there, that will be converted into a text form, and then it will be processed, and the steps that I have given you, with the help of those steps, it is able to understand. Just like when we talk with the Siri or with the Alexa, so it is converting that, trying to understand those things in the mind. It is doing the computation and then reverting back to our answers, just like we do in our mind. Whenever somebody tells us or somebody speaks to us, we first of all try to understand what the person has said, and after that we are there to respond. So same thing in the machine will be done. So that audio will be converted into that form, and then it will be using the same process, it will be analyzed, and once again it will be converted, the text will be converted into audio as the output also. So output also we will be getting in the sentence.
Very much understood, sir. Thank you, sir. Thank you.
Thank you so much. Any more doubts?
No.
Okay. Thank you so much, sir, for taking your time and coming and joining this conference. It was indeed very informative for us. Thank you.
Thank you.
Now I would like to welcome our next speaker, Dr. Prashant and Surajala, who is an expert in bioinformatics and system genomics, who has experience over 20 years in functional genomics, protein informatives, and medical genomics. And he's currently serving as principal scientist at Amrita School of Biotechnology, Kerala. He has led numerous projects on next generation sequencing, that is NGS, and rare disease genomics. Dr. Surajala holds a PhD in systems biology and also conducted extensive postdoctoral research globally. He is a prolific author with over 100 reviewed publications, an H-index of 28, and a proven track record of mentoring PhD students and postdocs. Recognized with multiple awards, including the Amrita Innovation and Research Award. He is also a key organizer of International Bioinformatics Conference, further showcasing his leadership and dedication to advancing bioinformatics education and research. It's indeed our pleasure to welcome you, sir. Welcome to the conference. The time is to you.
Oh, thank you so much for a lovely introduction, Jimema. That was, very kind of you. Thank you so much. I hope my voice is audible, and I'm not able to share my screen because the previous speaker, Dr.
Oh yeah, he
Sankhya.
did not off his screen.
Please, yeah.
One moment.
Please, yeah. I think it's first of all, I would like to thank Preenan Bakshi for his wonderful introduction and also inviting me for this gracious conference. He sent me an email almost 6 months ago, and I bookmarked my calendar for this lovely conference that he has been organizing over the years. And also Basis Genomics, and also the previous speaker, and also Somashekar, who is the head of the institute, for this, lovely, opening remarks. So I hope you can see my screen and see my full screen, maybe, if there is there. Can you all see my full screen, please? And is my voice audible? Yeah.
Yes, sir. Your screen
Yeah.
voice is audible.
Yeah, thank you so much. So what I'll do the next probably 35-40 minutes is I'll split my talk into probably 2 to 3 parts, and I've given a kind of a broader title, but I'll be speaking a large amount of the CA prostate work that we have been doing over the last 8 years through the consortium that I founded through BioClues. So interim, since it's a bioinformatics and data science conference, I thought I'll probably try to delve upon how did we bridge the gap between biologists and data scientists. That way, we have science meeting serendipity. So I'll give some kind of reflections that we are going through as a part of our case studies. So friends, we are celebrating 75 years of our constitution, and also, of course, 78 years of Azadi Ka Amrit Mahotsav. What a great year it has been so far in 2024. We have Nobel Prizes won for bioinformatics, and the first five Nobel Prizes have got a large amount of data science, right from physiology or medicine to physics to chemistry. Of course, looking into the artificial intelligence, and also the Peace and the Literature Prize having some kind of data science, to a larger extent. So when we say data, we need these computers. This was one of those particular cartoons that was appearing in Nature and Science way back in 2001, when a large amount of genomics is being put up. We thought that the computers would crash genomics. But I think it's the other way around. We have been catapulting both genomics and computers together, and thanks to the wonderful, excellent bioinformatics scientists we have, where we are able to fight and resist the Moore's law. So this is our lovely campus in Amritapuri, and our chancellor is Revered Mata Amritanandamayi, and our dean is Bipin Nair, and we have about 40 plus academic staff, and about now about 50 PhD fellows, and over 600 students. This is where we live. This is a beautiful Southwest Malabar coast, and this is our lovely campus, and our university is ranked the best in India among the private institutes. So I'm grateful to my 4Gs. When I say 4Gs, one is of course the Gurus, and of course Gandhiji. I'm a big fan of Mahatma Gandhi. That's because he's a man of open access. He has given everything for free, and we were celebrating his 150 years of birth anniversary in 2019. And of course genomes, and of course Galaxy, which has been a wonderful resource where James Taylor, who founded it and who unfortunately passed away a couple of years ago. And our works over the years, have been published in the cover page, and one of these papers on the first next generation sequencing approach in India was with Cancer Research Institute from Adyar, where we published, the next generation sequencing approaches with respect to smokers who acquired lung cancer and never smokers who acquired lung cancers and vice versa. And this was, put up and appreciated by ICMR, and this is where, we have taken up. But over the years, there is something called, what you call epistemology. Epistemology for data scientists, I need not explain. Epistemology is nothing but how we derive the knowledge, how we respect each other, how we bring, that kind of, scientific camaraderie, whenever we speak science. And if you see here, these are the lovely ants, that we have, and we can learn a lot, from these ants, if you can think of. Ants need not be told how to respect each other, how to have a wonderful camaraderie, how to bring up, those kind of, scientific, what do you call, revelations or scientific gestures. So if you might have seen, there's a big be of ant line whenever you walk on the road or whenever you walk on your floor or anywhere. And if one ant dies in between, what happens is the ants never miss the boat. Okay, they have only one thing, because there's a queen who is driving them, and the drones ensure that they listen to what the master says. And in between, if one ant dies, there are a few ants, they mourn in pain, and then they take the corpse and they bury those particular corpse elsewhere. But in milieu, the kind of, beeline is not stopped. So that is where, the lovely ant colony approach, works in. And I'm sure the previous speaker, also has delved into these kind of things. At the end of the day, many of these data enriching algorithms, including the workflows or the NLPs, they work on something what we call it as ant colony algorithms. So today I'll try to give you about introduction to systems genomics. What is systems genomics? How as a biologist, or as a proteomicist, I embrace systems genomics, and the kind of prostate cancer based approaches that I've been working over the years. And of course, the third part I'll work on working towards the student community, what and how through BioClues we have been enriching over the last 20 years. And of course, I'll be very happy to take up some kind of questions. So friends, whenever we talk about a system can be anything. So maybe you're talking about a Zoom. Today we are all listening through Zoom. A Zoom can be a system. Likewise, our body parts all entail in a system. And these systems make up a large amount of context. And these particular contexts are specific from one individual to the other individual, be it plants, animals, bacteria, or humans. Whenever we take plants are sessile, they make up some kind of stress traits. Whenever we take about bacteria, they might be monoisolate or multi-isolate or pathogenic or non-pathogenic, sometimes host-specific or host non-specific. Sometimes animals, they might be having feed efficiency traits, or fur, which is the skin. They might be acquiring different traits. And we humans are always born with respect to variable interpretation of traits through different epigenetic measures, which means if I'm there, if I'm fat, or if I'm tall, there might be traits that might be pre-existing, that is written right from my parental genotypes to the offsprings that have been derived. And that's where what we call it as a phenome. A phenome is nothing but a characteristic entity of phenotypes. So what I'm just trying to convince you here is, whenever we have these specific contexts, this context keep changing because of the environment, and that's where we are trying to get tremendous data input in the form of true positives, the false positives, the true negatives, and the false negatives. And that's where the central dogma of bioinformatics comes into picture. Sequence predicts structure, structure predicts function. And at the end of the day, we are to describe something what we call it as a function. That's where we can have a large amount of interfacial residues at the helm of this kind of opening the structure. That's where we can have a drug or a ligand that can bind to these particular regions, and that's where we can take up a central dogma. But I would say since systems genomics is an integrated part of the biology of a system, and over the years, there have been a large amount of epigenetic fluxes that has happened within the organismal structure. Let's take the recent SARS-CoV-2. You might have seen the 19 different variants, including the variants of concern that have evolved. That's because there have been a large amount of mutations that have been coming up within the 29.9 kb genome size, which is pretty small. And a large amount of mutations have irradiated right from MERS-CoV-2 to SARS-CoV-1 to SARS-CoV-2. Okay. But in milieu, you expect these amount of mutations, they keep arising and falling. And as a result, the number of genomic repertoire where we tend to see the proteins that keep on interacting with each other. And at the end of the day, over the years, there might be some kind of genes that might have really lost and found. You don't expect the complete gene to be lost, but you expect a large amount of synonymous and non-synonymous mutations. And if there are non-synonymous mutations, obviously you expect those particular proteins to be changed, and as a result, the function of those particular proteins might completely change, and as a result, new species carve out. So what I'm just going to describe as a part of my first part of the talk is, over the last 8 years, we have collected about 143 samples to be precise for CA prostate. And I'll probably tell you one important story how I got into this prostate cancer. Until 2014, I was working on colorectal cancers as a part of my several postdocs and PhDs. But as you can see in this picture, this was our animal systems genomics lab. This was a department of zoology where a large amount of animals are fed with grass. So these cows, buffaloes, and oxen are fed, are overfed, in fact. And one of my colleagues sitting next to me was a PhD fellow in my postdoc lab in Haji Qadamuddin's lab. So what he would do is he would overfeed these cows and ask a very pertinent question: what happens to the to these particular animals? Would they probably give more milk, or would they probably give more semen in case of oxen or bulls? That was a question that he would ask. So if we really take this in analogy to humans, one of the major questions that we could ask is, if we eat normally, okay, maybe a person might be with a normal BMI or with a normal this thing, so he would remain healthy. If we eat less, there might be a person who is very thin, he remains unhealthy. And if there is a person who eats in optimal time intervals, which means we are not inviting any binge eating, we are eating small quantities every, say, couple of hours, then of course the person would again remain very healthy. But what we have discovered over the years is, especially for the Indian phenotypes, if we are eating too much, we not only invite a disease, or we not only become unhealthy, we become obese. And that obesity is inviting something what we call it as a prostate cancer in elderly gentlemen. This was not only proven by us, but also proven by many other labs across the Caucasian population. Unfortunately, not from India. And that is where our interest lies in, and that is where I founded CAPSI, which is a CA Prostate Consortium of India, with about 32 wonderful scientists across 6 different countries. And from the 143 samples that we have collected, we have published a good number of papers. And one of the major discoveries that we have found is that vegetarians are at a risk of CA prostate. And thanks to our wonderful PhD fellows, in fact, there were 3 PhD fellows who I've done wonderful works in this particular area over the last 8 years. So then you might wonder, what is CA prostate? CA is a cancer adenocarcinoma of prostate. Prostate is a little gland that keeps on bulging as we age, and 1 in 9 men are diagnosed with prostate cancer during their lifetime. And prostate is the second leading cause of death globally, and the third most prevalent cancer in India after the oral or the gingivobuccal cancer caused due to tobacco, and the second one is of course the breast cancer. And the third one is that the Globocan, which is the global cancer indices, also indicate that there has been a rapid aging population or a geriatric population where there has been a declining fertility, and that's where because of declining fertility rates, there might be an index that might be populated with respect to obesity and prostate cancer. So when I moved back to India in 2016, I was at Birla Institute of Scientific Research, and this is where we have developed a wonderful initial pipeline. Now this particular pipeline is downloaded and benchmarked and commercialized by a couple of companies as well. It's already there in the market. But what basically, as a systems genomicist, what we asked was, can we help naive biologists to overcome the fear of running certain pipelines, because between them they have a large amount of data, and these particular files are anywhere between 6 GB to sometimes 80 GB files, which are very big. Okay, you need big servers, so you need something what we call as a FASTQ files that needs to give you the phenotype genotype correlation, where you need to get what are those particular SNPs or single nucleotide variants that are present in those particular population. And that's where our Meena et al. Paper in 2018 was published in Bioprotocol, which was downloaded about 60,000 times so far. But I'll not delve into the pipeline today. What I'll just discuss is about the results. What is that we have discovered with respect to the prostate cancer. So we have some high impact variants which we have discovered in high grade prostate cancer tumors that are specific to Indian subpopulation. So as you could see, these are the cases and these are the controls. And the circle ones are all those particular genes where CA prostate is seen in Indian phenotype, whereas the genes in the square boxes are largely seen in the West or the Caucasian population. But that is not the end of the day. What is most surprising is, if you can see here, say for example, CTNS, which is a gene which harbors a wonderful single nucleotide variant that is predisposable to vitamin D deficiency. The same CTNS is also known to be largely associated with what you call atherosclerosis, and also some kind of osteoarthritis, with bone ligament dysfunction. But we also discovered some mutations sitting in TP53 and COL6CA1, which is a well-known tumor suppressor gene, and also some mitochondrial dysfunctions, and with respect to OPA1 and EDA and SCN9A. So the commonality that we see here over the years that we are trying to talk here is, are we Indians, at a risk of, some kind of predisposable mutations that are known because of the diet factors, because of, whatever, that we wanted to discover or we wanted to, identify. So that's where, our preliminary conclusions here is. So interestingly, the preliminary results that we have shown, all the patients were all vegetarians. In fact, only 1 or 2 of them were lacto-ovo vegetarians, which means they would probably eat eggs and drink milk. And yet, they were prostate victims, unlike the good old theory that, prostate is only seen in the non-vegetarian, people. And then we found mutations that are relevant to obesity, diet, and mitochondrial dysfunction, and of course, vitamin D deficiency, some tumor suppressors, and of course, some copy number variants, which are large structural variants. And our pipeline, interestingly, could capture those copy number variants. And of course, we developed a conceptual framework for mutations where, the data that is obtained from this, the humongous data that is obtained from these particular samples were analyzed, for a downstream analysis. So that's where our part 2 comes in. So okay, we have just discovered mutations in some subpopulation, largely coming from the North Indian registry. So we asked a question whether or not any of these prostate cancer genes are regulatory in nature. Okay, so regulatory in nature is nothing but can we come up with a genome walking story? That's where we are trying to delve upon. So what we have done was, so let's assume we have a mutation here. We asked what are those particular regulatory regions or regulatory SNPs that are surrounding a mutation at this particular locale. So for example, if there is a SNP here, are there any regulatory SNPs that are present further 5' upstream region of this? These regulatory SNPs could be either long non-coding RNAs, which means you expect a genetic variation sitting in the non-coding regions, or any of the CTCF motifs which are regulatory, or even the open chromatin elements, or even the enhancers that are sitting further upstream of those particular regions. And then you might ask a question, Prash, why? Why is that those regulatory SNPs play a very important role? That's because if a SNP is present in the 5' upstream region, you expect those SNPs to be largely detrimental to that particular phenotype. And that's where we have validated those particular SNPs, and we found a mutation that is seen in the long non-coding RNAs. And we also observed that long non-coding RNA is also known to be interacting with a protein of that particular interest. And then we are still working on these kind of things on larger population, although this particular population was done, this particular population study was done only on 6 samples, because we need to extract RNA, we need to identify those kind of things. Isolating RNA from FFP blocks is not that kind of an easy task. Okay, so that's where we found bona fide small RNAs like pvRNAs or the piRNAs, and of course long non-coding RNAs as well. And we discovered that these non-coding RNAs play a very, very important role in lieu of prostate cancer. So we didn't stop there. What we did was we observed among us those differential express genes, those n number of differential express genes. How many of these genes form top ranking gene clusters, which means how many of these particular genes you would probably see to be largely interacting with its neighboring genes. Okay, that way we can also identify the top ranking genes or the top ranking nodes at any given point of time. That's where we can probably use the RNA-seq data of CA prostate. So the second part of the conclusions here is we discovered genetic variation sitting in the non-coding RNAs. That's where the pvRNAs and long non-coding RNAs play a very important role. Of course, we were interested to discover whether or not any of these genetic variation is associated with the regulatory SNPs. And then we also identified some long non-coding RNA protein interactions, which we are currently still working on it. That's where we are trying to establish whether or not any fuzzy RNA interactions play a very important role, which can play a very important role for discovery of biomarkers. But that's not the concluding remarks for part 2. But we are still asking a very important question. Okay, now that we have some denisovan genome sequencing that we are done, and we are also a part of our neonatal sequencing. So can we expect any of these particular genes or mutations that might have transcended from these neanderthals or Homo erectus, our so-called Lambujis, our ancestors from those particular things. So basically, what we are trying to ask here is we have whole exome sequencing data, which we have done it for about 100, and some RNA-seq data for about 14 samples. And we have a part C now where we are trying to identify deep variant, where we are trying to have part A and part B together and call it as a part C, where we are looking into these kind of things. That's where we are trying to reduce the diagnostic landscape. That's because, or increase the diagnostic landscape and reduce the cost for this. That's because in 2003, the cost to perform a prostate-specific antigen test would cost about 4,000, but in 2023 it would cost 6,000. And then the digital rectal examination costs about 3,100, whereas it costs 8,000 in 2023. And in 2003, the trust test costs about 600. Now it's 2,400, and biopsy is very costly. It costs about 10,000 rupees. But we wanted to come up with a next generation sequencing based technology where we wanted to reduce it by taking the 40% of reduced costs. That's where we wanted to discover genetic variation sitting in the long non-coding RNAs and come up with a good turnaround time in ensuring that we say goodbye to biopsies. So no more biopsies, but we can take up a kind of a test, something like this, where these older people can do a simple pregnancy like test where they can take a drop of urine, because they don't even discuss their kind of problems, because they have an inherent stigma. They don't even discuss with their sons who are probably aged, and they shy away. So we wanted to come up with this kind of test that can detect whether or not they are with prostate cancer or not. Okay, so we are inching closer. By 2028 probably we will be able to come up with these kind of tests. But coming back to that previous story, as I was asking a question, can we get to see those prostate cancer genes introgressed or seen in those neanderthals or the Denisovan population? So that's where we are also trying to see. That's where we are trying to work on whether or not any of those particular data has got any somatic genetic landscape attributed to prostate cancer, where we might have inherited some prostate cancer genes right from those Denisovan or Neanderthal population. Okay, so a key question that we are trying to ask at this point of time is, you pretty well know that humans of non-African descent have about 2% Neanderthal DNA. East Asians have about 20% more Neanderthal DNA, so which means we might expect some kind of prostate cancer, largely attributed from the non-vegetarian population. But again, a vegetarians who are at risk of prostate cancer is again a kind of a question that we are trying to ask. That's where we tend to have a large amount of purifying selection, where there might be some kind of synonymous mutations attributed to that, but the non-synonymous mutations might be largely associated with lifestyle and perhaps diet. So so for this we need collaborations. We all need to join forces. We should keep away the conflict of interests or competing interests. Together only we can. We need partnerships, we need engagement, we need genotype first approach, and of course a phenotype second approach. We need to discover and dig the genes, okay, and then come up with those kind of things. As you could see, this lady, I mean, we see these things in villages, in rural villages, and sometimes in the big centers. I mean, our heart really pains when we really look at these kind of things. If you really see, the reproductive health is the most important thing. This girl, this woman who's sitting at the back, is her mother with about 4 children. She has to raise her family because her husband is somewhere there. He goes to work. But how do you expect this girl to stand on her own legs at this age? And we are all bystanders. What do we need to do? We need to counsel this lady, take care of your reproductive health, maybe ensure that your husband also is checked, and of course limit the population, and most importantly ensure that these girls go to school and not come up as a circus MC like this on the roads. So the onus is on us to take these kind of things, and that's where we are trying to take up a large amount of predictions. So without doing a large amount of tests, from a simple blood test, we wanted to go for explainable AI. Baylor Genetics has really started recently doing this with Illumina. So we are trying to come up with those particular data sets in the near future. So the first part and part 2 conclusions here is that epigenetics is the key. We found some non-coding RNAs where genetic variation is sitting in the non-coding RNAs. We need large amount of sequencing data. We need collaborations, not the people who compete. we need to ensure that some variants that have not been discovered, especially from the genetic variation sitting in the non-coding regions further upstream, where we can identify the regulatory steps which are variants of uncertain significance, can also be detected. That's where we might ask a question: if a gene is overexpressed, is it because this overexpression is because of a variant that might be sitting in those particular genes? Okay, so that's where we wanted to come up, and that ends my two parts. But the third part is very short, only 5 minutes. But I just wanted to discuss where are we heading. We this is largely for the student community. This because we have seen COVID, we have seen mount stupidity to something what we call it as doubting about our own self capabilities. That's where we call it as an imposter syndrome or Dunning-Kruger syndrome. But in October 25, there might be a SARS-CoV-2 like picture. Okay, can we now come up with a prediction model saying that okay, the kind of tests that we have had, are we really ready for that? Okay, for that we need to bring open minds. That's where open minds can bring open collaborations. That's where collaborations, convergence, and consistency can come into picture. That's where we need to take Hippocratic oath, and whenever we write papers, we need to imbibe the COPE, which is Committee on Publication Ethics. We need to produce our data. We need to bring up reusable data or interoperable data. That's where we can get rid of enfeebling, self-citations, flabbergasting, and we can get rid of predatory plagiarism, which India has seen over the years. So we need to ensure that the blue ones that are seen here, the reproducibility, collaboration, and convergence between the people, should really come into picture. This is because we at BioClues take up the Hippocratic oath. We have 8 in 10 student researchers do not know how to write a good paper, how to write even an article. Today, everyone is using, unfortunately, the chat GPT. We don't have good tools, whether or not it is human written or the AI written. And India has also seen a lack of STEM curriculum thanks to the new educational policy. Maybe the science, technology, engineering, medicine, and mathematics curriculum is coming into picture. We need women mentees, many of those who get married, who stay home, who take care of their husbands and their children. They need to be brought up into bioinformatics because that's where they can sit at home and do wonderful bioinformatics curriculum. And that's where we can bring up all these things. It's not just publish or perish, but we can say perform and publish. That's where we at Women in Biology, headed by Renuka, who takes care of all this kind of capacity building, mentor-mentee relationships, and we engage in scientific community. And we have a we care thing where we have a women empowerment where we try to bring women who are putting up at household to take care of these things. So this is where Hippocrates, the great Hippocrates, Hippocrates, has advocated an oath, which we call it as a Hippocratic oath. Usually doctors take up this Hippocratic oath, but we as scientists should also take up. So we should advocate for science, focus on the merit of publications, be creative and define success, reconsider, review, persistence is the key. And then, of course, whatever we have learned, we should pass on the baton to the next generation. And that's where we can get rid of this facade publishing and get rid of those flabbergasting H index or self citations to citations, SCITATIONS, open up the peer review, open access of preprints and H index. These kind of things play a very, very important role. And that's where we have proposed something called C index. C index is a collaborative index. So part 3 of conclusion says we are celebrating 20 years of BioClues, launched in October 2nd, 2005 on Mahatma Gandhi Jayanti. And today we are very proud for BioClues. That's because we have an active vision group. We organized several conference series, produced about 79 publications, papers published in Nature Biotechnology, and even impact factors about 20, although we are not a big fan of impact factors. And we train the students and all those kind of things. And one of these particular conference series is INBEX. So our next conference is in November 2025 at ICMR Jabalpur in NIRTH, where Pushpendra Singh, scientist of principal scientist over there, is organizing this. So you're all welcome to be a part of our BioCruise community. So, as I told you, the prostate cancer study was done by my 3 PhD fellows who are now postdocs. Shalini is defending next week. Bhuban recently defended last week. Nidhi is now an assistant professor, and these three have done those wonderful prostate cancer related work. And my collaborators and my clinicians, without whom we would not have sustained. And of course, we only together we can. And please join bioclues.org and my funding agencies on all my collaborators. And thank you again, Preenan, for this wonderful invitation. Yeah. I'll be very happy to take up some questions.
Is there anyone who would be interested to ask any questions to sir about his presentation?
Yeah, good morning, Dr. Prash. It was a very, very interesting presentation. I just wanted one clarification, like once we are getting the sequence from the sequencers, there will be several noise and several unread or undetected sequences. In that case, we can even lose some important informations of the genetic addresses. So how do we handle it in the bioinformatics platform?
That's a great question, Preenan. In fact, basically what happens is most of the time it all depends on how good the libraries are prepared. That's a very important thing. Okay, so if your libraries are not prepared well, then you'll probably end up these kind of things. So basically, you don't expect a large amount of genetic variation attributing to pathogenesis if the read depth or depth of coverage is low. So we usually ignore them. That's where the beauty of our pipelines are. So our convex pipeline, which I can type here and where you can see, you can download this in GitHub page. Okay, so you can use this particular pipeline, where our pipeline is very stringent enough to detect that kind of noise, or probably low density depth of coverage variants, where they might be attributed to pathogenesis, and that's where
Sorry,
we
sir,
might
your voice
don't
is
want to
very
miss some of
low.
those particular variants associated with that. Okay, but as I tell you, it's not the bioinformatics part, it's the noise that is coming from the library preparation. So you need to trust your sequencing librarian. So your sequencing librarian is good if he has carved out a niche specifically based on how good the variant detection is. Then you can bring a myriad of it from that. Yeah. I hope that answers your question. Sorry, can you hear me? Yeah.
Sir, your voice is very low. It is not audible right now.
Oh, is it? 1 minute.
Yeah,
1 minute.
yeah,
I just removed my headphones. Yeah.
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 Now it is better.
Yeah. So I hope that was clear. Yeah.
Students, any further questions? Okay, I will then ask one more question.
Yeah, please.
I like usually in the genomics pipeline,
Yeah.
we usually take care of the exons,
Right.
but there are very few papers which also says that introns play a great role in regulating the exons.
Right.
So, have you ever worked on introns, or did
Yeah.
you
Yeah.
come across such
Yeah.
kind
Yeah.
of work?
Yeah. Our lab, our systems genomics lab, works on that. That's where I was just giving you the gist about the genetic variation sitting in the long non-coding RNAs. So basically, in fact, for prostate cancer, we haven't found a large amount of variants, but for a rare disease story, which I haven't discussed today, we have discovered a large number of variants sitting just next to the intron exon boundary, sitting largely in the introns. That's where we have identified those variants sitting in the intronic regions. That's where we have discovered those variants, and interestingly, they turn out to be pathogenic as well. Yeah. Yeah.
Yeah, thank you, Dr. Prash. Any students? Anybody? Any further questions from anybody?
So there are no questions. I thank Preenan again and for the wonderful organization. And I already shared my presentation to him, and he can probably share those presentation slides. I'm available at this email, and you all can join our bio clues, where we give a large amount of details and information about conferences here. Okay. Yeah. So thank you so much. I'll remain muted, and I'll be traveling after 1 hour, but I'll be participating in the conference. Yeah. Thank you so much.
Okay, okay. Thank you so much, Prash. So we will have a short break of around 5-10 minutes. We'll just uh, come back in another 10 minutes from now. Take a short break and come back in 10 minutes. Jemima, you can start.
Okay, sir. Welcome back, everyone. I would like to welcome Dr. A. Selvaraj, who holds a BE, Tech, and PhD from NIT Trichy. And he's currently serving as Associate Professor in the University Department of Information and Communication Technology at MGM University, Chhatrapati Sambhajinagar. So since July 25th, 2022, he is involved in the implementation of a seed fund project titled Biomass Estimation and Prediction using LiDAR and Google Earth Engine, and special reference to MGM campus. Dr. Selvaraj has notably collaboration experience with international faculty in the field of geoinformatics and plot. So he is a research supervisor at UDICT, a member of editorial board for the Remote Sensing Technology Journal in Singapore, and a sectional editor for a book chapter in Pandit publication, Coimbatore, Tamil Nadu, India. Sir, it's indeed a pleasure to welcome you for this conference. Sir, the time is yours. So your mic is mute.
Yes, ma'am. Thank you very much for a wonderful introduction. Ma'am, my slides are visible, ma'am.
Yes, sir.
Yes, ma'am. Thank you for confirmation. So without further delay, I'm going for the presentation. So today actually my tone is not good. So please adjust with me. So the presentation title actually belong to the data science related to that data visualization in recent trends. So that is why I'm mentioning like certain risk assessment using extendable AI. So simply you can represent that as XAI. And also I'm looking for that giving some inputs for that patentability. So it's a very important part because I have a lot of experience in the patent aspect and with respect to the biosciences. So there is a lot of logging in that for filing the patent. So I think this presentation definitely will guide you to go for the patent aspect as well. So basically the background of the presentation work is basically go for the stroke analysis. Stroke, because why I'm focusing on this study is that it is very important right now as per the World Health Organizations, because it's very tedious, and also sometimes we cannot expect, and also very prediction also it's not possible. And what are the main reason and what are the main attributes we are facing for this kind of disease. So that is why I'm working on it, and also I'm going for that lot of grant also for the project grant. So here I'm focusing on that data visualizations with respect to the actionable AI, because sometimes if you go for scientific publication, right, mostly the editor will be looking for that the data validation also, because I'm also one of the editorial member for that journal. Normally the editor in chief suggests that they given some advice to me that please focus on the that validation, whether the results are validated or not by the author. If not validated, immediately don't accept the paper, ask them to give for that major revision. So I think in the presentation, I think in the gathering here, and a lot of research color are there, I hope. And first of all, you focus on the validation of the results. It's very important. Why? Because this is a recent trends in extendable AI, also a very important tool designed for validation of the model. That means what? This is going to give AI prediction rather than the human prediction. AI prediction also one of the very important tools. Sometimes the AI tool will not bypass for the rules and regulation. Sometimes you go for right. If you go for manually, if you want to execute something, right, so that time I can miss some information. So manual error may be there. But whereas if you go for AI based prediction, I mean AI based validation. So this is also very important recent trends of tool. Most of the researchers are incorporated right now with respect to the data science analysis or machine learning model. So because machine learning models are very important input for this kind of techniques. So unless machine learning model implementation, we cannot go for this kind of AI prediction. And also, when we talk about the stroke, I'm mentioning here that transient ischemic cutoff. It's a very important one of the. There are different kinds of stroke maybe, but I'm mentioning here TIA. That means transient ischemic attack is very important and also very difficult, and also it will attack suddenly and causes to death. So that is very important term. You have to go through it. And also, with respect to the stroke, it's a second leading cause of the death worldwide, globally. And statistically, when we talk about the that stroke analysis, 70% of the stroke and 80%, 80% of the stroke related to the disability, and followed by these that if you go for low and middle income countries, right, and mostly that 70% of the stroke and 80% of the strokes both related to the disability. So first we need to protect us, and also it is we need to collaborations. We need a collaboration basically from these machine learning engineers as well as the medical practitioners. So it is not only needed for that only medical practitioner, but also it's inevitable. We need to go for that scientist and medical practitioners. They have to get a help from us also. So that is why most of the disease can be we can prevent easily with respect to the scientific contribution. So we need to give the society to that. There are even lot of attributes are there. Even if we go for that medical analysis, right? So they will do lot of analysis. But if you go for that, the data dimension is also very important concept. So we cannot predict easily based on the attributes given by the medical practitioner. So in this case, the data science will be giving correct or systematic approach for selecting the attributes for prediction. So that is what important. And also I said I'm going to give that patent aspirability in that bioscience related to studies. And always you have to do the research in three aspects: and total novelty, and unambiguousness, and industrial application. So industrial application is very much important because normally simply doing research and stopping with research is not enough. We need to go for the next stage. That is what commercialization. So the industrial wanted to do for manufacturing. For example, if you are going to make on devices for stroke assessments or prediction of stroke by the some product, so that to be commercialized. So it always start with the research. So once research completed, then we need to go for that industrial application. So that is why I'm saying that you got to do research in three aspects. So that is why your publications will be your paper will be accepted by the publisher, and as well as your mind to be protected. That means your idea to be protected, and you can go for commercialization in any other country. Okay, so when I say total novelty in sense that it is not necessary to give that new work. It's not like that. When I say the total novelty, what I mean is that we need to search the thing from the database. So when we talk about the patent and scientific publication, right, the patent controller will be assessing our applications not only by the right patent prior art search, and also they are looking for that documentation. That means scientific publication already published or right. Don't think that only they can go for that only already published patent. It's not like that, right? Because normally the patent will not be coming easily, right? After research only it will be coming. After some contribution only it will be coming. So definitely they will search through the scientific publication. So if any of the work, if suppose you are going to present something in the Torre conference, right? If your work is not present in the particular database recognized by the particular patent office, for example, World Intellectual Property Organization is there, located in the US, and right in Google patents also there. It's providing free data sources, right? So these are the bodies, for example. Okay, so those bodies for having maintaining the data sets or database or your work, whatever work published with respect to the patent. So if any of the finding is not available in the database, definitely it's called total novelty. So keep in mind that so total novelty is that I need to entirely give contributions. How I am going to do that? I need to find out the new product. It's not like that, right? If any devices or if any model proposed by you is not accessing the data sources, then it will be nothing but novelty. So if you go for entirely your contributions, so that is nothing but the total novelty. And coming to the next point, non-obviousness, right? So non-obvious means that that whatever you implemented in particular research did not be exposed by the others. For example, let us consider for device for method I'm using some essence. I'm going to find out some essence for the food technology because I want to talk about bioscience related work only because I think most of the people from the bioscience related area. Okay, so when we talk about some method or process, right? I'm going to do some process with respect to that particular temperature. I want to maintain the temperature of, for example, 17 degree. The same 17 degree should not follow for others. Suppose we are using this same 17 degree, that you would give explanation for this. Even right, even I want to give one good example, right? If you go for BSNL, right, the BSNL is working under the minus 47 DC voltage. It's not working the AC. So they have to give the reason for that minus 47. Why they want to use the minus 47 voltage? Okay, so that is what non-obviousness. Sometimes other service provider, right, like Airtel, Aircell, they should not use the same kind of technologies. That is what non-obviousness, right? So I repeat, the total novelty, whatever your work done, it's not existing in the database provided by the patent office, and non-ambiguousness, right? And industrial application. I said earlier that okay, the research should not complete without industrial application. So we need to make a finding in order to develop by the industrial application because why I'm saying this, right? Normally the problem statements or problems occurs in whenever you go for the learning and teaching or research, right? But industrial or company is concerned, right? They're not finding kind of these kind of things. They will go for only solution, right? So whatever the solution, right? They need a solution by the industrial person, right? But we need to give a solution. So that is what you have to think, you have to do the research based on these steps, and you have to give to them to industrial person, and you have to make a device, or you have to make a this workflow like this. You have to give the input. So this is what my presentation basically, right? You have to do the research in three aspects. And also, and question is arises that whether all biosciences based research work are patentable. First, you got to do research on that patentability aspect, and also, I am also looking for that on development of the tool. And if you give some invention to the tool will be giving information about the patentability aspect of our invention. It will give some suggestions, and it will be giving the probability value also. For example, 80% possible, 70% possible, okay, and 60% possible are very low value for the prediction probability for that patent grant. So that is what I'm working on it, and also I will be developing the tool within 1 year, so that it will be giving to that society, so that right before going for that further research, right, or further patentable process, we can save our time, we can save our that cost also. So that is what another things going on it, and also I'm looking for that tools for with respect to the data science later also. I will be covering in coming slides. And if we go for that, whether all biosciences related to work research or patentable, here some limitation are there in biosciences. So this is what mentioning here. This is what I'm mentioning here, that limitation in the biosciences here. Normally, you would think about that. I said earlier that any patent will be containing like, right, method or process. So you have to climb like whether you want to go for system or whether we want to go for method or process. Normally, I think in bioscience related, I think food science are there, biosciences are there, right? And normally they're looking for that sometimes product also. For example, food technology students are there. I think they're looking for that food product. They want to be protect their inventions and they go for commercialize. And also, I'm doing carry out on that food sciences related work only. In the currently that we are looking for the patent grant in through IPR cell through our university. So I'm keep on because so much techniques, so many technology are coming up from the biosciences. But only problem is they fail to protect their product, that invention or research. Wait a second. So here, so wait a second, please. Okay, sorry for disturbance. Okay, so here suppose we are having some related to that biosciences. Basically, I'm not belong to that bioscience related work. Basically I'm not a biosciences man. However, just I give you some inputs or date. So what are the things are may not be patentable, right? And here, suppose we go for basic research findings, like some new proteins, okay, and modified proteins also. Sometimes modified proteins also may be available, I think, in the database, right? Suppose you are going for new proteins or modified proteins with a mixture of that other modules or other molecule, right? So that will be patentable. Okay, however, you have to think in that your product to be that industrial capabilities, and also you have to follow that as per the laws. Yes, normally when you talk about the finding, which comes with laws also. So, as per the act, and you have to sincerely accept the laws of the Indian government, right? So, you have to go for the ethical also. As per the ethical only, you can do the research. Suppose we want to go for the patent, you have to do these things with respect to the laws also. And most of the data analysis, right? And don't think that immediately patentable, it's not possible. So, any new data analysis or method algorithms may not be patentable without application. So, that means what? So, what do we is, if you're finding some that method, or suppose you are modifying the some software based work for our biosciences work, that will be integrated with application. That is what I'm mentioning, that whatever you're finding, that will be integrated with the application. For example, I'm making on software. So suppose I want to go for that software based, whether the software may be patentable, it's not like that. Now the software to be integrated with the hardware. So that is what I'm saying, there. Any data analysis methods or algorithm immediately cannot go for patentable, but we can go for integrate with application. For example, you are making one software program with respect to the biosciences work. Okay, so that will be patentable. You have to understand what do you mean by the patentable aspect. Okay. And also, I'm mentioning that as per the Indian government, right, it has been established 1970 Patent Act, right, which has some important section. I'm mentioning here some important section for with respect to the biosciences, right? So, what are the section are here? 3B. You please go through it and through the internet, through official website, right? So, but there are there are various important section, but I mentioned here only important section for biosciences. So, section 3B and section 3C and section 3A. Okay, so mostly we'll be getting response if we go for biosciences related work. Okay, we'll be getting response under this section only. Mostly 90% of the inventions are false in the category, because I'm doing a lot of analysis from the documentation also. Okay, so mostly the controller will be giving response under these sections. So method of agriculture or horticulture is definitely not possible. And if you go for that admixtures, suppose you are going adding with one product with other product, and A plus B plus C plus D, it's not also okay. That is also not patentable, but sometimes it may be patentable, but you have to give a proper explanation as per other laws also. Why? Because sometimes you are giving some product or method for treatment for medical. Okay, so that is also not patentable. Okay, suppose you are going giving some important some modified techniques or uh, other method or other system in order to go for the treatment on the medical sector, that is also not patentable under the section of 3I. 3I also is another important section. So you have to go through it, these kind of sections. And here, and also you have to, whenever you go for the presentation or whenever you want to go for that presenting or dissemination of a research work or whatever you are going to present, you have to disseminate through scientific question. First of all, you have to derive the question. That questions, scientific questions. Okay, for example, In my case, right, I'm planning like how that the tool Lime enhances the interoperability of deep learning models, because normally because based on the scientific questions only we are going to for the conclusion, and we are going to get for the result and discussion, right? So these are the scientific question I asked before that starting of the work. The first question that I mentioned here: how effectively does Lime enhance the interoperability of the deep learning models in the stroke risk prediction? So once you derive the questions to be answerable by your research and discussions. So, and also which clinical features identify the limb as critical for stroke prediction align with established medical knowledges, right? Because I said earlier that we have a lot of features or a lot of attributes they are using, right? And especially we go for that medical sector, medical practitioner, okay, so make use of different clinical features, and they're not they're unable to get that easiest way of solution for taking the decision on the particular disease. So it's clinical features identified by the limb with respect to the stroke prediction elections. So that is also to be questions. And another challenge question is that what challenge arise when applying the line? So always we got to meet some challenge aspect. You got to meet, right? You got to sometimes uh, the challengeable always there. And when we go for the new method, or when you go for that new data sets, or modified methods or new method. So always you got to focus on the challenge, accept the challenge, and with respect to the scientific questions. And after that, based on the data set, whether you can go for the existing data sets, or also that that you go for real time data sets also. So we are going to face some challenge with respect to our proposed method. So that is also to be addressed in scientific questions. So attributes and sense with respect to the stroke, right? Age is very important factor here right now, and gender. So that is also like hypertensions and heart disease and marital status and work type and resistance types and glucose levels and body mass index and smoking status and stroke. So basically here stroke is the prediction variables, that is we are going to assess. The model will be giving to status whether the stroke or not. So these are statistics over the data sets used here. We can find here that that formerly smoked here in left side picture. You can find that formerly smoked persons having that stroke occurrence. So high possibility for that. So so that means what? Suddenly stopping the smoking habits also impact. So you have to reduce your habit slowly. Okay, so you have to disseminate to these globally, because these statistics I worked on the data set analysis from the different data sets. I mostly found that formerly smoking status and currently stopping, they have vulnerable. Okay, so how much vulnerable, and never smoked almost comparing that. Okay, but here smokers are there. It's little bit high compared with the never smokes and unknown factor here. And also when you talk about the age group, the statistically you can find definitely that high possibility for 81 plus of the age, and between the age of 61 to 80. So there is also possibilities for the 50% and 41 to 60. So it has started here. The exponentially increasing here, right? Here you can in the picture you can see exponentially increase here. So that means whenever the age is increases here, that vulnerable also has slightly increases. And if you go for beyond the age of 80, the vulnerability is very high. So this is what is statistically we can observe the information over the data sets. And this is also further that histogram analysis, and with respect to the body mass interaction distributions, whenever the body mass interaction is high at in the 30 and having the high significance for if the frequency count is 500, and also with respect to the average glucose levels, the count is high with respect to the that average glucose is 100. If you go for the 100 and between the 90 to 80 to 100, we will be getting high count as per the data sets concerned. And age distribution also here, the age distribution is also very high at beyond age 80, 60 to 80, high count, and in the moderate, like if you go for age 40, we're giving some frequency count. So workflow that we know already that I think when we talk about machine learning and data science or data learning, deep learning, and any deep learning model, So normally we have to find the data sets. The data sets to be existing data sets or related data sets. First, you have to work on the existing data sets. First of all, don't want to go for immediately real-time data. Because challenge is there because the input quality normally the AI predictions will be giving based on the input only. So when we talk about the input and output quality, right? Unless input quality is not there, then definitely output is not will be providing as much quality. So we have to focus on the load data set and we have to minimize the error. So manual error to be minimized and maximize the accuracy. So like this, we have to produce the data sets and lot of data sets available from the different respiratory in the medical sectors, and also you can go focus on the generation data sets. And normally you can go for pre-processed data sets, but I want to tell one thing, that if you go for a pre-processing data sets, right, suppose if you go for the machine learning and deep learning model, right, your data to be balanced in way. Okay, when we talk about the balanced in way, that means, right, if know that balanced in there, so very difficult to go for training and testing purposes. So when we talk about the machine learning, right, but the data to be balanced. But the question maybe arises, why you want to go for the balance? Because this we are going actual data only, right? However, when we talk about the machine learning, right, the machine learning model will be accepting only balanced data sets. So we can go for different innovative method for balancing the data sets, and different modified method are there. And if you go for that smooth model, it is one of the very famous model, and low frequency and high frequency. Accordingly, we have different classification of the model. So you have to choose the best pre-processing model, and you have to balance the data sets. Once balancing data sets, you can go for the deep learning model, and after that compiling model, right? And training, as per the last, we can go for that 70% for training and 30% for the testing, right? After that, you can whatever model you are implementing, that to be fitted with your data sets and generate the results and explainable model. So this is what normal workflow that I carried out. So this is actually finding. So why? Because that so definitely if you go for the data science related work with respect to the biosciences or whatever, right? So these predictions is very important, because I said the AI prediction sometimes providing good accuracy than the manual prediction or manual assessment for selection of the attributes. So here the AI prediction will be there. Here we can see it will be giving right-sided value that from the strokes with respect to the features and its value. And the probability also that we can get 80% of the strokes, that no strokes of the data sets. This analysis is based on the data sets given by users. And 60% of the right, it's possible for the data, it's possible for the stroke. So this kind of external predictions given by the external AI, it's a recent trends I said that. And another method also there, that is a step explanation I'm telling you. So these are the finding I basically observed from my finding, that as said earlier, that probability of the no stroke it's 85% and probability of the stroke is 16%. Normally, the question may arise, this is what exactly result? It's not like that. I'm saying that if you are generating some model already, right? That model to be integrated with this model, and you have to make a comparative statement. That means this one of the validation model. Suppose you already done model, right? That will be providing the same result. Definitely, we can go for that to validate our results. Okay. And also we can significantly, I found that age factor is highly impacted factor with respect to stroke. Even heart disease also not as much as per the method is concerned, but age factor is very important factor here that I observed. And with respect to the above age of 61 years, right, it's most significant contributor. Significant contributor with weight of 0.04. So basically it will be involving with statistical analysis also. And also, right, I observed there's some contribution factor from that working status also. That is what self-employment and or private sectors also have smaller impact on that, contributing around 0.0 each. So working factor also very important factor, because stress will be there. So sometimes stress also will be impacting for the stroke, but not as much, but significantly it will be giving some contribution. So this is one kind of data analysis tool which will be generated by the external AI. That is what waterfall. It will be giving more information here. For example, the important observation here, I observed that that lower 7th point, lower glucose level indicate the potential metabolic health issues. So this is one of the important observation I made. And you can go for that heart disease reduces the prediction by 99.43. So this is what one of the recent trends waterfall. These under study also we need to give more explanation. Still I'm working on it, so I cannot get correct input from this plot, but this is also a very important tool is for the data science consent. So if you have any work, you have to present the work this kind of work instead of going for conventional chart, because even though this chart will not be having a conventional method of formulas, but it will be giving more information. That is why you should avoid conventional method of explanation like charts, by chart, bar chart, bar chart, right? So this is what expectation by the publishers. So check it up these data sets for your studies also. Check it with soft waterfalls, explainable by AI. So this mean, all right, this is also that expecting in data science consent that heat map or correlations matrix. So this is also one of the validation of the model. And here, when we talk about the attributes, right, I said earlier that age is significantly positive correlation with stroke occurrence of 0.25. And the BME also that moderate positive correlation. And if you go for that weak correlations, I can say hypertensions and heart disease and average glucose level. So this is secondary. So the main important contribution from the attributes are age and BMI. So you got to maintain our BMI level with respect to the age and height, and with respect to the age. You have to maintain the BMI level. So because this model will be giving, but I need to validate further. So the other other attributes like hypertension, heart disease, average glucose levels will be providing weak correlation. So that is also I need to study. So with this conclusion, I need to conclude that the external AI risk assessment is not only improve the accuracy of the prediction, but also it will be empowering the clinician and patients like by providing clear, understandable explanation of the underlying the factors so driving health risks. So we need a collaboration between the medical practitioner and machine learning engineers to provide better accuracy. So with these presentations, I would like to thank to that Dr. Bassi sir who invited me for the particular presentations, and I would like to extend my sincere thank you versus Genomics Research Lab. Thank you very much.
Thank you so much, sir. Is there any questions? Any doubts?
Okay, you don't have my email ID also. And if you have any doubt, you can send your mail with queries with respect to the patentability. If you have finding, if you are struggling and not getting proper guidance, just send a mail to me. We'll be getting response within 1 day. Thank you very much.
Thank you so much, sir. That was so thoughtful about you. So now I would like to announce that there would be a lunch break, and the conference will again begin by 1:15. So yeah, you can take your time and can return back by 1:15. Thank you.
Hello, is there someone? They leave village. Hmm? 11 जण हा म्हणजे बरेच जण लीव करता येईल ना.
Okay, good afternoon, everybody. Welcome to the afternoon post-lunch session. So we will begin the session with Dr. Comfort. So
Hello. Oops. Can you see my screen?
one moment. Yeah,
Let me share.
yeah.
Desktop.
One moment.
Can you see my screen?
One moment, sir. Yes, sir. One moment, sir. One moment. Yeah. Yeah, Professor Dr. Comfort Wong leads the Cognitive Neuroscience Neurotechnology Research Team at the Intelligent Systems Research School, School of Computing, Engineering and Intelligent Systems, Ulster University. His research interests span computational modeling and mathematical analysis in the systems and cognitive neuroscience and psychology, brain disorders, neural computation and engineering, AI and data science. Prior to joining Ulster University, Professor Wong Ling was a research associate at Princeton University, USA, affiliated with the program in Applied and Computational Mathematics, the Center for the Study of Brain, Mind, and Behavior, and the Princeton Neuroscience Institute. He earned his PhD in physics, specializing in computer neuroscience from Brandeis University, USA, in association with the Berlin National Center for Complex Systems. Professor Wong Ling's achievements include the 2011 IJCNN Best Paper Award and the 2016 Ulster University Distinguished Research Fellowship Award and 2019 Ulster University Research Excellence Award. He has also held prestigious visiting fellowships, including the Moray Institute Visiting Research Fellowship at the National University of Ireland, Galway in 2017, and a visiting fellowship at the University of Oxford 2020. So I welcome Dr. Comfort Link to Von Link to give his presentation. Over to you, sir.
All right, thank you. Let's see. You can see the slide. Yeah, okay, great. All right, so first of all, I'd like to thank the organizers for the invitation, especially Dr. Prinan Pachi. And so move on. Oops, sorry. So let me begin by saying that our everyday decision making is a type of cognition that often involves the weighing of information or evidence for or against a choice. And perceptual decision making is a more specific type, which involves uncertainty, sensory information being processed and integrated, which leads to a choice or action being selected based on the presented information. Often, responses have to be made to report the choices, and it has to be done quickly and accurately in the form of a motor output. For example, imagine you are driving a car in a heavy rain and trying to follow your friend's car in front of you. You're constantly trying to make a decision on whether to turn the steering wheel left or right, depending on the visual information. Obviously, heavy rain can make the perceptual decision-making process much harder than on a sunny day. But in the lab, the environments are more controlled. For instance, participants may be asked to discriminate an overall motion direction. Oops, sorry. Overall motion direction of a cloud of randomly moving dots, a fraction of which are moving coherently either leftward or rightward. The participant is instructed to report her choice by moving his gaze towards one of the two choices on the left or right on the screen. If the participant makes a correct choice when the direction of the gaze moves in the same direction as the motion coherent motion, then it will get a correct choice. The task gets harder when the percentage of dots moving coherently is lower, which may lead more likely to an error choice. So an important probabilistic modeling framework developed by cognitive scientists and psychologists is a sequential sampling model framework of decision making, which assumes some internal decision variable X here that accumulates noisy evidence or information over time towards some prescribed decision threshold. Upon reaching the threshold, a choice will be made, and the decision time or reaction time can be obtained. Thus, these are considered evidence accumulator models. A popular model is the drift diffusion model. For example, for two choice tasks, the signal and noise are integrated over time in a calculus sense towards one of the two decision thresholds. Hence, it is a simple one-dimensional stochastic dynamical system. A question would be whether there is evidence of such processes occurring in the biological brain. It turns out that over the years, neuronal correlates of neural integrators that integrate sensory evidence over time during perceptual decision-making have been found across different brain regions. So you can see here, a highly studied brain region called area LIP was one of the earliest regions found. In particular, a notable work by Rodman and Shetland on non-human primates or monkeys recorded LIP neurons while monkeys performing the motion discrimination task described earlier. They found that the slope in the ramping of neuronal activities over time depends on the task difficulty. The harder the task, the less steeper the slope. This was also associated with slower reaction time in reporting a choice. Upon response, the activity are aligned at a similar value, perhaps suggesting some form of a fixed decision criteria or threshold. This is followed by a reset of the activity following the response. To account for and understand these observations, I have used so-called mean field approach from statistical physics and other approximations to reduce a biophysical network with thousands of spiking neurons into two populations of neurons, each encoding a different choice, with one competing against the other. The whole network can be described by only two coupled differential equations described by the kinetic dynamics. Upon computer simulation, we can see that over time, one of the neuronal populations win. And if their average activity surpasses some prescribed threshold, a choice is made. A choice is made. And the decision time is known, just like the accumulator models. This is a so-called attractor model, and one can think of the decision network states falling into one of two decision wells, similar to the network model by the Nobel Prize winner, John Hopfield. Of course, sometimes due to fluctuations, an error choice can be made, even though the correct choice, well, is deeper. This is primarily due to fluctuation in the noise, due to the noise. With the reduced model with only two dynamical equations, one can also perform rigorous phase plane dynamical systems analysis. In the absence of stimulus, there is a stable, spontaneous active state. If you look at the corner over here, you can guess that the energy landscape will look something like that for the three attractors, which is shown in the three field circles, white field circles. When the stimulus is presented, favoring, say, choice 1, then the basin of attraction associated with choice attractor 1 becomes larger at the expense of the other choice attractor. Okay, and error choices is in red color requires crossing the boundary and be in proximity of some steady state, thus slowing the trajectory. This explains why errors are slower than correct choices. As the task becomes, and you should please note that there's this setter point turns out to control the dynamics of the decision making. Setter as in almost like the setter of a horse. And when the task becomes more easier, the basin of attraction becomes even larger, and there are more correct choices. And this helps explain why the model can account for the choice behavior. And note the importance of the metastable steady state. Another note is that the energy landscape has changed when before stimulus and then after, as compared to after the stimulus is turned on. So this is called a bifurcation, or in physics, it's called phase transition. In fact, we can map out the stability of the network in parameter space. And we can see that the decision making shown in only in the blue region is finite. This is reminiscent of the phase diagram in classical and quantum systems. We can also view the energy potential around the setter point as over here as followed. You can see that the network's trajectory first moves along the stable manifold before diverting away from the setter point along the unstable manifold. When a network is approximately linear and its inhibitory and leak term balances out, the energy landscape becomes one-dimensional, like here, where the decision is made largely along a one-dimensional manifold, just like the classical drift diffusion model. Hence, we can bridge from biological model to classical cognitive model. Such energy landscape can also be mapped out based on people's walking or computer mouse trajectories. This can be applied to neurocomputing, marketing, and neuroeconomics, where we can understand and predict customers' behavior. With the advent of neurotechnology, several hundreds to thousands of neurons can be simultaneously recorded across the brain now. Here is a notable decision experiment where rodents have to steer a wheel, just like driving a car, while avoiding a larger stimulus, the larger stimulus contrast. Again, one can see winner-take-all type decision neurons across different brain regions. However, there are also other neuronal activity patterns, as you can see over here. And these diverse patterns can be captured using more complex recurrent neural network models. Further, such model can also capture activity trajectory in higher dimensional space. Just like any physical system, deeper understanding may require perturbation of the system. The attractor network model that I discussed earlier can also replicate a later work that shows brief motion pulse perturbation on top of the random dot motion stimulus, which I've mentioned. And this has a lasting yet decaying effect on choice behavior. The model shows that the inability of a late pulse perturbation to affect choice is due to the runaway energy landscape in the model. And more recently, there's work using more advanced neurotechnology with stimulus perturbation, and it has confirmed such an effect, where once the decision is committed, it is very hard to change it. And here is one such study. My other work is not only on using external stimulus perturbation to understand the underlying mechanisms of decision making, but also internal perturbations, such as due to endogenous brain chemicals like norepinephrine or noradrenaline. And these have also indicated the importance of nonlinear network dynamics. However, more recently, alternative methods of investigation can be done. And for example, using data-driven machine learning. Here we use a dynamical systems-based machine learning called SIND, which can uncover the underlying nonlinear governing equations given the state trajectory data. And this is done using sparse regression. In particular, my PhD student Brandon Lemfesti made use of Cindy on activity time course generated by different decision accumulator models to uncover their equations. The algorithms readily captures the original model simulated activity, time course, and also the model's choice behavior. And this is the first time Cindy has been applied to highly stochastic decision systems with truncated data, as shown here. Now, I would wish to switch gear. The reason for studying perceptual decision making is that it is not just a simple, straightforward sensory to motor information processing, but this pathway can be subjected to influences and controls internally within the brain. In fact, because of such influences, we may view perceptual decision making as a window to understanding higher forms of brain functions or cognition, such as metacognition, that is, cognition of a cognition. This is a type of metacognition. Specific type of metacognition is called self-awareness. Over recent years, studies have investigated how confident people or animals are when making their decisions. That is, whether the decisions are going to be correct or wrong. A recent work led by my PhD student Nadim Atiyah extended my mean field model of decision making by incorporating a metacognitive component that monitors in real-time decision uncertainty. This module can in turn provide feedback control to the decision-making neural populations, similar to a control engineering system. And the model was able to account for some well-known observations of metacognitive behavior in human and animal studies. Because of the feedback control loop, the model can also account for change of mind. Shown here are the neural populations in the model, with one showing an initial winning state before losing, and vice versa for the other neural population. A linear transformation to modal position shows a change of mind modal output as observed in experiments. Our model explains change of mind by creating a neutral central attractor during high decision uncertainty. This allows a resetting of a network and allow potentially an initial error choice to become a correct choice. In fact, it turns out that there are more eventual correct than error choice during change of mind. So change of mind is overall a good thing. The excitatory feedback control in the model predicts that even after the disappearance of sensory information, decision uncertainty continues to be integrated, and hence change of minds occurring much later. This is unlike other proposed models. This prediction has been validated by our experimental collaborators' data. And when fitted to the choice behavior of other data sets, this model predicted using multiple regression that people with self-reported mental health issues, a whole range of mental health issues, have weaker uncertainty monitoring and feedback control from the uncertainty encoding neurons. This is linked to the field of computational psychiatry. Using similar type of neural modeling, but with more realistic composition of neurons across the cortical layers, we can now model brain-wide EEG source activities of people making perceptual decisions while they rate their corresponding decision confidence. This work was done by my former postdoctoral researcher, Dr. Abdurreza Asadpour, based on fMRI-informed EEG data. We found that the neural pathways for encoding decision confidence is different from that encoding decision speed. Moreover, the model predicts that decision confidence, uncertainty, and speed are all neurally encoded in a distributed manner across the cortical layers. Interestingly, a recent study that simultaneously records hundreds of neurons in the area LIP region, as I've mentioned previously, have found 3 clusters of neurons. One cluster has a stereotypical ramping to threshold pattern of evidence or decision confidence. A third cluster seems to show encoding of decision uncertainty. Keeping this in mind, I want to move on to Brandon's recent modeling work. Here we look at data where decisions are abstracted from motor movements in a way that choice targets locations are unknown to the monkey subjects until later in time, so that the monkeys cannot prepare sensory decision-based motor movements in advance. So Brandon reanalyzed this LIP neuronal data and validated that the recorded LIP neurons did not ramp up during the sensory stimulus presentation, but only upon choice target onset. He then extended my reduced decision model by adding another group of competing neurons that integrate sensory information, and their outputs are fed into another group of neurons that represent the observed LIP neuronal activity. Importantly, the second group of neurons are non-linearly gated by the choice targets, even though they constantly receive inputs from the first group. This is shown in their respective activities here. And this is again similar to the observed experimental data. Also, the model can replicate the choice behavior of the monkeys. Decisions abstracted from motor movements have also been reported in humans. A recent study by our collaborators in US and Ireland showed brain-wide intracranial EEG activities in patients. A PhD student from IIT Guwahati, whom I am externally supervising, uses autoencoder to capture the latent IEEG activity dynamics. In particular, with a suite of machine learning techniques, including feature selection, he showed that using lesser brain regions can perform comparably to the original study in classifying task difficulty. Importantly, he shows that the same lesser brain regions can outperform the original study in classifying decision speed. Next, I want to switch gear to touch on using quantum theory to model decision making. Quantum decision theory, or QDT, applies the principles and mathematical structures from quantum mechanics to model and analyze decision-making processes, unlike classical decision theory that uses classical probability theory and assumes rational decision agents. Quantum theory has a few key components, but I will introduce two of them here. First, imagine an electron being shot through a barrier with two opening slits. If a detector is placed near slit 1, it will detect particle-like behavior with some probability distribution P1. Similar case when it is placed near slit 2. However, if we use a screen to detect instead, we see two waves passing through the two slits and creating a wave interference pattern. That is, the electron is behaving like a wave. Moreover, in quantum theory, if the wave is not observed, its state remains as a superposition of multiple potential states. In the context of decision-making, it might be a person considering both buying and not buying a product until a decision collapses this superposition state into a single state or particle. Going back to the attractor model, we can already see that multiple choice attractors coexist, and later in time, one of the choices are made while suppressing the other option. This is akin to collapsing the multiple options to one choice, just like the quantum decision theory. To illustrate the interference effect of quantum mechanics, here in decision making, here is a two-stage decision task where participants have to categorize whether a face is good guy or bad guy before deciding on an action, that is whether to attack or withdraw from the person. The probability of attacking can be obtained, which is PCD. When a good versus bad guy categorization is not made but an action is decided, the probability of attacking is larger than in the previous task. And this violates the classical probability theory, which states that they should be the same. This is called an interference effect. Thus, the act of categorizing or deciding earlier has an influence on later action. Quantum decision theory mathematically shows that the difference in probabilities is due to the mixed wave function upon expansion here, as compared to this probability, which I won't go into too much detail. This task is reminiscent to the earlier abstract decision task modeled by Brandon, and this inspires our further investigation. To test for interference effect, what is needed is to model the reset of the neurons upon making the decisions, upon reaching the decision threshold, as observed in experiments, instead of having them sustained over time. We found that if there is sufficiently large percentage of sensory evidence integrating neurons being reset, the choice accuracy can be reduced. Further, the model predicts slower decisions and the speed of correct and error decisions becoming more similar. Thus, I conjecture that quantum decision theory may perhaps be linked to classical probability theory through the implementations of more biologically realistic neurodynamical decision models. To some, I have shown how biological decision-making is linked to mathematical and physical sciences, but it is also linked to many other fields, including computing and intelligent systems, which our research center is focused on. And this is linked to the current new field of neuro AI, in which we can apply brain-based model to build novel artificial systems. To summarize, we have shown that dynamical systems can be used as a tool for understanding perceptual decision-making and related metacognition. And low-dimensional dynamical systems can account for choice behavior and neural data. More complicated choice behavior can be built on top of this simpler decision-making model. I've also shown that machine learning based on dynamical systems can be applied to uncover underlying decision processing. And finally, neurodynamical models can account for phenomena described by the quantum decision theory. To end, I wish to thank the people who have helped or influenced the discussed studies and the funding agencies. I would also wish to announce that I have several fully funded PhD scholarships available. Anyone who is interested may contact me for further information, and I'm happy to take any questions. Thank you. At the end of my talk.
Is there anyone who is interested to ask any question or?
Nope.
Sir, I guess there is no questions.
Okay,
for
good.
now.
Thank you.
Thank you so much for your valuable time and attending this conference, sir.
Okay, thank you.
Thank you. So now, moving forward, I would like to welcome our next speaker, Dr. G. Dhanalakshmi, who is a master's in science and master in philosophy and a PhD scholar. And she is currently designated as assistant professor in Padma Shri Institute of Management and Sciences, Bangalore, and working as computational biologist. And her research or key interest is with phytochemistry and computational biology. And projects are, she's a guide for 5 Master of Philosophy students and 50 Masters of Science project research work in field and publications is she has over 50 research papers in national and international conferences and journals. So, ma'am, we welcome you for this conference.
Yes. Good afternoon to all. My screen is visible?
Yes, ma'am, it is.
Yeah. Thank you, Paul, for your nice intro. And first, I thank to organizing team, Dr. Somsekhar Shah and Dr. Pinon sir for giving the wonderful opportunity. Actually, every year they are conducting this international conference through hybrid or online also. Actually, it is a good idea and knowledge, sharing the knowledge and learning, it is very, very important compared to other than that, I thought. So that is a better opportunity for our scholars as well as students also. I thank you once again for the organizing team, and then I'll start with my presentation. Okay. Today, my talk with the computational approaches in drug discovery. I'm audible?
Yes, ma'am, you are.
So I plan to start with the new intro. What is drug discovery? Actually, drug discovery is the process of identification of new molecules or the chemical that it will be helpful to cure or prevent the diseases. Either it will be in the acute or in the case of chronic condition also. Exactly the computational, that is computational drug discovery, it will be happens with the combination of chemistry, biology, and computer science, even the technology and innovations. It will be helpful to develop the new ideas. That is a new concept of the drugs. It will be helpful to support the medical field. That is the idea of the drug discovery. So today we will explore how the computational drug discovery works and what are the challenges it will be involving in this impact, and how to it will be helpful to improvise the healthcare in the worldwide also. We plan to discuss in these sessions. Okay. Shall we go to the session? Yes. So we are in that topic of drug discovery. So without pharmacology, we can't able to go with this, I guess. So what is meant by pharmacology? Yes, it is a scientific study of drugs and its uses of medicines. Yes, this pharmacology, I plan to take over so many wide varieties of pharmacologies. It will be there in that scenario of pharmacology also. I plan to go with that drug discovery basis. That is, I plan to take it a two kind of pharmacology here. That is forward pharmacology and then reverse pharmacology. Forward pharmacology, it is basically planned about that phenotypic drug discovery, like what are the compound, it will be screened from your animals or the cellular diseases. And reverse pharmacology, it will be helpful to go with this target-based drug discovery. I guess it is in presentation mode.
Yes, ma'am, earlier it was.
Okay.
Now we can see your screen.
Madam, it is not
it
in the
clear, right?
presentation mode. Only the first slide is saying with the other slides.
Sir, now I changed again. Can you check it once?
No, madam, it is the same.
Okay. Now I am stop sharing again and try to share. Can you see now?
Yes, madam, it is fine now.
Okay, thank you, sir. So in this intro, we will go with that. What is mean by drug? The drug, it is a chemical component or the substance. It will be helpful to cure or prevent the diseases or any kind of alignments also. That is a metabolic alignments also. That is the role of the drug. Now I'm coming to the drug discovery. Yes, the drug discovery, it is a process. It will be helpful to identify or develop the new components, that is a new chemical components. We call it as a pharmaceutical components because we are using as a medicine. That is the reason. So that it will be helpful to cure or treat or prevent the diseases. So it will be generally the drug discovery without computational biochemistry means it will be take a lot of times, almost it will be take 15 to 20 years also. Okay, everybody is known about that COVID impact. So chemical with the biological system, that is a computer based software with the biological systems, it will be gives a desired response, that it will be called it as a drug discovery. So the discovery, it is a flowchart of the drug discovery. I guess that is a we can start it with that target discovery. Actually, in the target discovery, we can choose how we have to choose our target first. That means program selections. What is meant by program selection? That means particular diseases. Okay. But first we have to think about that what kind of drug we want to discover. Okay. Against to what kind of disease or what kind of problems or what purposes you have to ready with your lead candidates. That is the idea. So we have to select the program first. And second, it is a target identification. In this target identification, you have to identify the target and you have to validate the target also. Then only you will be moved to the next point. That is the next step of your discovery process. Then it will be comes to the exploratory research. Either you have to go for hit generations, or if it is not applicable also, if it is fine in the computational biochemistry, that is a computational drug discovery, you can come with the lead identification. Okay. So this lead identifications, and again, this lead identification, and you have to optimize or validate your lead candidate also. So where you have to identify from the lead candidate, actually I plan to explain with the softwares also. This is only the steps, how we have to go with that process I'm explaining now. Okay, so now we have to go with that lead identification from any of your sample. For example, you are taking as a medicinal plant, the phytochemical, it is a lead component. You can extract the phytochemicals or identify the particular phytochemicals that it is act as a lead component. Then you have to come for the assay development and hit identifications, and you have to come for the drug designing, and you have to validate the lead identification also. So then up to this, it is come under the drug discovery. Okay, that is especially the drug discovery. So now you got the target component also as well as lead candidate also. So with the help of this, you can go with that molecular docking. Okay, molecular docking or molecular stimulation or molecular dynamics also. Okay, after that, you have to come switch over to the developmental process. Developmental process, I guess it is started from the preclinical. That is here in the preclinical, you have to start with that in vitro as well as the in vivo studies also. Then, I guess you know what is in vitro, in vivo, right? First of all, in the in vivo, we have to start it with the animal model. Then we have to go with the clinical studies that is in that human being. In the clinical studies also, you having the different phases, that is phase 1, 2, 3 kind of things. After that only you will be getting the approval from the FDA. Okay, so then only your what we are identifying the drug, that is discovered the drug, it will be supposed to be identified. Actually, up to this, the process, the word, we can't able to use the terminology of drug. We only use the prodrug or in the case of lead drug components only. Okay. Now I am switch over that computer aided drug discovery, that it is called as CAD. So this CAD, it is based upon the two important things, that is a structural based drug designing and then ligand based drug designing. Okay, so this, it will be based upon what is mean by structural based drug designing, what is mean by ligand based drug designing. That will be known as proteins, known protein structure, or in the case of unknown protein structure. Okay, that is made up of known protein, or in the case of unknown protein structures. If we don't know about the ligand, still we want to go through the ligand very depth. So I'm not touch the part of the ligand. I'll come back for this. Okay. So I guess you can able to see the pictures also here, structure-based drug designing and then ligand-based drug designing. Okay. So now I'm coming to the workflow of these things. So, the target proteins, that is a protein or enzyme. It is from the particular disorder. You have to select it is that as a target protein. Then you have to decide the binding site. It is called as binding packet. And you have to go with the molecular docking. Okay, so molecular docking or molecular stimulation, it is coming under that. If it is a known ligaments, if it is unknown thing, you have to come with that ligand-based drug designing. So the structural-based drug designings, it will be comes under the flowchart of target predictions. Yes, you have to choose with the specific disease first, then only have to choose the target and binding site identification. In this target, where is the binding site? Where is the binding cavity it is available? You have to check. Then you have to prepare the library based on this. Here only you have to take the lead candidate identification also. Then you have to come for the molecular docking and then scoring. So if it is applicable, if you go for the MD stimulation also, then your workout, it will be fulfilled. Then in the ligand-based drug designing, ligand structure and bioactivity, I guess you remember about that. We don't know about that unknown structure. The ligand structure, we don't know that also. We have to go with the structure predictions of X-ray diffractions or that is NMR. These kind of techniques you can use and identify your own atoms or the molecule structure, and you have to go for the further analysis. Here the QSR, it is very, very important for this. That is the QSR means quantitative structure activity for the relationship, and you have to go with that ligand-based visual screening analysis also. Okay. So with the help of wet and dry lab, you have to go with the lead optimization and validation also. Almost this is a whole structure of your docking. That is how you will be go with this. Okay. Now I'm moving with that. How you have to step by step, I plan to go with this. So what is the good quality of target proteins? Okay. So if you want to select the good target proteins, first you have to identify the disease. That is it's supposed to be relevant to your work. Then you have to check the side effects. Okay, what are the side effects? It will be there. That also you can able to identify through this computational or not. You have to check with this. Without identification, it will be not fulfilled your discovery process. Okay, yeah. From this idea, we have to come with this two important things, that is target identification and target validation. Target identification, already we discussed as such, the key molecules from the particular disorders, we have to identify the particular enzyme or a protein. It is act as a target thing. Then target validation, after identification, you have to check the validity of the target, whether it will be effective for your lead component, whether it will be dock with your lead component or not. What is the disease progression also? I guess here you can see a few softwares. It will be available for your target site identification. That is gene expression database. It is GEO. We call it as. It will be exactly helpful to identify the gene association with the disease. and analysis of the particular gene expression also. Then protein-protein interaction network, string, it will be goes very well. And pathway analysis tool, yes, KEGG, it is excellent tool for your disease identification. Even though drug bank, you can come with this. Based on the drug, I can check, and then mechanism of action, you can check. Through this, you will be getting the target protein. And genome-wide association studies, that is called it as a GWAS, and CRISPR screen. Okay, now I'm planning to go with that one small demo. Now it will be changed. Just a minute, I'm working in this. Okay, sorry for the inconvenience. Actually, I'm trying to open that soft first, and then I plan to show you how to check that thing also. It is the KEGG pathway database. You will be get like all those things, all the information of the pathways. I'm audible?
Yes, madam, you are audible.
Yes.
Yes,
Thank
ma'am.
you. Yeah. So, like you are getting all the informations like metabolism, genetic informations, environmental informations and processing, cellular processes and organism systems and human diseases and then drug development. Okay. So from in that bottom side, what your display, what I'm displaying will be the coronavirus, that is a COVID-19. Okay. I'm taking it from the human disease. Okay. In this human disease, you having the n number of diseases that will be displayed, including the cancer. So if you want, you can check it once in that pathway of the KEG pathway database. Using this pathway, you will be getting all the information. Then you can identify it. Okay. So now from this idea, how you will be getting the target site? See, can you see that you will be having the different kind of receptors? That is a enzymes. It is act as a receptors. A is ACE. That is a angiotensin converting enzyme, that it will be act as a receptor, that is a target site of your coronavirus, that is a COVID-19. So I can use the target site of COVID, that is COVID-19 for AEC, it is act as a target site, and then I have to go with this. Or you have to go with the drug development based on the particular drug development. For example, can you try after that? So like a lipidemic drug, anti-lipidemic drug, it is a good example target site of HMG-CoA reductase. So you can choose as a target of the HMG-CoA also. So in this case, you can plan for that. And so that is a target site identification. So another target tool, it will be that is an open target platform. Here also you can able to identifying the targets very easily. And another one target, it will be the Swiss target prediction. Here you can able to identifying the targets. This program, it will be helpful to identifying the target as well as Swiss ADME. It will be helpful to identifying your which one your lead component identification also, and Swiss farm and then Swiss dock, it will be helpful to go for docking also. That is important for this Swiss based tool software. And here I'm taking a few examples, cytochrome P450 and then thymidine synthase. Actually, this is a target. These components, it will be act as a target for the cancer. Okay, so cancer therapy from the long back, we are using that FU, that is a fluorouracil. That is the idea for the fluorouracil. It will be try to inhibit your DNA synthesis. Okay, especially the S phase. I guess everybody is remember about our cell cycle, G1 phase, S phase, and then G2 phases. Actually, it will be try to inhibit your S phase of the DNA synthesis at the time of inhibiting your thymidine synthase component. Okay, so that is why here we are choosing as a target of thymidine synthase. Okay, then with the help of your Swiss ADME database, you can get the further idea. Here you will be getting the RMSD value. Can you able to see here? That is a RMSD value. What is the important for your Q mean and then RMSD value? That it will be showing whether it will be qualified for your docking or not. That is at what you are selecting the target, it will be eligible to go for your target or not. Especially, it will be getting the score of less than 2. That means it will be very good score. That means less than 1 of RMSD value. It is very good. So it will be go for the correct binding packet also. So these are all the promising properties of the drug target. It's supposed to be disease relevant. It is very important. And druggability, accessibility, it is very, very important for that. If accessibility it will be there, then only you can go with that high throughput screening, and it is a manageable toxic profile or not. Then only you can able to check the adverse effect for that particular designing. And the last one, that is IP status. That IP status, that is intellectual property status, it's supposed to be goes to your pharma people. Actually, already available drug, you want to show some differentiation, right? Apart from that, it will be that nil work, that is a null hypothesis work only. It is no need for that. So better try to avoid these kind of things. So intellectual property right status, it is also very, very important in the drug target identification. And I'm now coming to that lead, that is a ligand identification and then validation. So this ligand identification and then validation is also having these are all the softwares. It will be helpful to you to identify the ligand and then validations, like your PubChem database. Generally, you can check the chemical component, any chemical component from this, and you can go with this. And you can go with this structure identification, and ChemSpider also, it will be helpful to you. And the MOU, especially for the natural product database, it will be that is called as a NPDP database. It will be helpful to identifying the natural database. So actually, here, while seeing that ligand identification and then validations, you have to identify the structure, and then you have to cross-verify whether it will be crossover the Lipinski rule of 5 and that is a pharmacokinetic parameters also. That is Lipinski rule of 5. Lipinski rule of 5, it will be having the, what are the Lipinski rule of 5? It is a molecular weight, it's supposed to be less than 500, and hydrogen bond acceptor, it's supposed to be less than 10, and hydrogen bond donor, it's supposed to be less than 5. And log P value, it's not supposed to be more than 5. You have to check the N violation, it's supposed to be 0. That is also very, very important. You have to check Your lead candidate, it will be crossover all the scenarios, that is all the rules, then only you have to choose is the component for your target identification. That is a molecular docking purposes. Okay, that is a sector for validation sector. Another one validations, it will be that you have to cross through with your ADME database, that is Swiss ADME database. What is mean by ADME means adsorption, distribution, metabolism and elimination. That is the ADME. The Swiss ADME database, it will be very, very important. It will be helpful to identifying the pharmacokinetic parameters. So in this, you can able to understand that GI absorptions and triple B, that is a blood-brain barrier, and your solubility and bioavailability scores, everything you can able to observe in this. So you have to, these are all the validation. These are all the things it is called as a validation of ligand candidates. After the validations only, it will be qualifying to move for the MD, that is a molecular docking analysis. Okay. So here, I guess my slide is changing.
Yes, madam.
Okay, sir. Thank you. So, actually, we are planning with the medicinal plants. Okay, so many options it will be there in a zinc or PubChem. You will be getting the structures very easily. Even though it is not available, you can check with the data retrieval. That is a plant. This is a ID. Here I'm given the ID also. From that, that is from this website, you will be getting the structures also. These are all the organizers they are supporting to get your plant-based structures. This, it will be act as a lead candidate. So you can access through this database also. Then now we are completing that validation of target as well as the lead candidate identification as well as the validation. So now we are moving to the molecular docking. Okay, so what is molecular docking again? It is a computational process. It will be helpful to identify the binding interactions of the small molecule to the protein. So here, I guess, here you can able to see that it is your ligand component. It is from the plant-based or any sample-based. This is your active site. This active site, it will be available from your target protein. What is your target protein? It is depends upon your disease, particular disease. Few examples we saw in the previous slides also. Okay, so in this case, we have to go with this. Thus, it will be called it as a molecular docking. Okay, now I'm coming to the different types of molecular docking. It will be having the different types of molecular docking like rigid docking and flexible docking, flexible rigid docking and soft docking also. What is meant by rigid docking? I guess we know about that enzyme binding theories like a lock and key model and then induced fit model, right? So based upon this only, it will be activating. Rigid model, rigid model of docking, it will be based upon your lock and key model. That means the ligand and then receptors molecules are very whatever the original shape, it will be not changing their original shapes. That is the idea. That is the rigid docking. The flexible docking, the proteins and the ligands are flexible. That is a binding capability of the side chains of the proteins and then ligands can change, slightly alter their nature. So this is come under the flexible docking. And flexible rigid docking, that means it is a semi-flexible docking method. Either your ligands or your target site, it's supposed to be flexi. That is the idea. Soft docking, it is very simple method that allows the small, minute degree of the overlapping in between your ligand candidate and your target candidate also. And that is your types of docking studies. So these are all the software here I'm mentioning. So what are the softwares that will be helpful to using your molecular docking? Not only this molecular docking software, nowadays you are available in number of softwares. It is helpful to go for molecular docking. So AutoDock, it is widely used one. Then Gold, like MC-Dock, CB-Dock, GEM-Dock, Glide. These are all the docking softwares. It will be helpful to go with your docking studies. Then these are all the few examples I'm giving here. The software program, it will be used for your molecular docking. That is AutoDock. Yes, AutoDock recent version, it will be there. AutoDock Vina, it will be the free versions, and then paid versions, it is also available. Next one, it is the Gold. It is helpful for your drug discovery, especially for your covalent docking methods. It will be identify very good. What are the advantages I'm telling here? It is come under the flexible docking. So it is adjusting the error of the methods also. Error, it will be less in this Gold. Then post predictions, it will be available in this Gold if you are using the Gold doc, and it will be based upon the Python API access. And next one, it is a Swiss doc. Already I introduced the Swiss. Actually, Swiss doc, Swiss ADME, it will be helpful to identify your pharmacodynamic parameters. Swiss target protein, it will be helpful to predict your targets. And Swiss doc, it will be helpful to go with the drug designing. It's a molecular docking. So these are all the applications. It's the n number of applications available in this site. You can check it once, you will be got it. Okay. Then I'm coming to the different type of scoring functions. So this scoring functions, it will be comes under the force field basis, empirical basis, and the knowledge based. So these are all the softwares. It will be helpful to go for the scoring function. That is a molecular scoring, docking scoring function. Chem score and PMF score, it will be widely used. So this is the formulas what we are using to identifying. What is the advantages for using that FF scoring? That is mean by force field scoring means it will be helpful to fast, and it will be helpful to pre-computed grid also. And empirical scoring, it will be helpful to use the it will be exactly we can identify in the binding affinity. That is the important for empirical scoring. And knowledge based scoring, it is free energy molecular interaction you can identify. I guess you know the thermodynamic class, that is delta G, that is like free energy changes, and then thermodynamic thermolabile thermostable conditions. So these you can able to utilizing this one. These are all the molecular scoring functions and formulas it is available. So here after the molecular scoring, you have to come for the molecular dynamic stimulation. So these are all the molecular dynamic stimulation softwares. Exactly here, you can use with the CHARM. It will be the maximally utilized molecular dynamic. And GROMAS, I guess it is a this software, it is a commercial software, but it is excellent for you to identifying. Then MAX, it is also there. It is for trial purposes. I guess 30 days free trial they will allow to you. I guess you can use the MAX software for molecular dynamic stimulation also. So I'm giving here what are the softwares. It will be helpful for molecular dynamic modeling and its stimulation, like GROMAS, LAMPS, CHARM, and then Gaussian. Gaussian software, it is a very good one when you are going for the electronic structure stimulations. That is a element wise you want to identify the docking. You have to go with this. It is one of the very good best software for that. Okay. Then I'm coming to the end of this. Almost we are here. What we discussed already, that is computational drug discovery only we have to go with this. So that is why we call it as a pro-drug or the lead drug component. Okay, we can't able to tell about the drug candidate or the drug components, because once it will be cross the preclinical trial and then clinical trial of phase 1, 2, 3, 4, then only it will be considered as a drug. Before that, it will be considered as a pro-drug or the lead drug or the lead candidates only. For this also, first you have to go with that is called as a in vivo study. You have to cross check with your experimental animals, and you have to come to the human being testings. In this human beings testings, initially you have to come with the lesser number of participants as a volunteers. That is a 20 to 50 or 100 in this lesser group numbers. And then you have to come for the increasing the stages of the number of participants. Then only you can able to clearly mention about your ED50 and then LD50 values. Based upon this only you can calculate the adverse reactions also. Once you identified the adverse reactions, then only the FDA will approve your drug. That is important here. And I'm coming to the conclusion. So our idea, it will be like a phytochemical based drug discovery. Okay, so it will be helpful to n number of components that will be there from the plant-based for the therapeutic purposes. In our household, in our home remedy, what are the things if you are using? For example, in the COVID time, everybody is known about that, that is a turmeric milk, that is a haldi milk. Okay, everybody is known about it. It is called as a golden milk. Constitution of pepper and that turmeric powder, well known. Pepperin, it is a active antiviral property, and curcumin, it is a very good anti-inflammatory, antiviral, antibacterial properties. It will be there in this. But even though if you are consuming, if it is not activated properly in your system, that is in your body, so that is why commercially, the active components, what are the active components? For example, curcumin, pepperin, these are all the active components. So we identify only the active components and we plan to prepare the medications. So that is the idea for the prodrug component, especially the plant-based component. Okay. So from here, definitely the plant-based ligands, that is components, phytochemical components, it will be reviled. Having the very good interactions with the drug targeting. Almost or most of the targeting, it will be having the very good effect. And it will be the idea of combination of traditional knowledge as well as the model computational methods. Okay, so it will be giving the very good support for our pharmacological industry as well as healthy and then wealthy environment we can expect in your future. So these are all the things it will be with your hands as a young budding scientist. So another one advantages for this computational drug discovery process, it is a low cost and less time consuming, and you can easy accessible also. So many softwares are free softwares, but that cost effect also very, very less. For example, if you go for the in vitro analysis, cell viability assay, generally you want to do some antioxidant assay, cell viability assay, or cell culture techniques also, you have to spend more and more. But before that itself, we can cross-verify whether if it is applicable or not, then you have to go with this idea for the further clinical and then preclinical and then clinical studies. This is our suggestions. Yes, any questions?
Thank you so much, madam. Any questions from the participants? Any question from the participants? If there are no questions, we can conclude the session. You can be in touch with madam. So we can now start the oral presentation. Jemima, can you take over?
Yes, sir.
Yeah.
So I would request you to tell the rules and regulations for the oral presentation.
Yeah, the presentation will be for 10 minutes. At the end of 8 minutes, there will be a short buzzer sound. And at the end of 10 minutes, there will be long buzzer sound. So I expect all to be present throughout the session. At the end of the oral presentation, we'll be announcing the winners for the session. So you can please wait for the attractive moment. Yes, Jamima, please take ahead.
Yes, sir. Thank you. So, I would like to call up first Omkar for his oral presentation. He would be presenting his presentation on fruit peel biofertilizer. So, Omkar, are you there?
Yes.
Yeah, you can use the screen.
So good afternoon.
Please go ahead.
Omkar, I would request you to please on your camera if you're doing oral presentation.
Uh, I'm sharing slide. One second. Uh, oh, hello everyone. I'm audible.
Yes, you are.
May I start presentation?
Yeah, you can.
So good afternoon, everyone. I'm here to share our research on how fruit waste can be used to make biofertilizers that improve the crop's soil health effectively. So I am Omkar from the MGM Institute of Department of Biotechnology. So let's get started. So farming in India faces big challenges like poor soil health and heavy use of chemical fertilizers. We studied how to turn fruit waste like papaya and watermelon peels into the biofertilizer using a simple method called as solid state fermentation, where microbes grow on the solid materials without the free liquid. We tested these fertilizers on fenugreek plants for better height, more leaves, and healthier growth compared to the untreated ones. So this shows that fruit-based biofertilizers can replace the chemical ones and helps the environment. So let's understand the problem. So let's begin with the introduction. So in India's farmers suffer from overusing chemical biofertilizers, which harm soil and pollute nature. So biofertilizer offer a natural solution. They add nutrients, soil health, and eco-friendly. So in this study, we used papaya and watermelon peels as a raw material or biofertilizer because they are rich in nutrients. So let's look aim to achieve. So next one is the objectives. So first one is the formulate biofertilizer. We develop the biofertilizer using the fruit waste like papaya and watermelon peels. So next one is the utilize the microbial stain. In this, we utilize the beneficial microbes like rhizobium and bacillus for nitrogen fixation. So third one is the applying solid state fermentation. In this, we optimize solid state fermentation to maximize the biofertilizer efficiency. So in last one, test biofertilizer efficiency. In this, we test the effect of biofertilizer on fenugreek plants under the control condition. So next one, I will talk about the materials and methods. So materials, papaya and watermelon peels from the local market were collected. The next one is a simple chemical like agar, salt. Next, tools like autoclave and shaking incubator. Keep these things clean and measure the results. So let's see the how we prepare the tested the biofertilizer. So first, we collect the fruit paste and store it at room temperature for 1 week and grow microbes naturally. Then we crush the waste into the paste to make the nutrient-rich microbes. So then we dilute the fruit waste and spread on the nutrient plates. After incubation, we identify bacterial colonies using gram staining and the other simple tests. So next one is a biofertilizer application. We tested the biofertilizer on fenugreek plants because they are widely grown and sensitive to the nutrient availability, making them ideal for testing growth impacts. So first we divide plants with treated and untreated groups. Then we apply 10 ml of biofertilizer to treated plants. Then we monitor the growth weekly, measuring heights, leaf count, and health. So next one is the result. So we isolate the both gram-positive and gram-negative bacteria, including Escherichia coli, with helps in nitrogen fixation. So in this, we got the number of colonies of different variants, the colors, and the elevation ion size are respectively. So the colony size distribution across the dilution are given below. So we got the gram-positive and gram-negative bacteria. Both of these 50% are distributed. So next, these are the indole test results. Indole test results across the dilution. Plants treated with biofertilizer or grew better. In this, average height of treated ones are 20.7 centimeter, and the non-treated is 15.3 centimeter. Average leaves in treated ones are 12, and untreated ones are 8. Treated plants are healthier and greener. So effect of biofertilizer on the fenugreek plants shows the growth parameters, average plant height, and green light effect and darkness effect. So next one is discussion and conclusion. So results show that using fruit waste for biofertilizer has many benefits, such as boost plant growth and natural nutrients, improve soil health, reduces the agricultural waste and chemical pollution. To summarize, fruit waste biofertilizer improve plant growth and soil health. They are eco-friendly and cost-effective alternatives to the chemicals. Future studies can expand this method to the other crops. So these are the references we are using for our paper. So thank you for listening.
Okay. Any question from the judges?
Yes, sir. Can you tell me about that? Did you compare any commercially available biofertilizers as a control?
Yeah, we will come here with the chemical fertilizer. So the cost of chemical fertilizer comparing to the traditional biofertilizer as low are fast higher. Yes, ma'am.
Can you show the result for the comparison?
Yeah, but I can't mention here. So these are the picture line of work. We
Okay.
expect
Okay, can continue.
so
Jamima?
Thank you, Omkar, for your presentation. Next, I would like to call Akash for his oral presentation, and he'll be presenting his presentation on comparative antibacterial analysis of natural products against Staphylococcus aureus isolated from fresh wound samples. Akash, are you there?
Hello, am I audible?
Omkar, can you just switch off one device from your place?
This is my device.
Is this Akash?
Yes, yes, yes.
Okay, go ahead.
Um, Good afternoon. My name is everyone. Good afternoon, everyone. My name is Akash Chaudhary. Today, I will be presenting on the topic natural antimicrobial agents in wound care. Specifically, we conducted a comparative analysis of honey, turmeric, and neem oil against Staphylococcus aureus with my
Share your
partner
screen.
Himanshu Patil. I will start
Akash,
with overview. This
Akash,
study
share your screen.
Hello, Akash.
focuses on S. aureus,
Akash,
gram-positive bacterium
Akash,
known for complicating wound healing by forming biofilms
Akash,
and
are
Akash,
we audible to
Akash,
you?
Akash, please share your screen.
Yeah.
sorry. This study focuses on S. aureus, a gram-positive bacterium
Akash, share your screen.
known.
Om, if you can hear, you can remove your share screen. Yeah. You can share your
Is my
screen.
screen visible?
Yeah, we are able to see.
Hello.
Yes, go ahead.
So I will start with an overview. This study focuses on S. aureus, a gram-positive bacterium known for complicating wound healing by forming biofilms and resisting treatment. This makes managing such infection challenging, especially with rising antibiotic resistance. We explored natural alternatives, honey, turmeric, and neem oil, and tested their antibacterial efficacy at different concentrations using the well diffusion method. Honey showed the most promising result, particularly at a 50% concentration with a 1.5 centimeter inhibition zone. Neem oil demonstrated dose-dependent activity, while turmeric showed consistent antibacterial effect at lower concentration. Our findings suggest this natural agent can serve as effective alternatives to antibiotics, reducing the risk of resistance development. Now let's delve in the background of the problem. S. aureus is a common pathogen associated with wound infections. It can form biofilms which act as protective barriers, which make infections difficult to treat and prolonging the healing process. Biofilms also increase bacterial resistance to antibiotics, which natural agents like turmeric and neem oil for their ability to restrict biofilm, reduce inflammation, and promote tissue repair. They provide a sustainable and effective alternative to synthetic antibiotics. With this context in mind, let's move on to our study objectives. The primary aim of the study was to evaluate the antibacterial efficacy of honey, turmeric, and neem oil against S. aureus. We used the well diffusion method to measure inhibition zone at various concentrations and assess the potential of these natural agents as alternative therapies for wound care. Our goal is to address the channels of antibiotics resistance by exploring sustainable and effective solutions for infection and management. Good afternoon, everyone. Myself, Himanshu Patil, and I will continue with materials. For this study, we used Mutor agar as the growth medium for Staphylococcus aureus. The bacterial culture was standardized to the 0.5 met Faraday standard to ensure consistent results. Our antimicrobial agents included honey at concentrations of 25%, 50%, 75%, and 100%. For turmeric, it was at 10%, 25%, and 50%. And for neem oil, it was at 25%, 50%, 75%, and 100% with isopropanol used for dilution. And other materials included sterile cotton swabs, pork borers for well creation, and an incubator set at 37 degrees Celsius. Next, I'll plan explain the methodology. So our methodology involves several key steps. The first is we isolated Staphylococcus aureus from a bone specimen. Second, Mueller-Hinton agar plates were prepared and inoculated with a standardized bacterial suspension. Third, using the sterile cork borer, we created wells in the agar plates. Then next step was each well was filled with 100 ml of respective antimicrobial solution at desired concentrations. The fifth was the plates were then incubated at temperature of 37 degrees Celsius for 28 to 48 hours. And the last step was inhibition zones were measured with a caliper to determine antibacterial activity. So now let's now discuss the results that we have obtained. Our results showed significant antibacterial activity for all three agents, but it was with varying degrees of effectiveness. For honey, demonstrated the highest inhibition zone at 50% concentration, measuring 1.5 centimeter. For turmeric, exhibited consistent inhibition zones of 1 centimeter at both 25% and 50% concentrations. For neem oil, it showed dose-dependent activity with the largest inhibition zone of 1.1 centimeter observed at 100% concentrations. So to visualize these results more clearly, let's look at the graphical representation. So here we can see a bar graph comparing the inhibition zones for honey, turmeric, and neem oil at the different concentrations. For honey, it shows peak efficacy at 50%, while neem oil's effectiveness increases with concentration. And for turmeric, maintains a stable antibacterial activity across the tested concentrations. So now let's interrupt these findings in more detail in the discussion. The results indicate the potential of these natural agents in wound care. To begin with, honey's effectiveness at 50% can be attributed to its hydrogen peroxide release, low pH, and osmolarity. For turmeric, active compound curcumin disrupts bacterial membranes and inhibits biofilm formation, leading to a stable efficacy. For neem oils, dose-dependent activity highlights the importance of higher concentrations with compounds like azaridine playing a key role. So these findings reinforce the feasibility of using these agents as alternatives to antibiotics, especially in cases of biofilms-related infections. Now Akash will continue with summary. I will now summarize our finding and conclusions. To conclude, these studies demonstrated the antibacterial efficacy of honey, turmeric, and neem oil against S. aureus. Honey at 50% concentration had the highest inhibition zone of 1.5 centimeters. Turmeric showed consistent activity at lower concentration. Neem oil exhibited significant dose-dependent effect with peak activity at 100%. This natural agent offers promising alternative to synthetic antibiotics, helping address antibiotic resistance. Future research should focus on combination therapies, clinical trials, and optimizing their application for real-world use. Here are the key references we rely on for our study. Thank you.
Thank you, Akash. Judges, is there any questions you would like to ask them?
Okay, sir. Any questions? Dhanlakshmi madam, any questions? If there are no questions, Jamima can call the next person.
Okay, next I would like to call Ronit. Is Ronit there? He will be presenting his presentation on optimizing testosterone through nutrition.
Yes,
Ronit?
ma'am.
Okay. Yeah, you can share your slide.
Successfully. Is it visible for all? My slide.
Yeah, it is.
Can I start now? Hello. Hello.
Yeah,
The
you
slide
can.
is visible.
Yes, okay. Good afternoon, everyone. Myself Tony Saur, and today I will be presenting our overall title. Wait. Okay. Is it visible for all? My slide.
Yes, yes, it is.
Good afternoon, everyone. Myself Tony Saur, and today I will be presenting an overall title: Optimizing Testosterone Through Nutrition, a comparative review. This work has been carried out in collaboration with my team, Om Joshi, Jay Chaudhary, Omkar Agre, and Akash Chaudhary, under the Department of Biotechnology, MGM University, Chhatrapati Sambhaji. Let's see the overview of our study. This slide provides an overview of our work. In this review, we examine how nutrition impacts testosterone synthesis, metabolism, and bioavailability, with a focus on its relevance for active performance. We analyze dietary factors such as micronutrients, particularly fat quality and protein intake, common beverages like caffeine and carbonated drinks, specific, specific foods such as soya products and junk food. Our finding emphasize need for more robust research to confirm these nutrition effects and develop strategies for optimizing testosterone levels. Let's see the introduction for testosterone is a key hormone for male health, involved in regulating spermatogenesis, secondary sexual traits, and fertility. Beyond physical roles, testosterone also affects psychological factors such as mood, aggression, and risk-taking behaviors. Testosterone production is regulated by the hypothalamic pituitary gonadal axis, which ensures balance secretion. Distortion in the balance can lead to hypogonadism or testosterone deficiencies. Now, why nutrition is important? Emerging evidences show that dietary choices can increase circulating testosterone levels, which are particularly circular for athletes aiming for peak performance. In this presentation, we will explore how specific dietary habits impact testosterone production and its related functions. Why are you doing this project? Slide 4. Dietary fat and testosterone. Let's start with the role of dietary fat. Testosterone synthesis begins with the cholesterol, meaning fat intake plays a significant role in hormone production. Here is what research shows. Low fat diets reduce testosterone levels, including total testosterone, free testosterone, and other sex hormones. In a meta-analysis of 6 studies with 206 participants, low fat diets resulted in a significant decrease in testosterone, especially among men of European descent. The type of fat also matters. Saturated fats appear to increase free testosterone and SHBG, while other fats like MSG and trans fats show no significant impacts. Let's see the caffeine impact on testosterone. Now let's look at caffeine, which is widely used and ergogenic aid to to enhance athlete performance. A study investigated caffeine's effect on testosterone and cortisol levels during exercise. Caffeine does up to 800 mg were given before resistance exercise. Results showed results showed a 50%, 15% increase in testosterone during exercise with a concurrent 52% increase in cholesterol at the highest dose. While caffeine boosts testosterone, the stimulation rise in cortisol and stress hormone could concentrate some of these benefits by reducing the testosterone to cortisol ratio. Hello everybody, myself Om Doshi. I will carry forward the presentation. Now here we explore the effects of carbonated beverages such as Pepsi Cola, Coca-Cola on testosterone. In an animal study, mice consuming 100% carbonated beverages showed increased testis mass and dimensions along with higher levels of androgen receptors. Serum testosterone concentrations were elevated in mice consuming Pepsi Cola compared to Coca-Cola. Now, these findings suggest a potential impact of carbonated beverages on testicular development and testosterone secretion. However, it is important to note that this study used animal models, which may not directly translate to humans. Mechanisms behind these effects remain unclear, requiring further research in human trials. Now, let's understand the effects of soy consumption on testosterone. Soy products contain phytoestrogens, specifically isoflavones, which mimic estrogen in the body. Here's what the study case reveals. A 54-year-old man consuming 310 milligram per day isoflavones through soy milk developed hypogonadisms, which resulted in low testosterone, gynecomastia, and ED. Symptoms reversed after discontinuing the soy consumption. Mechanisms suggest that isoflavones may disrupt the hypothalamic pituitary gonadal axis, suppressing the testosterone production. While moderate soy consumption is considered safe, excessive intake, especially long term, could negatively impact the male reproductive health. Next, let's discuss the protein intake and testosterone. The research highlight shows protein intake exceeding 3.4 gram per body weight kilogram per day consistently reduces the testosterone levels. This occurs due to the body which upregulates the urea cycle to handle the excessive ammonia, which is produced during the protein consumption and digestion. It diverts resources away from the testosterone synthesis. But however, most athletes consume protein below this threshold, meaning moderate intake has no significant side effects. Future research is required to conclude the integrated relationship between testosterone and protein intake, which can be used to explore the protein levels between 2.5 gram per body kilogram per body weight kilogram per day to 3.5, 3.4. The role of protein sources such as animal protein, plant protein, and the exercises mitigating the effects of testosterone. Now let's understand the relationship of junk food consumption and testosterone. Junk food consumption is another critical factor which influences the testosterone levels. A study found out that Western diets, which are high in processed foods, sugar, and saturated fats, leads to low testosterone, increased in visceral fats, and decreased muscle mass. Conversely, diets with dark green vegetables, lean protein, and saturated fats showed higher testosterone levels. These results emphasize the need to limit junk food and adopt a healthier dietary habits to support hormonal balance, health, and overall health. Now let us move towards the discussion and conclusion. To summarize, healthy fats and a moderate protein intake positively influence testosterone levels. Excessive soy, junk food, and carbonated beverages have negative effects. Caffeine can boost testosterone, but excessive intake raises the cortisol levels. Lifestyle factors such as regular exercise, adequate sleep, and maintaining a healthy body weight are equally important for hormonal regulation. Optimizing testosterone levels requires a balanced approach. Prioritize healthy fats, adequate protein, whole foods, avoid excessive junk foods, soy, sugary beverages, and maintain an active lifestyle. With further research, we can develop better strategies to promote testosterone balance for health and athletic performance. Thank you for your time.
Judges, any questions?
Judges, yes, Satish sir.
Puneet, how did you collected the data for this? For the verification of the level of these?
Sir, this is a review
Subject-based,
presentation.
or it is based on some test, medical test or
Sir, we collected the data from various research papers. These tests were either total testosterone levels along with their dietary habits, or free testosterone or serum testosterone levels were checked.
that is all the secondary data you have taken.
Yes, sir.
Okay, right. Yes, sir. We can move to the.
Yes, sir. Madam, any questions? Okay. Jemima, you can move on.
Okay, so thank you, Ronit. I would like to call up the next participant, who is KS Shri Rajeshwari Devi, who would present her presentation on exploring the intersection of psychology, parapsychology, and philosophy. Are you there?
I think she is not there. You can carry on to the next person, Jemima.
Okay, sir. Next is Shri Kanya Roy. Is she there?
Yes, I'm there. Yeah.
Okay. She would be presenting her presentation on identification and characterization of the tau protein mutation and their role in protein structure and function. Go ahead, Shri Kanya.
Slides are visible.
Yes, it is.
Good afternoon, everyone. Myself, Srikanna Roy. Today, I am going to present under a research scholar from Department of Biochemistry and Biophysics from Kalyani University under the joint supervision of Dr. Rakhi Dasgupta Madam and Professor Angshuman Bagchi Sir. Today, I am going to present my work titled Identification and Characterization of the tau protein mutations and their role in protein structure and function. So this is the brief outline upon which the talk will be based on. So getting into the introduction, tau protein is a 441 amino acid long protein, which is a microtubule associated protein. Its structure consists of 2 inserts and 3 N-terminal repeat sequence, due to which it is majorly has 6 isoforms. For this study, isoform ON4R was considered and is regarded as tau wild type protein from henceforward. It is a protein that is majorly related with stability of microtubules, that in turn is essential to maintain the structure and transport function of neurons. Hence, abnormal modification of tau contributes to various diseases related to the nervous system that are widely known as tauopathies. Some important mentions will be AD, PSP, FTD, and etc. From literature evidences, it has also been seen that FTD has been linked with Parkinsonism 70. Now, coming to the research objective of this study, we had three objectives. For the first objective being identification and characterization of the SNPs that are present within the tau protein. Objective 2 was to record the impact of the SNPs in the protein structure as well as in this function. And objective 3 was to study the effect of the SNPs on disease pathogenesis. This can be the research methodology that we have followed, and it can be divided into three major sections. The first one being identification, the second being the characterization, and third being the analysis of the results. So coming to the results section, we first retrieve the sequence information of wild type tau from protein data bank, and thereafter use that sequence for mutational analysis. Two tools, predict SNP and align GVGT, were used. The methodology that we followed was for each of the tool, a threshold value of 80% was selected. SNPs that showed value above the threshold in any of the tool was given a score of 1, indicating it being pathogenic from that tool. A total of 8 different SNPs were used, which we can see in the left-hand bar diagram. And the total 8 different tools were used, and all these SNPs were evaluated, and the bar plot was generated. Where we can see that the red indicating SNPs are the pathogenic SNPs. From that, we got the right-hand bar plot, where we can see that the red is the highest scored pathogenic SNPs, and these were separated, and the particular SNPs are shown in the red box. And should be noted that we have studied these 7 SNPs henceforward. So now, to gain knowledge about the region in which these SNPs were present, we have performed sequence conservation study where we identified that SNPs positions, and as you can see that the pulsating boxes are representing the particular SNPs. And from this study, we saw that 6 out of the 7 selected SNPs remained in the conserved region of the wild type protein. Now coming to the SASA value calculations of each of the mutants with respect to the wild type, and it is shown in the bar plot here, where blue indicates the wild type amino acid residues and the red indicates the mutant residues. Similar trend of apolarity was seen, where 5 out of the 7 SNPs which are shown in the pulsating green box have an increase in apolarity. Next, coming to the protein stability of each of the mutant, we have plotted a line graph for the del G values of each of the mutants, and the mutants which attain more stability remain above the linear lines of each of the graph and are represented in green here. Lastly, the physicochemical properties of each mutant were checked. The noteworthy results were for mutant P301L and P427M, as shown in the chart, are probably damaging SNPs, and G335B is the most pathogenic SNP, which mimics our initial finding of the pathogenic mutants. We also saw the protein-protein networking systems of the wild-type tau protein, where in the left-hand figure, we can see that MAPT, or the tau wild-type protein, is closely associated with various other proteins that are key players in neurodegeneration. For instance, APP, amyloid precursor protein, related with Alzheimer's disease. Similarly, SNCA, or alpha-synuclein, is related to PD, and etc. We also clustered this network, as we can see in the right-hand diagram, and 3 main clusters were coming up, which are shown in the color coding. This study shows that the tau protein is in fact in the central hub of different neurodegenerative diseases, Alzheimer's and Parkinson's disease being at its epicenter. And it also shows that tauopathies can be studying the particular SNPs that are present in the tau wild type can give us insights about the tauopathies. So coming to the conclusion of this study identifies the most important SNPs which are present within the tau protein. We were also able to characterize these and categorize these SNPs according to their pathogenicity and identified G335R as the most pathogenic SNP of the select 34 ones. The recommendation of the study might be that we can insert these SNPs and study their dynamicity in the cellular environment. That will give us a valuable insight into tauopathy. These are some of the references that I have used for my study. Now, I would like to acknowledge DBT for supporting me with this study and also for providing me with a fellowship. I'm thankful to Coordinator Professor Angshuman Bakchi sir of BIF Center for providing me with infrastructural facility. I'm thankful to University of Kolkata for providing me with plagiarism check facility. I'm grateful to my supervisors, Dr. Rakhita Ashmita Madam and Professor Angshuman Bakchi sir for their guidance. And I'm also grateful to my lab members for their constant support. Thank you.
Thank you, Sri Kanya. Judges, is there any questions you'd like to ask her?
Judges? Sankesh sir? Madam?
Hello.
Okay.
Hello.
Yes.
Yeah. Nothing was audible at that moment. Can you, if anyone has any question, can you?
No. Yeah, I have a question.
Yes.
I just wanted to know, did you compare the SNPs which you have received using the DBSNP database of NCBI?
Sir, the SNPs were primarily located by using literature mining and these are already established SNPs, I guess. So, so
You
that
are
is
telling established SNP, I guess. That is why I asked, did you compare or check it out, cross-check with the DB SNP because all the established SNPs are there?
I believe we have not used that methodology here, but I have procured the SNPs through literature mining itself, and these are in fact established SNPs.
Okay, so you have taken the SNPs directly from the protein sequence.
No, sir.
Then
These SNPs were present in various literatures, which I
literature.
have mined and then again used it.
Okay. And you have in the one of the last slide you have mentioned that the particular SNP was related with some when it was the most pathogenic, I think you have mentioned.
Yes, sir. If I can
So
go back to that slide, just yes,
yeah,
sir.
is it associated with any disease?
Sir, all these SNPs are in fact associated with various tauopathies.
Okay.
This one particularly, I have seen that it is being related with Alzheimer's, but some significant study has also been showing that this particular SNPs also can be related with Parkinsonism 17. But this is also very like new genre of studying of these SNPs with tau. So. Might be might come with another possible disease association. So till date, it can be said that this particular SNPs is related with AD as well as Parkinsonism 17.
Okay, that's all from my side.
Okay. Thank you, Sri Kanya.
Yeah.
Next, I would like to call Jeet Mondal, who would present his presentation on circular RNA. Jeet, are you there?
Yeah. Hello. Yes, ma'am.
Okay. Sri Kanya, can you please stop sharing your slide?
Yes.
Jeet, you can take over.
Is my slides are visible?
Yeah, it is.
Okay. Good afternoon, everyone. Myself, Jeet Mondal, CSIR UGC NET Senior Research Fellow, under the supervision of Professor Unshuman Bakchi sir, of the Department of Biochemistry and Biophysics at University of Kuldani in West Bengal, India. Today, I'm discussing about my work on circular RNA, an important biomolecule to control gastric cancer. This is the outline of my work, consists of some following points. In recent days, circular RNA gained momentum on current research works in different fields. Initially, they are considered as the transcriptional junks, but its role in many physiological processes, giving it more importance in the different therapeutic aspects. Circular RNAs are a specialized group of RNAs which is derived from actively transcribed genes through the alternative splicing mechanisms. Generally, they are covalently closed loop structure, which lack of 5' capping and 3' polyadeninated tail. According to their structural configuration, they are stable and resistant to RNase degradation. Circular RNAs act via a variety of mechanisms, that is IRS-mediated translation, RNA binding, protein association, mRNA sponging, and so on. So some of the other circular RNAs have the protein coding potential, and their derived peptides are associated with several biochemical pathways and diseases like cancers, neurodegenerative disorders, etc. So in this work, we found 3 distinct circular RNAs, that is SIRC-MAPK1, SIRC-PGD, and SIRC-DLG1. SIRC-MAPK1, that is HSA SIRC-0004872, which is derived from MAPK1 gene, functionally antagonistic circular RNA that targeting the MAPK1. It suppresses the proliferation and invasion of the gastric cancer via the reducing of the MAPK phosphorylation pathway. The next one is SIRC-PGD, which is derived from PGD1 gene and encode an oncogenic protein. And this circular RNA can promote the cell proliferation and metastasis while inhibiting the apoptosis by sequestering or sponging with the MIR16-5P and suppressing the apoptotic pathway. The next one is the SIRC-DLG1, that is HSA SIRC-0008583. This circular RNA derived from the DLG1 gene, which is directly interact with the MIR141-3P and functioning as a protein sponging that boosts the expression of the MIR141-3P and associated genes of the chemokine 12, which is a promoting factor or encouraging factor of the gastric cancer. So now our objective is to investigate the shared miRNA binding interactions of these 3 unique circular RNAs, that is SIRC-MAPK1, SIRC-PGD, and SIRC-DLG1. And our second objective is to finding the common gene pool linked between these common miRNAs and understanding their functions in the onset of the gastric cancer. Here is the mechanism how the circular RNA and miRNA can sponge each other, and their associated genes can regulate the upregulation and downregulation of the gastric cancer. So our hypothesis shows that these 3 distinct circular RNAs, that is SIRC-MAPK, SIRC-PGD, and SIRC-DLG1, which can share the common miRNAs, and that can regulate that is upregulation or downregulation of the gastric cancer. So in the methodology of our work, we can first retrieve the circular RNA data, including its length, complementary sequence, and its binding information and circ RNA IDs from 2 different databases. One is circ-base and another is circ-bank. And after that, we can compile this data with the help of the Venn diagram tool. Next, we sorting the data, that is the miRNA data, and with the help of another database, that is the MIRDB, and obtaining the data with its relevant genes, which is targeted or connected to the GC, and sorting this data with the help of Venn diagram tool again. After that, we can calculate the percentage of GC content of these three distinct circular RNAs and gathered the information of the mRNA mRNA linked or associated gene set of the circular RNA and the gastric cancer related gene set or gene data set with the help of the another database, that is the disease database. So next we compare these two data sets and of this antagonistic two circular RNAs and sponging of the miRNAs, and they are determining gene data set and the gastric cancer data set, and then and conclude the onset of the gastric cancer. So from the above experiment or experiment that we can find the result of the information of circular RNAs, that is the common mRNA involved in the pathways along with the GC percentage and regulation status. So from this, there are three circular RNAs. There is SRC-MAPK1, which is SRC-PGD and SRC-DLG, which GC% content is 44.5%, 51.6%, and 44.6%. And their common gene set, their common mRNA association or interactions, that is the HSA-MIR 2085P, HSA-MIR 13P, and HSA-MIR 206, and HSA-MIR 613. All of this can find with from the mRNA DB database and with the help of this Venn diagram too. After that, this mRNA portion and their associated genes is tallied with the disease database, gastric cancer dataset, and we can find these five associated genes which can be upregulate or downregulate the gastric cancer. So from this, we obtain the five genes, which is CDK6, MET, KRAS, ASH1L, FBXW7, which have the both progressive and regressive roles in the advancement of the gastric cancer. Out of these five genes, there are CDK6, MET, KRAS, and ASH1L, which are the upregulated genes, and this can promote the gastric cancer. And last one, that is the FBXW7, which is a downregulatory gene, which can be downregulate the gastric cancer. So from this, we can show that there are the two contrasting group of circular RNAs functionality, and this can of the onset of the gastric cancer. So from the aforementioned research, we conclude that there are three distinct types of antagonistic circular RNAs which can share the common gene pool with the association with miRNAs and influence the gastric cancer in both positive and negative ways through this regulatory several genes. So in our future work, we must characterize the circular RNA and their interactions with the gastrointestinal cancer and their mode of binding in the of circular RNAs and miRNAs also. The bioinformatics study of this is the powerful tool which can help to interpret or identify this kind of interactions. So now I have to acknowledge my professor, Professor Anshuman Bagchi sir, for his research idea and supervision, the UGC for giving me the fellowship, all of my lab members which help to do or support in my work. I also acknowledge DBT funded Bioinformatics Facility Center and University of Kolkata. Here are the references from where I can gather the knowledge and experiment of my work and the literature evidences. Thank you.
Thank you, Jeet. Judges, any questions?
Judges, any questions? Participants? Any question from the other participants?
No questions from my side, sir.
Okay. Yeah, I have one question.
Yes,
so I just wanted to understand the significance of this study. You have taken circular RNA and you compared the and got like correlation with the miRNA. So
Yes,
what is the significance of this particular study and why you are comparing circular and miRNAs?
So actually the miRNAs can basically inhibit the gastric cancer progression, and there are two types of contrasting circular RNAs are there. The SRC-MAPK1, which is a inhibiting role in the gastric cancer progression, and other two, that is SRC-DLG1 and SRC-PGD, they are the progressive role. And for that reason, we are seeing that there are many interactions, many interacting mRNAs which can interacting with all of these three circular RNAs. So from this side, we can we're not concluding. Actually, we are predicting that the gene set which are associated with the positive regulation will related to the SRC-PGD and SRC-DLG, and there is a relation between FBX. One second, sir. The FBXW7, the previous one, the FBXW7, this one, these are the downregulatory gene, which is a relation between the MEPK1. So that I can conclude this miRNA, other miRNAs also in effect in the gastric cancer progression as well as in regression, both of them.
So you are telling that it is like these are one of the causal factors for the gastric cancer.
Yes, sir.
That is the conclusion, or you are just predicting it?
Not only, sir, I mean, it is actually a prediction of, bioinformatics study. So we can conclude, but we can further study the why they can relate it in the pathway related portions. Actually, I mean, we can conclude as a data sets basically, but further we can experiment, and this binding interactions will help them to identify this portion is where it is actually particularly where it is acting or not, or acting which area actually.
Is there any reference papers?
Yes, sir.
In this particular area?
Sir, I got a paper of FBXW7, which is related to the MAPK1 pathway or MAPK phosphorylation pathway. I can see this paper, and that can downregulate, or its downregulation can inhibit the MAPK pathway. Sorry, its downregulation can progressive the MAPK pathway, which can lead to the other cancer also.
Okay, but is the paper related with miRNA and circular RNA?
Yes, yes, sir. There is a paper of miRNA and circular RNA also present in this portion of PGD and DLG.
Your paper is very much complicated. My only concern is that if you are telling this, you are presenting here.
Yes,
it's like as you told first, this is a prediction study. You are not concluding it. So, is it possible for you to publish this work? That
Yes,
is
sir.
one concern. You can think it out. You can discuss with your guide. This is just my suggestion. I am
Yes.
not telling the work is excellent, but discuss this with your guide.
Okay, sir. Okay, sir. Sure, sir.
Okay, this is my suggestion. Yes, because if reference paper should be there before you publish it in journals.
Okay, sir. Okay, sir. Sure, sir. Sir, the reference are here. I can present when I am complete the whole write up. Then I can. Okay, sir.
Okay. Any questions? Dr. Comfort is here. Dr. Wondling, can you give your insights? Okay.
Okay. Thank you, Jeet.
Okay.
Yeah. Next, I would like to call upon Dr. Rupali Thor, who would present a presentation on safe muscle tuber medicated green synthesis of silver nanoparticles and their characterization. Dr. Rupali? Jeet, can you please mute your mic? Dr. Rupali, can you hear me? Yeah, thank you. Your mic is mute. Ma'am, you need to be a bit louder. Your voice is not clear.
Now I'm audible.
Yes, ma'am, now better.
Good afternoon, everyone. Myself, Dr. Rupali Taur, Assistant Professor, MGM University, Aurangabad. I'm working as a Assistant Professor in Plant Breeding Molecular Genetics in Institute of Biosciences and Technology. So, today I'm presenting here green synthesis. That is the green synthesis from Safed Musli, which is the tuber-mediated green synthesis of silver nanoparticles and their characterizations. Basically, synthesis of silver nanoparticles using plant extract is one of the most rapid, efficient, economical, and eco-friendly strategy, which diminishes the use of the toxic chemicals. However, in current years, various environmental friendly techniques for the efficient synthesis of silver nanoparticles have been demonstrated by using the different plant parts and their various types of the extracts. The keystone of the nanoscience and nanotechnology in nanoparticles, which possess the enormous potential and have various applications across diverse fields. So nanoparticles are synthesized through physical and chemical method. These approaches are limited by concern over toxicity. So green synthesis of nanoparticles is a relatively new and emerging field offering economic and eco-friendly advantages over the traditional chemical and physical method. So that nanoparticles have the various diverse uses in various fields, that is in use in photonics, catalysts, biology, textile and pharmaceutics and drug delivery. So we focuses on the plant that is the Chlorophytum boryphenalum. So this plant is having the huge medicinal properties, and it is used in the Ayurvedic, Unani, homeopathic and allopathic medicinal system. So these plants have been attracted to the several researchers because of the significant interest from the scientists and research due to their wide range of the applications. So these plants have the uses in various medicinal properties like diabetes, arthritis, and increasing body immunity. It is a curative for natal, postnatal problem, rheumatism, and also the joint pains. It also helps in increasing the lactation in the feeding mothers and also use in diarrhea, dysentery. So there's several kind of the uses. So number of plants are suitable for the preparation of the silver nanoparticles. We have selected the Chlorophytum boryphenalum, which is in use of the centuries in the Ayurveda because of its antioxidant, anti-inflammatory, and anti-diabetic, antifungal action. So, on the basis of available literature, we select the Chlorophytum boryphenalum plant. Now, this study present and the eco-friendly synthesis of the silver nanoparticle tuber extract for reducing and stabilizing agent. So, the process was validated by using the FTIR, X-ray diffraction method, and the scanning electron
microscopy. Now the materials and methodology. So we first collected the tubers that collected from the MGM campus, and these tubers cleaned, sun dried, and we have make a fine powder, and after that make a tuber extract, and that extract is heated at the 60 degrees Celsius for 10 minutes. After that the silver nitrate solution were added. So after adding the silver nitrate solution, it shows the change in color. So that yellowish color is changing from reddish to the brown color, which indicating the nanoparticles formation. And these synthesized nanoparticles we have characterized by using the scanning electron microscopy, IDAX, FTIR analysis. So that characterization include the scanning electron microscopy, which are useful to analyze the shape, size, surface morphology, then FTIR spectroscopy, which are include to identify the functional group which are responsible for the reduction and stabilization of the silver nanoparticles. So these methods demonstrate green, eco-friendly approach to synthesizing the silver nanoparticles. So we can see here, these are the tubers. Those we have collected, we have make a fine powder, then the extract, and after that silver nitrate solution added. We can see here their color change. After that 24 hours, this extract we have centrifuged, and lastly we collect the fine powder of that the synthesized silver nanoparticles. So here we can observe that the scanning electron microscopy. So the shape and morphology of the scanning electron microscopy reveal that the exact size of that synthesized silver nanoparticles. So the green synthesis that has attracted to the researcher due to its more importance in recent times, that the green synthesis are the uniform which are having the size which are ranging from the 30 to 50 nanometer, and we can observe here that is the spherical shape of that synthesized silver nanoparticles. Next is the EDX. So that EDX pattern showing that the color transform in the dark pale yellow to the darker brown, and that extract we observe, it shows the particular size and shape. So on that basis, that is the crystalline nature we observe in the IDAX. The morphological and crystalline were examined by employing the IDAX pattern, which are revealed the spherical shape and average range size, that is the 15 nanometer. So EDX spectrum that shows the silver elements which are showing the strong peak. After that, there is also presence of the carbon, chlorine, and zinc, and also the oxygen, which are also detected in the spectrum, that are associated with the organic compound of the tuber extract on the surface of the silver nanoparticles. The presence of the zinc ping we can see here may be due to the bring some present of the grids, or it has been shown that the nanoparticles synthesized by using the plant is extract. So they are composed by a thin layer of the some capping inorganic material from the plant tuber. The FTIR spectrum we have observed here that are showing the presence of the silver nanoparticles, increasing the formation of the nanoparticles. So the range of that spectrum is leading to the 693 to 3997 range. So it shows the presence of the nitrogen and hydrogen stretching vibration, revealing the presence of the aliphatic primary amines. The broad peaks in FTIR spectrum was observed, which are also indicating the presence of the oxygen and
hydrogen stretching, vibration, those are indicating the presence of the alcoholic group. Then again, we can observe the band in the range of the 1672, which are showing that the presence of the aldehyde esters and aliphatic ketones. So there is a range presence of the peak from 938 to 693, that is corresponds to the presence of the chlorine, boron and zinc ions, which are the substituted of the compounds. Now, these are the elements which we can see. So the silver nitrate that are also present, which are showing the strong signal and their molecular weight in the given analysis. So this study demonstrates the successful green synthesis of silver nanoparticles by using chlorophyllum, borifenol, tuber extract. Upon mixing the extract of the AgNO3 solution, here we observe that the change in color, that is yellow to brown, indicating the formation of the silver nanoparticles. FTIR analysis also showing the presence of the alkane, ketones, aldehyde, esters groups. Then we have also observed that the same and index analysis, so the maximum average particle size, which is ranging 30, 50 nanometer, and we obtain that is also the 45 nanometer. The crystalline nature of the nanoparticles was also confirmed by the selected area by using the EDX. So elements like carbon, chlorine, zinc, and oxygen were also detected. Conclusion. So in this study, a successful, rapid, and green synthesis of silver nanoparticles was achieved using the chlorophytum borealis, and the tuber extract as an effective reducing and the capping agent, different methods, including like SEM-IDEX, FTIR. So we are successfully used to characterize synthesized AGNPs, and this novel method for the environmental friendly by synthesis of the silver nanoparticles and the number of attractive feature and provides the effective appropriate means for the protecting the environment. Thank you.
Yeah, thank you. Any question from the judges?
Yes, sir. I have one question. Can I know the reason for why you are choosing for silver nanoparticle synthesis?
Because it having the huge application in the drug delivery and also the surgery. So we are thinking to provide a raw material because we are thinking to make a startup on it. We have also have the communication in few companies. So basically we are focusing on the silver nanoparticles. We are also, ma'am, extracted from different parts like seed, pills, leaf. So that is the reason.
Okay, but even it is not a common nanoparticles. Okay, silver nanoparticles, it is not common for all the drug delivery purposes. Okay, if you're going for anti-arthritics or anti-diabetic, each and every one, it will be having some specifications. Okay, so if you're designed the drug field, the production field of your drug, then if it is applicable.
Yes,
Right?
ma'am. It also now
Any drugs
current research is also, ma'am, for the drug delivery system and also some transgenic technology to transfer a gene. So our focus is how it acts as a mediator. So it can be for not only the drug delivery and also the transfer a gene. For example, agrobacterium mediated system, it also have the use because easily agrobacterium does not take any kind of the gene easily. It is always called as a natural genetic engineer, but we are also focusing for that strategy.
Okay, did you have any literature for this? This nanoparticles, it will be helpful for the...
Yes, ma'am. We have a literature for that.
Okay.
Any more questions? So I guess it's done. Thank you, ma'am.
Thank you.
Now I would like to call Mr. Irfan Abdul Latif, would be presenting his presentation on developing resilient speech emotion recognition systems through deep learning and audio augment for enhanced emotion detection. Are you there?
Yes, Jamil.
Yeah. Okay, you can take the screen, sir.
Yeah, very good evening, all of you. I am Irfan Chaugule, and I'm pursuing my PhD from MGM University, Chhatrapati Sambhajinagar, under the guidance of Dr. Satish Sankai sir, who is associate professor from MGM University itself. My research topic is development of speech emotion recognition using deep learning. Under that title, I started my research journey by finding the existing literatures and I mean what research has been done in this area. So I came across that there are, I mean, still we are struggling with the accuracy for speech emotion recognition, and that's what I discussed with my guide, and we came across that we can increase the accuracy by comparing the different model, by hybridizing the different models, and we have started the work, and the first step in this is developing the resilient speech emotion recognition system through deep learning and audio augmentation. So this augmentation technique we introduce here for enhancing the speech emotions. So let me tell you first what is SER. So SER is speech emotion recognition, enables system to detect and interpret emotions from speech and enhancing the interactions. So basically, ACR represents a vital component of human-computer interaction, offering systems the ability to interpret human emotions and improve the user experience across the different domains, such as customer service support, healthcare, for recognizing the mental health, and the entertainment industry. So this study explores how deep learning combined with the data augmentation technique and how this technique can improve SCR performance, particularly in noisy environment. Because when we take the clean data, then obviously we will get the higher accuracy. But the challenge is to get the accuracy in noisy environment. So utilizing convolutional neural network, that is CNN, and recurrent neural network, that is RNN, alongside augmentation methods such as Gaussian noise addition, pitch shifting, time shifting. So this augmentation technique we have introduced, and the approach enhances the SCR robustness against audio variability. Experimental results demonstrate substantial gain in the model resilience and generalize the result under the noisy conditions, indicating strong potential for deployment of adaptive and emotion-aware applications in practical environment. Still, while implementing this, still there is a challenge of overlapping the audio signals. I mean, this is the big challenge for all the researchers in this area. So as I said, that why is it important? So SCR improves the human-computer interaction essential in the field of customer service, healthcare, and entertainment. Challenges, as I said, that still noise condition is a challenge. Different accents are the challenges. Speaker variability is challenge, and the audio overlapping is also a challenge. Our approach is we explore the deep learning and audio augmentation technique to enhance ACR accuracy and robustness, because we found that when we comparing the previous models, then when we introduce this augmentation technique by injecting the noise in the audio and increasing the diversifying the data set and applying the deep neural networks, then we found that we have increased around 40%. We got the increase in accuracy. When you talking about the CNN, so this is the deep learning algorithm which excels at identifying special patterns in audio spectrogram, capturing vocal nuances, and improving audio analysis. I mean, this is talking about the feature extractions, the different features extractions like pace, voice, then time, variability, regularity in the audio signal. RNN, particularly LSTM, short-term memory, are highly effective at processing temporal dependencies in speech, enabling better understanding of the speech sequences. And when we hybridized these two models, then we got surprised and we got a better result because we are able to leverage both spatial and temporal information by combining CNN and RNN, resulting in enhanced performance in this complex task. The purpose of audio augmentation is artificially expand the data set and introduce variations to improve model generalization. This helps in creating more robust model that can perform better in a real world scenario. I mean, at some point of, at some level, I'm not exactly saying that it's completely working on real world scenario, because still, as I said, that audio overlapping is the big challenge. The technique is various methods used to enhance audio data include Gaussian noise addition, which involves adding random noise to audio signals, like pitch shifting, which alters the pitch of audio without changing its duration, time stretching, which changes the speed of audio playback without affecting the pitch, and the time shifting, which shifts the audio signal in time without altering its content. The benefit of these techniques increase the model resilience to noise and speaker variability, ensuring that the model can handle diverse audio inputs effectively. The methodology used here, so we have used secondary data sets here, like RAVDES, EMODB, and IMO-CAP. So these datasets provide diverse and robust audio samples essential for training and testing the models. In data augmentation techniques are applied to the training data using augmentation library like Librosa. And the implementation is done by the programming language, Python programming language. So this enhances the model's ability to generalize by creating variations of existing data. In model architecture, the model employed including CNN, RNN, and by combining these two algorithms, these models are chosen for their ability to effectively process and analyze the sequential audio data. Training is conducted using categorical cross entropy loss and Adam optimizer, ensuring efficient learning and convergence of the model. Evaluation metrics. So model evaluation is based on metrics like accuracy, precision, recall, and F1 score, providing a comprehensive assessment of the performance. Here, there are some comparisons on clean data and noisy data. So you can see that by implementing CNN, we got 85% accuracy, for RNN 88%. And when we hybridizing these two models, then we got 90%. So hybridized model is performing well as compared to individual algorithms. So accuracy on noisy data, CNN 75%, RNN 78%, and hybridized model giving 82% accuracy. So as I said, that clean data, there is a lot of difference in clean and noisy data, but still we got a good accuracy in noisy data. And after augmenting when we check the accuracy, then CNN got 87%, RNN got 89%, and this hybrid model got 93%, which is better than without augmentation technique. So here we got 11% more accuracy when we apply augmentation technique. So the impact of augmentation: significant improvement in robustness due to data augmentation by introducing varied data scenarios. The speech emotion recognition system have shown enhanced performance and resilience against unexpected inputs. The limitations, as I said, augmentation may not perfectly simulate all the real-world noisy conditions. While it offers robustness, it cannot fully replicate every possible noise scenario encountered in real-life applications. The conclusion for this is reiterate the effectiveness of the deep learning and augmentation for building resilient ACR systems. These technologies play a crucial role in advancing the reliability and accuracy of speech emotion recognition. There is a scope of further development for this. After this, applying the augmentation, the next step would be the pre-processing, where we are analyzing our data set, cleaning our data set, and then we will be using different model. Maybe I'm planning to implement the distillation model so that we can hybridize multiple models together, and then that model, this is the deep learning model. So we will be trying to automate this process. I mean, the automation of the feature learning by the model itself, and then we will improve the more accuracy by implementing that hybrid model in the future. So this is all about my research work so far. Thank you.
Thank you, Irfan. I would like the judges, if they have any questions, they can please ask him.
Yeah, I have a question. The title of your work says that speech emotion recognition system, whereas in your presentation I did not find anywhere speech. It was completely of noise. So there is a much difference between speech and noise. Speech means it can be like what we are talking, communicating with each other, and noise is something which we cannot understand. So how do you differentiate both speech and noise, or how do you
So
relate?
yeah. Yes, sir. So basically, I mean, I have started this research, and so far I have implemented this augmentation technique only. So till now, we are not working on the real emotion recognition, real predictions. So we are applying the different techniques of data augmentation. After that, we will be moving to the data pre-processing, and then we will be going for the hybridizing the different models which are exist from the deep learning neural networks, applying the different models in deep learning. So this is the initial phase of our research, sir.
I just asked like speech and noise. How do you differentiate it? Speech
Uh,
and
Noise is like, sir, in the form of overlapping. I mean, when we say that, let's say, speech is, if we say something, this is a speech, but any background noise is can be there, or any overlapping audio or speech is there. So this is the noise. Actually, we can call it as a noise.
okay. So you have just taken the data set from various databases, and you have
Yes.
not taken any real world or real time data set.
Yes, sir.
So, are you planning to use the human language, or how you are planning?
No, sir. Actually, my focus, research focus is the accuracy, because still there are chance to increase the accuracy, because when we go through different papers, so I saw that still there is a problem of accuracy in speech emotion, because of this noise and other parameters also. So still we are not getting that much accuracy when we change the environment, or when we introduce new features. Then still there is a chance to increase the accuracy, sir.
So, are you using any existing algorithm, or you have developed your own algorithm for this?
I'm planning to develop my own algorithm, because
Okay.
there are different algorithms. So a lot of study has been done, and a lot of people has already used different deep learning neural network algorithms like CNN, by LSTM, then your RNN, then machine learning algorithms are also used. But you, when you see, I have explained that when we combining the different models together, then we will be able to increase the accuracy. So this way I'm going, and I'm developing my own algorithm by hybridizing different algorithms, and then I'll proceed.
Okay. Okay. Good work.
Yeah. Yeah. Thank you. Thank you, sir.
Okay, thank you.
Thank you.
So, I guess there is no more questions now. Yeah. So now I would like to call the next participant, who is Shreya Pahune.
Hello, good evening. Should I share my screen?
Yeah, sure. Go ahead.
Okay. Hope it's visible.
Yeah, it is.
So good evening, everyone. Before I begin, I'd like to thank the Vashish genomic teams and everyone present here for your time and attention. So today I'll be presenting our work on using machine learning to classify glioma subtypes and predict mutations using transcriptomic data. So gliomas are basically brain cancers. And what we do is our approach offers a novel solution for precision oncology in brain cancer treatment. So this work is done by me and my advisor from Triple IT Hyderabad. Continuing, gliomas represent about 1/3 of all brain tumors, and they pose significant medical challenges because they're very heterogeneous and aggressive in nature. And this aggressive nature increases with stages. So, as you can see, the main two subtypes of gliomas would be the LGGs and GBMs, that is the low grade glioma and the glioblastoma. So, low grade glioma is classified as stage 2 and 3, whereas GBM is classified as stage 4. So, what happens is the traditional diagnostic methods often they're not able to capture the complete genetic complexity of these tumors, and this leads to very limited treatment options. And this is where our precision oncology approach comes in. So this is what we have considered. We have the complete diffuse glioma data set, which the details I'll be going into in the next slide. And the two main subtypes are LGG and GBM. Within them, we have tried to do a subtype classification. Apart from that, we have also done identification of key mutations for each of the main subtypes. So coming to the data set, we analyzed 667 samples from the Cancer Genome Atlas, which is this a major project which collects different sequencing mutation clinical data for different cancer samples. And we include both low-grade low-grade gliomas and glioblastomas. I've provided the links over here, and this is our sample distribution. So as part of pre-processing of this data set, we do variant stabilizing transformation, and this gives us a final matrix of 556,603 genes per sample. And in our pipeline, we integrate this RNA sequencing data with corresponding mutation and clinical information, and we end up with this big comprehensive data set. Right? So before I go into this ML pipeline, we do a pre-analysis, which involves using the mutational and clinical data to come up and validate the key mutations that we find. Based on that, we come up with our ML pipeline, which predicts those key mutations. So in our ML pipeline, like I mentioned, we do pre-processing, and then we do a feature selection using XGBoost and Lasso. And we use this two-step feature selection so that we have like a complete comprehensively validated feature list, which can be, clinically applied. There is complete reasoning to it. And finally, in metrics, we use AUROC, and especially we use Matthew correlation coefficient, which is MCC. And this is supported by literature that it is very helpful when you have an imbalanced data set, like in our case. So now coming to the results, our models performed exceptionally well for classifying LGG and GBM, where we got a near perfect classification using random forest classifier, which makes sense because it's very easy to classify into an extremely aggressive type, which is GBM, versus the stage 2 or 3, which is LGG. Now, within the subtypes LGG and GBM, we see that there's moderate success, and this is due to a lot of overlapping features and additionally class imbalance. So over here in this table, I have displayed the results for diffuse glioma, which encompasses both LGG and GBM. And if I show you the next slide, where we just have LGG and GBM results specifically, so the subtypes for LGG are astrocytoma and oligoastrocytoma, which have a lot of overlaps. So that is why classification is not clear, and hence the accuracy is much lower. Whereas in case of GBM, we notice a class imbalance, right? So this is about subtype classification. Now I'll move on to the results for mutation prediction. So in mutation prediction, our model showed very strong performances for key genetic markers. These are the key genetic markers that we have identified using our analysis using mutation and clinical data, along with previous literature. So the details for each of this will be there in our code as well as our paper, the link of which I have attached at the end of the presentation. So in mutation prediction, our models, like I said, showed very strong performance. And the most impressive was for this IDS mutation, which is a particularly highlighted key mutation across gliomas or brain cancers. And we got an AUROC of 0.98. And what this tells us is treating this mutation could be a very crucial target for precision oncology. Right. And we also targeted co-occurring mutations. So when we did our entire mutation landscaping, we saw that there were a lot of mutations which were exclusive and a lot of mutations which were co-occurring. So we took all of those into consideration while saying, like, for example, in case of LGG, we noticed that IDH co-occurs with this 1p19q co-deletion. So we tried to classify on the basis of those. And luckily for us, WHO also redefined their classification on the basis of this exact subtype for LGGs. This is one of the analysis that we did as part of our pre-analysis, and this one is using clinical data of a patient. One thing to be noted is that if the survival time for a patient was not specified, we use the last date that was given over there of the last follow-up. Right. So it revealed a lot of significant patterns for us, such as if the IDH gene is mutated in a patient, what we notice is there are much improved outcomes for gliomas, especially when this IDH gene is co-occurring, the IDH mutation is co-occurring with mutations in TP53 and ATRX. All three of these genes are key identifying genes in cancer, like they're determined. For example, TP53 is a tumor suppressor gene, right? But what we notice, and this aligns with our understanding, is that GBM remains highly aggressive irrespective of what mutation is there. And this makes sense because it is a stage 4, which is much down the line if you're discovering it at stage 4. So there's very less scope of survival. Now, finally, to validate what we had done, in addition to finding overlap with past data, we performed an enrichment analysis using gene ontology terms on the selected feature sets that we got from XGBoost and Lasso feature selection. and it confirmed the biological relevance of our approach. We identified key pathways that were involved in glioma. Now, let's say if I give you the example of IDH again, because it is one of the most important genes, we notice that it is linked to metabolic pathways, whereas TP53, which I mentioned is a tumor suppressor gene, is associated with impacts on the immune and cell cycle processes. So, similarly, we have this for each of the key mutations in each subtype. Finally, in conclusion, we have developed a robust framework for glioma classification as well as prediction of key mutations. In each case, we have received high accuracy, except for subtypes in LGG, which was due to extreme overlap, and it has been proved that it cannot be distinctly identified. And we also noticed significant amount of biological relevance with in each case we have highlighted the cases where we have significance where p-value is less than 0.05, the adjusted p-value. So our approach is scalable the way the code is written, and it can be extended to other cancers. In future work, we plan on integrating other data modalities, for example, imaging data, and also on how it can be implemented at the clinical or hospital level. So that's all for this paper. And thank you so much again for your attention. If there are any questions, I'd love to answer.
Okay, thank you, Shreya.
Thank you.
Now you can move on to your next presentation.
Okay, since there are no questions, I'll move on to my next paper. So yeah, now I'll
You
be
can ask the
presenting
questions at the end.
Sorry?
You have come continuous 4 presentations. You can ask the
Yeah,
questions after your 4 presentations.
sorry?
You can ask questions after your 4 presentations.
All 4? Okay,
Yeah.
works. Fine. So now I'll be presenting our work on predicting Parkinson's disease using a multimodal machine learning approach. And again, this was done by me and my advisor. And what we do is we try to improve. I'm sorry, I think I'm on the wrong slide. Yeah. So yeah, this one is a collaborative approach with me, my advisor, and other college colleagues. So in this research, what we try to improve is an early detection through the integration of multiple different data modalities, specifically for Parkinson's disease. So some background would be that Parkinson's disease is poses significant diagnostic challenges. It is a very severe neurodegenerative disorder, and what the main issue is that the current diagnosis relies heavily on clinical symptoms, and these show up much down the line. And these clinical symptoms are substantial like occur after, like I'm saying, down the line after substantial neurodegeneration has occurred, and thus highlighting the need for a more comprehensive diagnostic approach that can catch this disease much earlier. So, one of the main things about Parkinson's is that it causes the deficiency in dopamine, and dopamine comes from movement, and all it's one of the happiness hormones. So, one of the main clinical symptoms that is identified much helps identify Parkinson's, but very much down the lane is a movement disorder. So this is our main study overview, and we use the data from the PPMI dataset where we had to apply for access. We analyzed data from 598 participants, and we had data for 3 different modalities, and this is across each of the 598. And this is where we're forming the integrated data set. So first is clinical data, which are basically results to a bunch of tests like SCOPA, UPSET, which I'll be explaining later. Biospecimen is basically the CSF or the cerebrospinal fluid markers, which is the colorless spinal fluid that is in your brain. And then our genetic data, which is different types of SNPs that we have. And what we do is we end up with this integrated data set of 598 participants with 29 clinical features, 5 cerebrospinal fluid markers, and 154 very carefully selected genetic markers. The explanation of the genetic marker selection I'll be going through in the next slide. Now, this is the main workflow. After the integrated data set, this integrated data set acts as the input for the early integration and intermediate data integration model. Whereas we move ahead with an XGBoost feature selection and different ML models. So in case of each data modality, we end up with one best model, which is then used in the late integration technique. Details of which I'll move into the further slides. So, talking specifically for our genetic data, we implement a novel biologic driven feature selection approach, which does not rely heavily on machine learning methods. So, from the data set, we had nearly 7,000 SNPs, and we combined this with biological relevance through different literature papers. We went through a lot of papers, we shortlisted a bunch of SNPs. We found the overlap between the 7,000 that were present, and using the chi-square test, which is the statistical correlation test, we identify 154 most predictive genetic markers. And this approach ensures that we not only have statistical significance, but also biological meaning backing our genetic features. So it's not a black box. Now talking about one of the key aspects of this paper is the integration approach. So we have three different integration approaches. One is early integration, where we directly take the raw features and combine them, which is our integrated data model. Then we use intermediate integration, for which every modality we obtained encodings using auto encoders of dimension 4. Then we concatenated them to get a 12 dimension vector, and we put it through a simple neural network to see if it is able to predict Parkinson's better or worse than the other integration techniques. And finally, for late, like I said, in each modality, we obtained one best model, and we did an ensemble voting to see which each model will give a prediction, and took the vote for each of them and combined it to give one final result, whether Parkinson's is present or it's whether early Parkinson probability is there or it's not there. Now coming to our results, we see that the early integration model performs the best with an AUROC of 0.94 and an F1 score of 0.9. So this is despite data imbalance that we had. So this suggests that direct feature interactions between the modalities are actually more important for accurate prediction rather than what happens in the intermediate and late. However, the predictions are not as bad for intermediate and late, and this validates that there is some value to this multimodal analysis. Now, coming to the key features in each modality, here is the table from the paper. And if I had to mention the key ones, for clinical, it would be the upset score. Like I mentioned, upset basically measures olfactory function. This is one physical test that is measured very much down the line. Another one is SCOPA, which is an autonomic dysfunction, like I said, a motor disability. Other than that, key features which are missed out in the current methods would be biospecimen data, where we see ASN nuclein and the ratio of these tau CSFs was also showing much significant predictive power. And as per literature, like in line with literature, our genetic markers came from major SNPs that lie on the chromosome 4. So the clinical implications of our work are very significant. The multimodal approach could enable much earlier detection of Parkinson's, potentially much before these motor symptoms even start to appear. So this would lead to earlier intervention and much better outcomes for the patient. So from which we can conclude that the model can serve as a valuable tool in clinical decision making, maybe not completely take over, but definitely support clinicians and like complementing with existing diagnostic methods. So for future applications, we are hoping that, like I said, it acts as a support tool for the clinicians that exist. In conclusion, our study demonstrates that combining these multiple data modalities actually helped improve Parkinson's prediction. We saw the previous state of the art, which were using just one modality, and we noticed that it actually does help when you have different modalities. And one major modality that we can actually bring in would be imaging data for Parkinson patients. In future work, like I said, would be the adding the modalities. right? So that's all for this presentation. So we'll be taking questions in the end. So I'll move on to the next one. Okay, so this is another project or paper that I've taken up with my advisor over the course of my research. And this is basically understanding the genomic landscape of a Plasmodium parasite. The species Falciparum is the most deadly one of this parasite, and it is deadliest cause for causing malaria in humans specifically. And what we do is we combine transcriptomic, specifically single cell RNA sequencing data, along with a machine learning approach. And this aims to enhance the understanding of malaria as a disease and also identify new treatment targets. So, some background before we jump into it is that malaria is still a critical global health issue, especially in developing nations, as we can see from this diagram. And this parasite, Plasmodium falciparum, is the most virulent species because it has a very complex life cycle with multiple stages, and these stages take place through different hosts. So, half the cycle is in the mosquito, whereas the other half is in mammal, or in our case, the human. So, what we deploy are single cell RNA sequencing technologies, and then we can now use that and analyze gene expression at a very, very unprecedented resolution. So our goal, like I said, was to leverage this data and use machine learning to better understand how this parasite is developing over its life cycle and identify potential intervention points. So before we begin with anything, the data is from it's free access data from Malarial Cell Atlas, and our data set had over 37,000 cells with more than 5,000 genes. And we had a well-balanced data set in this case across all the 4 development stages. One thing I'll mention is 3 stages that are trophozoite, skin zone, and ring. These are 3 asexual phases, whereas we have one sexual phase or stage, which is the gametocyte stage. And the UMAP visualization shown on the right shows is a UMAP which we made after pre-processing our data set just to verify that what we have, what we're working with is properly pre-processed. So we actually do notice 2 distinct profiles where the gametocyte, which is the sexual stage, is in a complete different divergent expression patterns as compared to the 3 asexual stages. And we can keep this diagram in mind because it will come in use in the upcoming slides. So coming to our methodology, we combine 3 complementary approaches in feature selection. And this feature selection is basically a static analysis where we use the single cell data and we perform 3 different type of feature selection methods on each stage data. So one would be identifying the highly variable genes, which is the most basic statistical method that one can use on variance. Then is a little more complex using the Seurat R package, which is identifying differentially expressed genes. And finally, there's an M3 drop analysis, which reduces the noise, and based on this noise filtration, gives us genes. Then there is trajectory analysis for identifying dynamic transition as we move from one stage to another. So this gives us a key set of genes. Finally, we use each of these sets into a neural network to see which gene set or which combination of gene set can classify into the stages the best. This would indicate that which combination of gene set can capture this life cycle the best and thus give us potential treatment sites. And then, like the other procedures, we validate them and back our findings using gene ontology enrichment. So our feature selection methods, this diagram over here is shown specifically for the static feature selections where we use highly variable genes, differentially expressed genes, and the noise filtration method for the schizon stage. And we receive different distinct gene set for each developmental stage. One thing that I would like to highlight is that we have 1,818 life cycle genes. Now, what we're calling life cycle genes are basically genes that remain active throughout the development. And these represent 1/5 of the parasite's genome. And this actually aligns with previous research on the parasite's core genetic functions. So this was a very strong checkpoint for us that what we're doing is correct. Now, coming to the trajectory analysis, it revealed very fascinating and unique patterns in the development. And we observed the continuous progression in asexual stages. Like I said, the diagram configuration matches that of the UMAP. And what we notice is again there is a branching into asexual into the sexual stage from asexual, and this can be mapped to the gametocyte stage. And what we notice is as the pseudotime progresses, that is from 0 to 20, the life cycle also progresses from different asexual stages to the sexual stage and finally ends at the top over here. So this analysis also helped us identify crucial stage over a period of time, that is through stage transitions and development. Now, coming to the comparison of these gene sets, our neural network achieved very impressive classification accuracy of up to 96%, and this was highest as 96% in the case of the top 1000 trajectory analysis genes. So we did not need to take any combination. The trajectory analysis gene on its own were able to capture the life cycle. And this outperformed the different the when we use the entire gene set, which indicates that maybe using, not always using the entire gene set is of value because it can lead to overfitting. Now coming to the biological significance that is conveyed via the gene ontology analysis, it showed that each stage had different enrichment of the expected functionality. So things that I would highlight would be that host cell invasion related terms were highlighted in the ring stage. Metabolic processes were affected in trophozoite stage. Processes related to cell division were in the skin zone stage, and sexual development related terms were highlighted in gametocyte, which makes sense because gametocyte was our only sexual stage. In conclusion, this integrated approach was successful in identifying state-specific signatures, which could down the line act as potential therapeutic targets. And what this unique combination of static and dynamic analysis for features gave us a very robust understanding of the parasite's biology. One main thing that we immediately plan on doing is modeling this certain gene transitions from normal state to active state where it's activated using a Poisson beta model. This will help us understand the kinetics behind the gene expression. And I have wrapped up with this. I'll move on to my final presentation, which is in line with the presentation that we had in the starting by one of the keynotes, is where I'll be presenting my work on using graph neural networks for drug repurposing. And we have a particular focus on COVID-19 applications. Now, this was one research that was conducted in collaboration with the colleagues from Carnegie Mellon University in Pittsburgh, myself from IIIT, and a student from Manipal University, Jaipur. So let me start by highlighting the major challenges that we are addressing. Like we know, developing a drug by traditional method can take up to 15 years, and it can cost up to $2.6 billion per drug. And if it is the case of a pandemic like COVID-19, there is a higher emphasis on the urgent need for faster solution. We cannot take 15 years in a situation like COVID-19. So in these cases, something like quick drug repurposing of existing already FDA approved drugs would be very useful. So to do this, what we do is we construct an integrated network using multiple biological interactions. We source these interactions from the Stanford dataset, and we have 4 different types of graphs or mappings. One is protein-protein, one is drug-protein, one is disease-protein, and finally drug-disease. And our dataset included over 18,000 proteins, 6,000 drugs, and 1,400 diseases. And we developed this comprehensive network that I'm showing in the diagram here, which allows us to capture complex relationship between each of these biological entities. So we apply a 3-prong approach again. First, we start with 4 different homogeneous graph neural networks, which includes GCN, GAT, GraphSage, and GIN. Second, we develop a heterogeneous graph transformer that can handle these multiple type of nodes and edges. And finally, which was a unique thinking from our side, we implemented a matrix implementation approach as a baseline. So, for those of you who are unfamiliar, matrix factorization is one of the main thing logic behind recommendation systems. So, we thought of remodeling the recommendation problem as a drug repurposing, where let's say if for what happens in Netflix, for example, we have a movie, and then for each user, they try to suggest movies. So, what we're trying to do in here is for each disease, let's recommend the best diseases. Um, so, our results show that the graph-based approaches were significantly outperforming the traditional matrix factorization, although we did use a very basic model. And for graph sage, we achieved the best performance with an AUROC of 0.99. And this is very closely followed by the heterogeneous graph transformer. Like I mentioned, the matrix factorization showed a much lower performance. And what we can actually understand from this is the importance of incorporating a very complicated network system which can capture all the relations between the entities. So now coming to the COVID-19 case study, our model was able to identify 31 potential drug candidates. I have mentioned a few over here, which we've also mentioned in the paper. And one of the main things is the majority of these drugs come under the antivirals category. And as we know, COVID-19 is very viral in nature. So that aligned for us. Additionally, we also identified anticoagulants like heparin, which showed up by three different models. And this has also already shown very promising results in reducing mortality rates in COVID-19 patients. So each of our findings are aligning with past literature. So coming to the key insights, the graph-based approaches did give much superior results for the drug repurposing task, and this can be attributed to capturing the network structure. And one main thing that I mentioned is all our predictions aligned with previous clinical knowledge. So we can say that this framework can safely be extended to other diseases. Now coming to future implementation. It's very similar to the previous slide where we can have significant implications for drug discovery as well, in addition to drug repurposing. It's much faster, it's more efficient to develop rather than developing it from scratch. And in case of pandemics or very rapidly emerging diseases, this is a very useful framework so that we can prioritize candidates for clinical trials. And I'll finally wrap up with the key findings, which I've mentioned is the graph neural network performs much better, and we were successfully able to identify clinically relevant COVID-19 treatments. So now I'm open for all questions and answers, and thank you for your attention and time for any of the past four papers.
Okay. Judges, any questions or any participants? Do you have any questions?
One thing I'd like to add, sorry. So one thing I'd like to mention is for each case, we have the code and paper readily available on our GitHub. Yes.
Sir, any questions from your end? Okay, so I have a few questions.
Okay.
One is, from where did you get the data sets?
For
Is
which
it
case, sir? I've mentioned in each case.
okay?
So if I talk about the glioma paper, it's
Yeah.
readily available data online on the TCGA portal.
Okay. So all
In
are from
case,
the specific database, and
yeah,
you used like any programming languages directly, or you used softwares for this? Because transcriptomics has its own pipeline. Even it can be performed with softwares. Even a
right. No,
single cell
no.
RNA it can be done. So how you did all this?
Right. Okay. So I'll mention this for all the papers. We source the data from the data, each individual data set, databases that are there online. In some cases, we had to get access. Now, coming to the programming languages, In most cases, we used Python for the machine learning part, and for processing the data, we used R packages. So, like I mentioned, we used the Seurat single cell RNA processing packages and M3 drop in case of malaria. Similarly, for glioma, also, there is a readily usable TCGA package in R. So, these details I have added in the paper. Considering time constraint, I didn't mention it here.
Okay, thank you.
Thank you.
Any questions, sir? Sankesh sir, any questions?
Yeah, the work done is very good. So
Thank you.
congrats for that. Regarding your last paper that you are proposing the network system,
Right.
how much you are confident about that this will be the give us better opportunities for the drugs to be coming in the markets?
So I cannot give any guarantee because it comes with like a lot of health implications. But when we tested it for COVID-19, it's giving us results that match with the existing drugs that are being used. And one thing I'd like to mention is during COVID-19, actually drug repurposing paper model from MIT was used, and those candidates, drugs from that paper were given higher preference during clinical trials. So we can say to a certain extent that yes, this can be used, especially when we have a pandemic at hand.
But now there are some side effects are coming. So what do you think about that? Will that?
So we have two options in case of a pandemic, right? Like if something is coming so rapidly, you can either cure it with some side effects or wait 15 years for a cure. Like it's a bargain that we had to make. So I believe that is why the government of special, I think US had done this. So I think the government went ahead with it because it made sense to, okay, at least we can cure them for now rather than let a lot of people suffer.
Thank you.
Thank you.
So I guess that's it. Thank you, Shreya.
Thank you. I'll just stop sharing.
Okay, thank you. So next I would like to call Jeevan. Prahlad, is he there?
Yes,
Yeah,
ma'am. Is
Jeevan,
my
you
screen
can
is visible?
start your presentation.
Okay. Good evening, everyone. Myself Jeevan Tonde, student MGM University, Chhatrapati Sambhajinagar, and title of my research paper is Towards Effective MCQ Generation, Semantic and Machine Learning Approaches. The objective of my research paper is to compare two techniques which are used for generating multiple choice questions, a semantic based approach and a machine learning based approach, and evaluate the generated questions with the help of subject matter expert and automatic evaluation metrics like BLUE, ROC, and other one. So the multiple choice questions are popular tool for assessment because they are easy to use and can be graded automatically. And it also works in both education and industry domains. However, creating MCQs manually is the time consuming and require expertise to write the questions, choose the correct options, choose the correct answer, and add proper distractors, that is the wrong answers. The multiple choice question consists of a three fundamental element. First one is the stem, then the key and the distractors. For example, if the original sentence is Dr. APJ Abdul Kalam is the missile man of India, the stem can be here, who is the missile man of India. The key or the answer will be Dr. APJ Abdul Kalam, and the distractors can be Dr. Vikram Sarabhai, Homi Baba, and C.V. Raman. In semantic approach for question generation, it focuses on understanding the meaning and relationship within a text using tools like semantic role labeling, name entity recognition, and the dependency parsing. It identifies the key entities, roles, and patterns in the text to generate the meaningful questions. Some advantages of semantic approach is generated questions are meaningful and closely tied to the text. They can handle various text structure and adapt to new content, and we can also reuse them, that is the extracted patterns or rules can be reused across the different domain. This is the design flow for question generation using semantic-based approach. In this, we give the sentence as an input to the model, and we get a question. We get a question based on the text, inputted text. The process involves text preprocessing, POS tagging, segmentation, dependency parsing, clause identification, and finally applying the rule. So in the text preprocessing, we remove the unnecessary characters like punctuation marks, special symbols. Under tokenization, we divide the paragraphs into chunks. Then we expand the contractions like, for example, if the word is don't, then we are going to convert that don't to do not to maintain the clarity. Then POS tagging. In this, we label each word with a grammatical rule that is to identify the structure. This will help to locate the question-worthy component like verbs and noun in that sentence. Then we apply the NER, that is a name entity recognition, which uses to identify the entities like people, places, dates, organization in that particular text. Then co-reference resolution. So if our context or if our text have some pronouns, then we are going to convert that to a particular noun or particular entity. For example, he is a cricket player will be converted to Sachin is a cricket player because Sachin is the entity here or Sachin is the noun here. So for then we have designed some linguistic rules that are applied to the text, and by using this linguistic rule we can generate the questions from this. So the first rule is here DT. Here the meaning of DT is determiner, that is A and D, which is optional. So followed by the cardinal number, that is CD, which should appear at least one time. Then there is a RB, that is an optional adverb, like optional adverb. Then if the sentence contain the optional adjective and the sentence contain one or more nouns. So if this pattern matches in the text, then we construct the how many type of question using this format. For example, to construct how many questions, we use the following format. How many plus part of chunk excluding the cardinal number plus X plus subject part plus remaining words of the verbs plus remaining part of the sentence as it is, where X is the verb type. So if the verb is in past tense, then we assign X as a did. If it is in present tense and singular, then we apply X as a do. And if it is in past tense, then we past tense and third person, then we apply X as a does. So suppose the text is here. They ate 3 pizzas during the parties. So the question can be generated by using the rules is how many pizzas they ate during the party. So like this, we have created 15 different rules for generating different types of questions here. So second one, we have used a question generation machine learning model for question generation. For this, we use a pre-trained model called LEAF, which is a state-of-art system for question generation. So this is a pre-trained model which is trained on the SQUAD dataset, where the SQUAD stands for Standard Question Answering Dataset, which is a popular benchmark in the field of natural language processing. It consists of 1 lakh questions answer pair created by crowd workers on Wikipedia articles. Each question is paired with a corresponding segment of the passage where the answer can be found. So we evaluate these questions, this 50 generated question using both method, that is using semantic base and machine learning base. The 5 subject matter experts rated the questions on semantic correctness, syntactic correctness, semantic correctness, and relevance, and answerability on 5-point scale. So here are the average rating of each method. The result shows that the machine learning model method generally scores slightly higher in the terms of syntactic answerability and relevance. However, the semantic based methods seems to have a slight edge in the clarity of the questions. So for this, I have taken a feedback of subject matter expert on the Moodle, and the generated XML file of that feedback is uploaded on GitHub. So this is about human evaluation. We have also used the automatic metric to evaluate the generated question and the actual question. So for that, we have used the metrics like ROG and BLUE. So ROG stands for Recall Oriented Understudy for Gisting Evaluation, and BLUE stands for Bilingual Evaluation Understudy. So these are the formulas for BLUE scores and ROG1 score. And this is the analysis. The BLUE score says that the semantic approach edge out with an average score of 0.92, which is slightly higher than the machine learning approach, which is 0.90. And the ROG1 scores, here the semantic method score is higher, that is 0.93 compared to 0.94 for machine learning model. So again, the code for this evaluation matrix is uploaded on the GitHub. So finally, conclusion, our finding shows that the semantic approach provide a clear and structured way to generate the questions, while the machine learning approach is more flexible and efficient for handling large amount of data. So each method has its own advantage, and combining them can improve the quality of automated question MCQ generation system. These are the research paper that I have referred for this presentation. This is all from my side.
Okay, any questions?
Jeevan?
Yes, sir.
Yeah. Are you looking at the some of the I can say data sets which is already having this type of question answers?
Yes, sir. I have created a 50 50 text from a textbook, and I have also referred the SQuAD dataset, which contain 1 lakh question answer pair.
And are you looking at some distractors? How the distractors can be used in the MCQs?
Yes, actually, I have not included the distractors part in this
That
paper.
you can include in your things?
Yes, sir. Yes, sir. We can include that part.
Okay, so I guess that's all. Thank you, Jeevan.
Thank you.
Now I would like to call upon Anirudh. Aniruddha, are you there?
Yes, I'm here.
Yeah, now you can just take over.
Okay. My slides are visible now?
Yes, sir.
Okay, thank you. So I am Aniruddha Vishwas from JS College of Engineering. I am the presenter of my presentation, that is interactions between long non-coding RNAs and proteins to elucidate the mechanism of neurodegenerative disease onset. My co-authors are Shima Vishwas, Jeet Mondal, Srikanya Rai, Anirban Nandi, Surakshana Malita, and our guide, Angshuman Bakchisa. These are the outline of my work. Firstly, I would like to start with the introduction of my working. I'm dealing with the LNC RNA, which interact with proteins that affects the neurodegenerative diseases. So with this prelude, I would like to introduce the LNC RNAs, which are mainly, earlier it is known as junk DNA, you can say, and 98 to 99% were non-coding part, which is not translated into proteins, but they have different mechanisms through which they can actually interact with protein or can have different roles in neurodegenerative diseases. There are different modes of action of LNC RNAs, like chromatin interaction, interacting with proteins, and by interaction with other RNAs. Here, our key concern is the interaction with proteins. After different studies and literature reviews, we come to conclusion, or we find out different LNC RNAs which are associated with protein like base 1 AS, the base 1 amyloid beta peptide protein, which directly have different roles in up-regulation of Alzheimer's disease. Apart from that, there are PD, Parkinson's disease, Huntington disease, and ALS, which are also being differently associated with protein like LNC RNAs like ASUCL1, which interacts with UCL1 protein, as well as MALAT1 NEAT2 that interacts with protein alpha synuclein. Hot air interacts with HOXC, etc. Now, coming to the research objectives, our first objective is to determine the structure-function relationship of LNC RNAs with its binding partners, as we have mentioned earlier. Second is to find out the mode of binding interaction between LNC RNAs with proteins involved in neurodegenerations. The key part, which is the methodology that we have applied. Firstly, we have find out the protein which is interacting with LNC RNA and differently working on the neurodegenerative disease onset. So firstly, I would like to introduce the protein which is 6LT7, a multi-mer protein that is ribonuclease P protein subunit P20. Then in the next step, we perform the minimization using Discovery Studio 2.5. And finally, the molecular dynamics we perform using GROMACS. With this, we get the results. Here we find out the RMSD and protein RNA complex structure, and also the interacting residues. Here, the key part or key finding that we come across, that is in the result you can see here, the interaction between the LNC RNA and protein. We will discuss the implications of these findings. And in the graph, you can see at the very early phase of the graph, from 0 to 20 nanoseconds, the stability of the graph, that means the RMSD value, is fluctuating. And after that, at the end, it shows stability during the end of the graph. That is, after 40th nanosecond, it becomes little more stable. Here, you can see the structure that we find out. This, it is actually the interplay between long non-coding RNAs and proteins in the context of neurodegenerative diseases. So the features of these protein RNA complexes, focusing on the specific interacting residues. Structure of the protein RNA complex, you can see here that the red mark are proteins, the ribbon-like structure, and the rest of the part, which are called the LNC RNA, which are interacting with this protein. Now, the findings of our research work is that this protein, which has chains C and F, which are interacting with the amino acids, which is mentioned on the right. On the left, the C chain are mostly the LNC RNAs. On the left, you can see here. And on the right, we have the amino acid sequence, which are interacting with one another. And in the next table also, we have the chain F, which are the LNC RNA, which are interacting with different amino acids, which are present in chain D and chain E. With this, we can say the RNA function, like LNC RNA play a diverse roles in gene regulation, influencing protein expression and cellular processes, as well as the protein function, like proteins through their interactions with LNC RNAs contribute to cellular signaling and the regulation of essential functions. In the last table, we have already seen different interactions that we come across through our tools that we have used. And finally, we reach to our conclusion where we can conclude that interacting nucleotides in the LNC RNAs and interacting residues or amino acids in the proteins. And we can recommend further for the future work characterizing these circular RNAs and their relationship to neurodegenerations are our future aspect. With this, we would like to finally acknowledge our Professor Angshuman Bagchi sir for his research idea and supervision, my lab co-members for their constant support. I would like to acknowledge bioinfrastructure support, the BIF Center, University of Kalyani, and special thanks to JS College of Engineering and Department of BCBP, University of Kalyani for encouraging research and innovation. Some of the references. Thank you all for listening.
Thank you so much, Aniruddha. Judges, any questions?
Okay, Jamima, you can move on to the next person.
Okay, now I would like to call upon Rajat. Rajat Pandey, are
Hello.
you there?
Yes, I'm about to share my screen.
Okay, yeah. Please go ahead.
Thank you. Yes, is my screen visible to all?
Yes.
Oh, thank you. Yes, so good evening, everyone. So today I'll be discussing about my work that is enhancing data security by DNA methylation-based encryption technique. So this work is carried out by me and is supervised by Dr. Manoj Kumar Ramteke from IIT Delhi. So basically, if we come towards how the data that we are using on day-to-day basis is sensitive and how it is securely encoded. So whenever we use any of the platforms that we use today, that is the most common WhatsApp, Telegram, or X. So we always come to a particular phrase called end-to-end encryption. So this end-to-end encryption, what does it actually mean? So basically, if we look towards the traditional techniques, so here we will be able to find that on the basis of an RSA algorithm, that is basically Rivesh, Samir, and Adelman, named after the inventors. So basically, it works on the basis of principle of that, and basically it is based on two keys. One is public and one is the private key. And with the computational as well as the mathematical integration of these two keys, the encryption of our message that we are sending across take place, as well as the decryption at the receiver ends also take place. So nowadays, as DNA encoding has come into role nowadays in data encryption and decryption role. So the proposed technique that I will be talking about is how can we improve certain aspect of this traditional technique using DNA methylation or DNA encoding rules. So as this DNA encoding thing is kind of new, So I would rather explain it in upcoming slides. So before going into DNA encoding, let's look into the traditional approach of the encryption that follows. So basically, as I have worked on RSA encryption, so I'll be explaining about RSA encryption that is most commonly used in most of the platforms that we use today. So basically, it is a conjunction of two encryption keys that we have. One being the public and other being the highlighter private key. So with the help of these calculations and the conjunction of these key and some mathematical operations, the original message gets encrypted. That is that it gets coded and it gets decrypted, which means it returns to its original form when it reaches the receiver. So the current challenges with the traditional approach is that it has a very high computational overhead and it is very static in nature. Whatever the algorithm has is the mathematical computational technique. And if we backtrack that mathematical computational technique, it is kind of a straightforward technique, or we would like to say in our domain, a single lane or a single view channel that can be backtracked easily. So if we are sharing some sensitive data, so it can be easily backtracked. And the third issue being the scalability using large data sets, the computational overload would be very much. So how methylation can help in this encryption technique, like this biological aspect? So coming towards some basics of methylation, like it is observed in everyone from human, plants, bacteria, microorganisms to animals. And it is basically predominantly occurring in CPG, that is cytosine phosphate guanine sites, and helps in gene regulation and development of disease. The idea of taking methylation as a key concept in encryption is that, as we have discussed earlier, the traditional methods are kind of static in nature. But methylation, just as mutation takes place in cancer, is a kind of a random thing in nature. So we need to introduce the dynamicity to the encryption techniques. So the primary steps that we would be involving in encryption would be selection of possible methylation sites and then encoding it forward in any of the given messages, files, folder, images, anything. So our research objective it involves of encoding DNA methylation pattern into digital format, combining the traditional RSA algorithm with this DNA methylation technique, and further validating the uh, hybrid algorithm structure. So the methodology that we are having is a conjugation of both the traditional techniques, where it converts the message to a public key and it goes towards this ATGC format, converting into DNA base pairs. So how does this DNA base pairs take place? So every encrypted data in a digital platform, it can be converted into its binary equivalent 0101, and using this particular table that we are having, that is known as DNA encoding table. Each particular binary equivalent can be converted into its DNA equivalent, that is adenosine, ATGC, thymidine, cytosine, and guanine. So in this generated sequence, we are looking at the particular methylation site that occurs, and this methylation would be completely random as on the basis of the sequence that is generated. And once it's generated, the encrypted data that we will be having, and again this whole method will track back to the decryption method. With the private key, decryption will occur and we will retrieve the original message. So the system architecture looks something like this. So basically, as previously explained, so this is the file system that we are converting into decimal system, further converted into a binary equivalent to DNA equivalent, and further layering it with the security of a DNA or random nature of DNA methylation, we are encrypting that data. And from the encrypted data, we are moving backward to the original data. This is supplemented by the RSA algorithm, whose system architecture or the computational step has been and mathematical steps has been described here, like for the both encryption and decryption technique. So the experimental setup used for this study was a simple benchtop uh, working system, workstation, having the following specification. The work was carried out using Python in JupyterLab, and the data set was used that was publicly available, and the size was not specified. Any size of the data set would do. The support of a public methylation database site was used for possible methylation, identifying the possible methylated sites within the sequence. So moving on towards the results. So there are two possible metrics that we have in the area of encryption, that is key sensitivity and entropy. So basically, these are key sensitivities. Basically, if any of the one of the keys, be it public key or the private key, changes, then how will the entire original message change? Because if any one of this key gets into the hands of a hacker or antisocial elements, then the whole message or the sensitive information would get leaked. So that is why even in present day scenario, apart from WhatsApp, none of the agencies are able to crack what are the conversations that are going between two people. So if we can see that for the 5 files that we were having, the key sensitivity is almost 100%. And the entropy is basically the randomness, degree of randomness. So for every 18 bits, there is a change in the original data that we are having, approximately 8 bits that we are having with the encrypted data set. This is carried out with the encrypted data set because in original, we don't see the randomness. The original will remain as such. Then we are looking forward towards the correlation plot. That means how closely they are correlated to each other. So basically, we have an actual file and the decrypted file. Decrypted file is basically the original file that has undergone, completed the process of encryption and has reached the receiver. So if we correlate or if we just compare the two, we can see they are highly correlated. It means that the same message or the same message that was sent by the receiver, it is received same like as it is by the like sender and receiver. The original message is there. Whereas if we compare the actual files with the encrypted files, the ones which are encrypted by RSA and DNA methylative uh, algorithm, we can see there is a huge degree of randomness and the uh, points are scattered all over the graph. So all this message, no one, even a hacker, would not be able to assume what was the actual message in all of these files. So that is the degree of randomness that we are able to achieve. Another main factor for any encryption algorithm is the computational time. How much time is it feasible in a real time scenario? So if we can see that it is given in, I have in a recent study published in 2024 that the what is the only RSA based encryption algorithm? What is the average encryption and decryption time for any message data sent over? So basically, it's 45 milliseconds for a 10 MB file and 56 milliseconds for a 10 MB file for decryption of the data. So here we have these 5 files again, and with varied uh, file size and the encrypted and decrypted data time that took. And we see that if it is not similar, but closely similar to what is achieved by or stated in the literature, The high overtime is maybe due to we are adding on an additional layer of dynamic layer of DNA methylation that adds to the security but also adds the computational time. So these metrics were compared with the other literature, and as compared to the other literature, though security in terms of complexity is high in our approach, the efficiency time is a little bit less due to the addition of a hybrid DNA methylation layer. While due to this addition, we are able to achieve scalability that is that to a high amount of or large amount of data set, we are able to share seamlessly these data set without any computational overhead. So the key takeaways was the novelty and the high robustness of this hybrid DNA methylation and RSA hybrid algorithm method. There is acceptable computational overhead in this, similar, if not similar, slightly greater than the established methods, and it is efficient in handling larger scale data sets. So the strength of the system is basically the increased robustness due to the addition of an additional of a layer, DNA methylation layer. So this technique is a novel integration and it can be scaled upfront. But the shortcoming would be the computational cost, because to process that extra methylation step would be uh, time intensive, and the dependency on quality of data that we are getting. So it would conclude to the future improvements that could be done is basically this random nature of methylation could help in adaptive encryption strategies as well as resist the quantum computing task. Like, what does the quantum computing attacks means? That basically all of our algorithms are mathematical calculation or uh, calculation based, and these calculation are kind of straightforward. So based on a kind of empirical formula that can be backtracked or traced easily. So if we add the idea of any biological phenomenon, be it mutation or methylation, which is random in nature, would be very hard to crack or hack for actual reasons. So for this reasons, the application would uh, cover the enhanced security for data exchange between research and clinical environments, as well as the storage of data for a prolonged period of time. So for this work, I would like to extend my sincere thanks to Dr. Manoj Kumar Amteke, my professor, Department of Chemical Engineering, IIT Delhi, Indian Institute of Technology and Science and Engineering Research Board for extending funding support for this particular study. And lastly, the organizing committee and members of ICBDS 2024. Thank you.
Okay, thank you, Rajat. Now I would ask the judges and the participants if they have any questions, they can just ask now. Or else I would like to call Saurabh. Are you there? So I guess there is no questions and there is no Saurabh. So I would like to call Vaibhavi. Are you there, Vaibhavi?
Yes.
Okay, yeah, you can take over.
Okay.
Yeah, so Vaibhavi, you have to give your presentation one after the other, okay?
Okay.
And at the end, there would be questions.
Okay, sure.
Okay, thank you.
So, good evening, everyone. First of all, thank you to present my research work on the molecular docking study of bioactive compounds from the Sushrut Samhita for modern drug discovery. So my name is Vaibhavi Jain from the Department of Bioinformatics at the MGM University in the Institute of Biosciences and Technology. So this presentation explores the how ancient Ayurvedic wisdom can contribute to the modern medicine through the computational approaches like the molecular docking. Let's begin with introduction. So in which as all of us know that Sushrut Samhita is a foundational text of Ayurveda which describe the therapies for diseases that are still relevant today and also for the surgical methods. So this research uses the molecular docking simulation to study how the bioactive compounds from the Ayurvedic formulation where interact with the disease-related gene receptors. So here we are randomly taking some diseases from the Sushrut Samhita for predicting through the molecular docking simulation. So in which we are taking the diseases like tuberculosis, eye disease, colic disease, leprosy, and their remedies mentioned in the Sushrut Samhita. And by preferring the reference papers for the getting their bioactive compounds which are presenting that remedies for that diseases. So next is the methodology, in which first is the disease and gene selection. So in which we focused on the disease which described in Sushrut Samhita such as tuberculosis, eyes disorders, colic diseases and the leprosy, which associated genes were identified from the database like NCBI Uniprot for the and for the further interns their gene receptors were selected. Next is the bioactive compound selection. So in which compound like beta carotene, vitamin K, riboflavin, many extracta related to that remedies extracted from that Ayurvedic formulation described in that text of the Sushrut Samhita and validated using the PubChem. Next step is the molecular docking. So in which we build the 3D model of gene receptor using the Swiss model tool, and validation was performed with Ramchandran plot to ensure the structural accuracy. Sorry. So in which through the Ramchandran plot we get that the which section or the area are more suitable for that gene receptor binding with their bioactive compounds, and then the bioactive compounds were converted to the SMILE format and docked using the GramX software. So the result were analyzed using the PyMol, which focusing on the binding energy and the amino acids interactions. So here is the result. So in which first is the docking result. Actually, there are I am taking almost 5 diseases with their about 2 gene receptors. So the docking result were so much images. That's why I am not able to show here. So I am putting here the docking result table through their interaction number and the amino acids and the binding energy. So in the tuberculosis, you will observe that the actually tuberculosis known as the eczema in the Sushrut Samhita. The text recommends the goat's milk ghee, which contains the active compound like beta carotene, tocopherol, and lauric acid. So here we are selected the vitamin D gene receptor, which plays the role in the immune modulation. So in this docking result, you observe that the beta carotene had the strongest binding energy of above the minus 158 kilocalorie per molecule interaction with the amino acids like given here, and the tocopherol, which shows the 9 significant interactions which suggesting their potential as the therapeutic agents. So in the Gramax, there is the levels for the energy binders, such as the high affinity binders, each ranges about to minus 200 to minus 100 kilocalorie per mole, and the moderate binders are about to the minus 100 to 50 kilocalorie per mole, and the most weak binders are such as the minus 50 to minus 10 kilocalorie per mole by referring. So here next is the eye disease. Here we are taking particularly the diabetic retinopathy from this. So which shows that which also shows the suitable binding energy with the interactions of bioactive compound with the gene receptors such as AKR1B1. So here in the Sushrut Samhita, which described the treatment for the various eye disorder using the raw milk butter, which focused means I focused on two conditions, like here is the diabetic retinopathy and next is the, here you can see the glaucoma. So this docking revealed that the phytosterol binds effectively to AKR1B1 with the binding energy of minus 143 kilocalorie per mole. So, and the vitamin K, which interacted here with other gene receptor for the glaucoma, that is the CPY1B1, shows the strong hydrogen bond. Actually, here I am showing the bond-wise also amino acid. Like here is the interacting amino acid with hydrogen bond, and here is the interacting amino acid with hydrophobic bond. So here next is the colic diseases, in which actually colic disease is caused by an imbalance in the Vata dosha as mentioned in the Sushrut Samhita. So manifest as a severe abdominal pain. So the Sushrut Samhita recommends that the regular milk for its soothing properties also. So here we are taking one inflammatory bowel disease, which gene receptor is ATG16L1, which are also giving positive binding energy with the bioactive compounds here are showing. So in which vitamin B12 had the strongest binding energy, which is the minus 233 kilocalorie per mole with that gene receptor ATG16 L11, and next is the riboflavin and casein. Riboflavin and casein also exhibited the significant interaction actually, and supporting their inflammatory potential also. And here is the next hereditary hemorrhage disease of the, which is the also type of the colic diseases with their selected gene receptor and the selected bioactive compounds from that remedies. So here vitamin B12 also gives the highest binding energy, which is the minus 287 kilocalorie per mole, with also hydrogen bond and hydrophobic bond. Here you are seeing, observing that with the number of interaction is 6. And next is the randomly selected disease is that leprosy with the gene receptor. There are taking IM2 gene receptor, NOD2 gene receptor, and TRL1 gene receptor here. So in which uh, it is actually leprosy describes as Kushtrog in the Sushrut Samhita, which recommends the castor oil, which contains the compound like tocopherol, ricinoleic acid, and tocotrienol. So here also we got the some positive results with their binding energy and the interacting of the amino acids with the interaction numbers. So phytosterol, which demonstrated strong interaction, uh, sorry, the triricinolen, which gives the highest binding energy, that is 216 kilocalorie per mole, with also hydrogen bond and the hydrophobic bond of the amino acids. Here is the second one, that is TRL1 gene receptors. So which is also gives the positive result in this. So in which the also the tri Ricinolen also gives the almost above same the binding energy, that is minus 228, with the number of interaction actually here is 0. But the main is the if the binding energy is high but number of interaction is 0, then we consider the second one bioactive compound for the higher interaction with their receptor. So there is the phytosterol, which is binding energy is minus 141, with actually it gives only the hydrogen bonds here, not hydrophobic bond, with the one amino acid. So, and the next is the chronic fever, uh, in which actually it is mentioned as Jirn Javar in the Sushrut Samhita. So, where the Ayurveda recommends the milk-based therapies also here. So, here we selected the MEFV gene receptor from the NCBI for the interacting with the bioactive compounds.
Please conclude. Please conclude first.
What, sir?
Please conclude fast. You have already crossed the time.
Okay, sir. So here we also see the positive binding energy result with the vitamin B12, that is the minus 249, with the hydrogen bond and hydrophobic bond. So let's go to the conclusion. So in the conclusion, I can say the finding demonstrate that the potential of Ayurvedic formulation, in which like tuberculosis, we see the beta carotene and the tocopherol showed strong immune modulation effect. And in the eyes disease, the phytosterol and the vitamin K highlighted their role in the ocular health. So, and the colic disease, which the vitamin B12 and riboflavin exhibited for their anti-inflammatory properties, as mentioned in the PubChem. So, and last is the leprosy and chronic fever. The compound like tocotrienol and casein supported for the traditional remedies. So this underscores the relevance of Sushruta Samhita in modern drug discovery and validating its holistic approach with the computational tool. Last I can say that the molecular docking validated their efficacy for the bioactive compounds from the Sushruta Samhita for several diseases, and these findings bridge the traditional medicine with the modern pharmacology. Here is the significance of project. And the future direction, I can say the experimental validation of these findings will be concluded, and integration of Ayurvedic insight into mainstream healthcare practices. So this research is highlight the potential of combining the ancient wisdom with the modern science and innovative and integrative the healthcare and the solution. Here are the references which I prepared during my research studies. Thank you. Is any question? Hello?
Are you done with both of your presentation, Vaibhavi?
No. Can I start second one?
Conclude fast.
Okay, sir.
I think you took 15 or 20 minutes.
Okay, sir. So here is the next topic, that is the uh, uh, based on the natural language processing for the knowledge extraction from the Sushruta Samhita. I am Vaibhavi Jain from the MSc Bioinformatics second year PG student. This research project were done under the guidance of the Dr. Prinan Bakchi and from the Institute of MGM University, Institute of Biosciences and Technology. So, it gives me a great pleasure to present you today the project which unites the modern technology with traditional wisdom from our past. This project centered on the applying NLP to extract knowledge from the ancient wisdom text of the Sushruta Samhita by using their NLP steps or methodologies which are given in this research. So, its treasure trove of knowledge encompasses various aspects such as health, disease, and well-being, etc. So, NLP is like teaches computer our human language for interpret and generate in our human language. It's like teaches computer human language for the interpret. So NLP is a revolutionized way in which we interact with computer using the textual data and making it possible to extract meaningful knowledge. So the project essence is the convergence of ancient wisdom and the modern technology with
Your
goal
PPT is
of.
not there, Vaibhavi.
Yes, sir.
You're not presenting your PPT.
Actually, I am presenting, sir.
We are not able to see your PPT.
We are seeing the first screen on last screen of the
last one, previous one.
Okay, sir. 1 minute. Now is this visible?
Yeah.
Hello?
Go ahead. Go ahead and conclude first. Go ahead and conclude first.
Okay, sir. And methodological approach in which by following this methodology, we can systematically extract, analyze, and interpret the knowledge of Charak Samhita using the NLP technique, and the interdisciplinary impact in which project extend across the multiple field, including the medicine, computer science, health, and linguistic, etc. So by bridging the discipline, promote holistic approaches and to the healthcare and cultural heritage preservation.
So here is the objective, in which first is the interactive query system, which the introducing the concept of PAN, the interactive query system that allow user to search text and get relevant information from the Sushruta Samhita. So next is the text preprocessing, in which it is the transforming raw text into the suitable format for analyzing text. For example, part of speech tagging, tokenization, etc. And last one is the knowledge dissemination, in which uh, by using interactive query system or making it suitable in the platform, where we can extract the information and digitize the text and preserve it for long term. Next, material and methodology. So in which Charak Samhita text serve as the material for knowledge extraction, and the NLTK tool is the natural language toolkit is used for processing the text. Here is the methodology. First one is the conversion of PDF to image folder of Sushruta Samhita. Second one is the read image from the folder and extract text from the Sushruta Samhita. Third one is the name entity recognition and using the NLTK tool. Fourth one is the part of speech tagging. Fifth one is the information extraction, and sixth one is the interactive query system. So let's see with the result. Here is the result of the converting PDF to images. You can see here I applied the machine learning code for the Sushruta Samhita. Second one is the after converting image, it read the text and extract the text from the Sushruta Samhita, which is text is available in the Sanskrit and Hindi. So in which the library is used as the test-write OCR and the library CV2 OS module through this NLP techniques also, and NLTK tool also. So next one is the name entity recognition result. You can see here the with the help of name entity recognition is detect the text and categorizing the important, in which we can identify the name entities such as medicine, herb, treatment, and exercise, etc. Second one is the part of speech tagging. So in which by applying part of speech tagging, it assign the grammatical categories to the word, aiding in the analysis of the sentence structure and semantic, like study of the meaning of the languages, in which text classification is also a process of categorizing the text from the Sushruta Samhita. So next is the by preparing the queries, interactive query system. Here we extract the disease related information, in which I search the disease, hemorrhoids disease. Here we are actually typing in the Marathi for that getting that disease information, and through this applying the NLP's methodology, we are successfully extracted the text related to that diseases. And second one is the result of the tuberculosis, which is known as Kshay Rog in the Sushruta Samhita. Also extracted related the text and their remedies of the diseases. And here is the conclusion, in which our project on the knowledge extraction from the Charak Samhita using natural language processing is the treatment to the synergy between the ancient wisdom and the modern technology. By using the Django framework and digitizing these texts help to preserve them for the future generation. And the scope, it contributes to the medical research by providing insight for modern healthcare from the Ayurvedic wisdom. So preserving, in which aids in the preservation and digitizing of the ancient wisdom and enhancing their accessibility and the understanding. Last one is the facilitating the creation of educational resources and promoting the interdisciplinary collaboration in the healthcare. Here are the references which I prepared during my research study. And what is this happening? Sorry. I extend my gratitude to the mostly Dr. Pranav Bakchi and my collaboration at Indian Institute of Biosciences and Technology for their invaluable guidance and the support. Thank you.
Thank you, Vaibhavi. Is there any questions? Judges and participants?
Actually, I want to show you my previous work related to this Sushrut Samhita, which on the Charak Samhita. Actually, we developed the application or the website.
Vaibhavi, we can't see your screen.
Actually, I'm saying that I want to share you my previous work related on the Sushrut Samhita using NLP, which on the Charak Samhita, where I developed the website for this. I can share here. 1 minute. One minute, I am sharing you here. Actually, I prepared the website for this name as the ayurvedpedia.in for the Charak Samhita, and we are also going to involve the Sushrut Samhita in this also. Here we also develop one thing. Here we can give input in the English also and take the information about that diseases, like here you can see the diabetes also mentioned in the Charak Samhita, which named as the Madhumeha. All of you can see the slide or the screen.
Yes, we can. Go ahead, Vaibhavi.
So here you can see the text related that diseases were extracted, or their remedies also here in the mention in the diseases. You can see here. Again, next one we can try that. In the result, I am as giving the tuberculosis. So here is the tuberculosis is known as the Yakshma in the Charak Samhita and Sushrut Samhita both also. So you can see here also the output is coming with the relevant information and their remedies. Thank you. Is there anyone question?
If nobody has no question, I would like to give the time to Brendan, sir.
Satish sir is having question. Yes. Sankesh sir?
Yes, sir.
Sankesh sir, you are trying to speak something? Okay. Okay, continue. Continue, Jamima.
Okay, thank you, sir.
So the time is all yours, Brendan, sir.
Sorry? There is one more participant.
Sir, she didn't join yet.
No, Pita has not joined. I think one more person, last person. Please call the last person. Navya Raj.
Yes, sir.
Over her
Sir,
colleague.
Prithvi is online only.
Yeah, Prithvi, please, you can go ahead with the presentation.
Yes, yes, sir. Is my screen is visible?
Just go ahead.
Yes, it is visible.
Okay, my name is Prithvi from the Department of Biochemistry from Padma Shri Institute of Management and Sciences, Bangalore. And our topic is in silico study of Syzygium cumini components with HMG-CoA reductase for potential anti-obesity effects. So we know that most people are suffering from obesity, which is now a worldwide health problem, and too much of bad cholesterol in blood can increase the chances of getting heart diseases. So to prevent all this is inhibition of HMG-CoA reductase activity is the proper approach to find the potential anti-cholesterol agent. Actually, we did in vitro and in silico studies for our study for this. And the main objective of our study was to evaluate the anti-cholesterol activity in extracts from the leaves, seeds, and pulp of Syzygium cumini. Coming to introduction, we know the Syzygium cumini, which is commonly called jamun. It is a tropical fruit with a notable medicinal properties, particularly in cholesterol management. This in silico study explored the anti-cholesterol potential of its bioactive phytochemicals, which targeting HMG-CoA reductase, a key enzyme in cholesterol synthesis. The finding highlights Syzygium cumini as a promising plant-based therapeutic agent for managing obesity and also related diseases. In this in silico study, we used phytochemicals components of Syzygium cumini as ligand, and it was docked with HMG-CoA reductase, which is our target protein, to find anti-cholesterol activity. This was compared with the positive control, which we have taken as simvastatin, which is a anti-cholesterol drug. In our study, first we have identified the phytochemical structures. Phytochemical structure. The phytochemical components of Syzygium cumini were carried for structural identification study using PubChem database. Here, we check the violation for each components, and the zero violation components were chosen as ligand for our study. And similarly, we collected the 2D and 3D structure and PubChem ID of the simvastatin. And these parameters were checked with the drug or data bank base also. And next the identification of Lipinski rule of 5. We know that it's the rule of thumb which describes the drug to determine a molecule. Actually, this rule helps to determine if a biologically active chemical is likely to have the chemical and physical properties to be orally bioactive. So, to make a drug orally active, they should follow certain rules. Here are some rules like the molecular mass should be less than 500 Dalton, and hydrogen bond acceptor should be less than 10, and hydrogen bond donor should be less than 5, and log P octanol water partition should not be more than 5, and the N violation should be 0. So in our study, based on the Lipinski rule of 5, or positive control simvastatin and phytochemicals like dihydroquercetin and gallic acid, ellagic acid, camphorol, quercetin, and micamnose and tetradecanoic acid compounds are not violating the rules, and hence the remaining 9 compounds. Actually, we have taken 16 phytochemicals here, and remaining 9 compounds do not obey the rule and hence are not chosen as ligand. Next, we have done pharmacokinetic studies. So pharmacokinetic study, it provides important data on the behavior of molecule within the organism. These parameters helps to establish bioequivalence in between formulation and to understand toxicology drug exposure. For this study, we used Swiss Adam database. The ligand molecule of the phytochemical and drug components were checked with the pharmacokinetics activity that includes E-log value, GI absorption, blood-brain barrier permeability, and bioavailability score. If a compound is to be accepted as ligand, the E-log value should not exceed 6 and should be soluble. And it should be soluble. The GI absorption, it refers to the process by which an unmetabolized drug is transported from the site of administration and into the bloodstream through the gastrointestinal tract. The normal permeability of blood-brain barrier protects the brain by preventing exposure to molecules that are harmful to peripheral organ but toxic to neuron. So this describes how the body affects a specific chemical or a drug after administration through the mechanism of absorption and distribution. By applying pharmacokinetic principle to per clinical trials, safer and accurate clinical trials can be designed. Hence, here we can see, here the result shows that positive control simvastatin is moderately soluble and macamino's is highly soluble, and rest are soluble and poorly soluble. And the gastrointestinal absorption of a phytochemical components were recorded to be high in simvastatin and dihydroquercetin, ellagic acid, camphorol, quercetin, mycaminose, and tetradecanoic acid, and delphinidin. So here, except tetradecanoic acid, all were recorded. All were recorded not to cross blood-brain barrier. We can see here only tetradecanoic acid is crossing blood-brain barrier. And from this report, bioavailability score of phytochemical components were noted to be 0.55 in simvastatin, and dihydroquercetin, ellagic acid, camphorol, gallic acid, quercetin, mycaminose, and beta cytosterol. A neutral organic compound to act as a good oral drug, it should satisfy Lipinski rule of 5, and the bioavailability score should always be 0.55. So in this study, we selected the target protein as HMG-CoA reductase. The sequence of HMG-CoA reductase was searched, and the faster sequence was downloaded from the PDB database. And then through the Swiss model database, the PDB format of the target protein was developed. Actually, here we can see the structure of HMG-CoA reductase. Here the PDB ID, that 1HW8, it represents the crystal structure of the HMG-CoA reductase. And it's the Z-score value of HMG-CoA reductase. Here we can see that QMEAN value is minus 0.32. Here that increase in the QMEAN Z-score value means the better agreement with the predicted features. At last, we have done the molecular docking of the our ligand with the target protein. The selected phytochemicals like gallic acid, dihydroquercetin, camphorol, quercetin, ellagic acid, and mycaminose, tetradecanoic acid as ligand. Out of 16, we have taken only these phytochemicals because the rest of them were showing violation more than 0. So along with simvastatin, we have taken this and were docked against target protein HMG-CoA reductase by using CBDoc software tool. The active site of the target protein where the ligand bound and its structure with docked amino acid residues was retrieved from CBDoc software tool. The result includes binding score, which is also called Vena score, and amino acid of the respective protein ligand complex. Here we can see the docking score represents the binding affinity of target protein and ligand. Here we can see dihydroquercetin, ellagic acid, and quercetin showing the highest docking score, which means they have high binding affinity with the target protein. From this result, it is revealed that the phytochemicals like dihydroquercetin, camphorol, ellagic acid, and quercetin have more potency with the HMG-CoA reductase compared to simvastatin. These are the docked amino acid residues of target protein, HMG-CoA reductase. So in conclusion, to conclude from our study, the key phytochemical like dihydroquercetin, gallic acid, ellagic acid, camphorol, and quercetin showed superior binding affinities for HMG-CoA reductase compared to simvastatin in molecular docking studies. These compounds obey Lipinski rules and ensuring favorable bioavailability and drug likeliness with optimal gastrointestinal absorption and minimal central nervous system toxicity risk. So overall, Syzygium cumini extracts, particularly those from seeds, leaves, and pulp that we have taken as sample, hold considerable promise as natural agents for managing hypercholesterolemia and enhancing cardiovascular health. The identified bioactive compounds, especially dihydroquercetin, gallic acid, and camphorol, are promising candidates for developing new therapeutic strategies for cholesterol management. In future, in vivo studies are warranted to confirm these findings and assess the clinical applicability of Syzygium cumini in hypercholesterolemia treatment. And these are the references. Thank you.
Thank you so much. So is there any questions? Okay, so now we'll end the meeting, and I would request you all to join back again after 10 minutes for the results.
Or Satish sir, Sankesh sir, you want to share something?
It was a very nice opportunities for all the presenters. You have conducted the fourth international conference, and it was being online. Everybody was able to give the time, and more number of participants were benefited with this. I think heartiest congratulations to you and your team for successfully doing this conference. We have got new areas where the research can be done, and so many students have given very good presentations also. So definitely that will also help other students, to those who were attendees, to know the other areas. So that is what I think, and that is what the purpose of conference is there, to have the interaction and exchange of the knowledge is what the basic purpose is there, and I think that is being solved by this conference. That's it.
Okay, thank you, sir.
Yeah. Do we have to meet again?
No, sir, you can share the details. You can announce, you and madam can announce the winners maybe after 10 minutes.
Okay, so we will have to wait for 10 minutes.
Yeah, you can maybe you can stay logged in, and after 10 minutes you can announce the results, you and madam, because you both have taken the headache. Actually, I will say headache to judge everybody. So both of you can, I won't say stay back, rather you can
Yeah,
announce it.
if everybody
So
leaves,
that we
then
can
we can,
conclude in another 10 minutes.
if the participants can leave the.
No, no, let them stay back. Anyway, people who are not here in the group, we are messaging to all to join back in 10 minutes so that
Okay.
we can announce the winners and close for today. We can take a group photo and we can close it for today. Okay, welcome back, everybody. So before we announce the results, can we take a picture of yours? Everybody can please switch on your videos. Everybody please switch on your videos. Everybody please switch on your videos. Others? So please switch on your videos, everybody. Others? Prithvi, Sukanya, Rajat, Akash, Savita, please switch on your videos. Srikanya, Akash, Savita, please switch on your videos.
Sir, my camera is not clear. Yeah, that's why I'm not
Okay.
switch on.
Okay, fine. You can put your videos off. Satish sir, will you please take the privilege to announce the winners?
Thank you, sir. Thank you for giving me an opportunity once again to announce the winners. So we have 3 judges panel, and they have judged based on their presentations, the content, and the innovations. So based on these 3 parameters, first of all, I will write to congratulate all the participants. We have given the parties appreciation certificates for 3 of the students. So first being Omkar Angre. So congrats to Omkar. Then Rajat Pandey and Jivan Pralad Tonde. So they have got the appreciation certificates. On the list of the papers, the 3rd prize is given to Anirudh Biswas and Dr. Rupali Taur. So Shreya Parhume is also there?
Yes, sir. She had 4 papers. One of the papers was judged.
Okay. So one of the papers that was network-driven drug repurposing insights from the graph neural network and recommendation model. That has got the 3rd prize. So congratulations to all the 3. The 2nd prize, or I can say the 2nd one, is with the Akash Ajay Chaudhary and Jeet Mondal. So congratulations to Jeet Mondal. I think Jeet is there.
Yes, sir.
Yeah. So congratulations to you.
Thank you, sir.
Yeah. And the first prize is with the Srikanya Roy, Jain Vaibhavi, and Ravindra Prithvi. So I think Prithvi is also there.
Yes, sir.
Yeah.
Prithvi is there. Yeah, Prithvi is there.
Prithvi is there. So I don't know whether Vaibhavi is also there. So
Yes, sir.
yeah. So heartiest congratulations to both of you. In addition to Srikanya, Roy is there, but I don't know whether she is
Yes,
present
sir.
or not.
Thank you, sir.
Yeah, she is also present.
Thank you, sir.
Congratulations to all three of you for getting the best paper award. And once again, thanks to Pranav sir. And that's all from my side, sir. And now it's up to you.
Okay, sir. Thank you so much. And thank you all the participants for making the event highly successful. We thank the speakers, the morning and the afternoon presenters, as well as our judges, Dr. Satish Sankai and Dr. Dhanalakshmi Madam. So shortly we will be sending the certificates to all, and very soon we will be calling for the book chapters. So you will be receiving a mail regarding the same. And as it is an annual conference, our next conference will be again held next year, almost the same time in December. So see you all. Till then, take care, everybody. Bye-bye. Good night. Have a nice time ahead.
Thank you, sir.
Yeah, thank you, sir. Congratulations on all the participation.
Thank you, sir.
Yeah, thank you.
Thank you, sir.
Yeah, thank you, everybody.